Next and after that we are going to discuss about pointers. So operators and expressions, control structure, arrays, pointers, followed by functions. Next and after that we are going to cover character array. That is nothing but string. Character array, that is nothing but string. Next and after that we are going to cover about storage class and data types. Storage class and data types. Next and after that we are going to discuss about structure, union, enum, and type def. Next and after that we are going to discuss about the preprocessor. Next and after that we are going to cover the files. So these are 11 chapters which we are going to discuss, but as I said, not from scratch. Assuming that you have the knowledge of C programming language, MCQ with respect to these concepts will be discussed. At least 200 MCQ I am going to cover throughout this session, throughout the duration of the course. And while discussing those MCQs at any stage with respect to any particular chapter, if I found that you are not having the knowledge, then that particular part I will discuss and then take those MCQs. Other than that, everything will be discussed at runtime. Discussion at runtime means, suppose whenever I will start a discussion about operators and expressions. Now under C programming language, we are having so many operators: arithmetic operator, relational operator, logical operator, bitwise operator, special operator, increment, decrement operator. So many operators are there. So it will be not be like a C session where first operators will be taught and then MCQs will be taken. No, directly from the beginning MCQs will be taken. And while the clarity with respect to that particular MCQ, how to get the output with respect to that particular MCQ, while giving the lecture based on that at runtime, at that time, for that operator, whatever necessary information will be needed, that I will provide to you. That's why I said that the prerequisite to attend this session is that you must have a C programming language. At least it is not required you have to be master of that C programming language, but at least if you have basic idea, then I will be able to work on that thing. Along with that MCQ, there are some tricky interview questions are there, which generally ask at the time of interview. So those type of questions also I will cover as a part of the course. Duration of the course will be 45 to 60 sessions, right? Initial 5 or 6 days, though they will mention it as a demo session. It's a demo session to you people. To me, it is not anymore a demo session, because from today only I will start discussing everything. So demo session is separate, and then again the session will be start freshly. Not like that. Session is going to start from today only. It's for you to decide whether to continue with the course or not. For that, it is the demo session. Now, if you feel that it is good for you, it will be helpful for you, then you have to join the session by registering to that Durga soft, right? And once your joining will be completed, then everyday note, running note, whatever I will discuss, whatever is the necessary thing, that I will provide you in a Google Classroom. But today Google Classroom will not be created. Once you become a registered member, then the Google Classroom will be created, and I will start the sharing the notes. Initial 4 or 5 classes, as it is a demo session, no note will be shared. You can take the picture, you can take the note parallelly at a runtime also. But once your registration process will be completed, then I will share everyday note. Now from the Durga Sub point of view, they will share the everyday lecture video. That means if you miss any session, that session will be there in your mail ID, in your what is called that Google Drive. Those videos will be shared from there. From their side, they will definitely share those videos, right? So these are the things that is going to be provided as a study material. That is the video and the runtime notes, as well as any note that will be necessary for understanding any particular topic. Recorded video will be sent. No need to worry for that. Okay, Vijay, Viraj. Viraj, if you want to join that data structure batch, what you can do is that, as you are showing interest to join in that data structure batch, you can directly contact to Durgasoft, right? They will guide you how to join the batch, because already the session has started. If you want to join, you can join, but in that case, all the recorded videos, whatever already discussed, you have to go through those videos, right? You can join there. Ritik, yes, you also can join, but for that you have to join. You have to contact to Durgasoft only. That the course duration for that data structure is say 2.5 months. Already 1 month, close to 1 month is over. Another, not 1 month, few session have been done. 15 or 16 session have been done. Now it's continuing, so you can join, but in that case you have to make it up by watching those videos, and for that you have to contact Durgasoft. They will guide you. Okay. Yeah. So let me start today's session. Let us take the first problem set, first example. Now, in this first example, say for example, I'm writing here printf. Now, it will not be like all other session where you will not respond, just silently watch those videos. No, because it is for interview preparation, as well as it will be for practice session. So what you have to do is that you have to be responsive. You have to, whenever I will ask the question, you have to respond in the chat box. Forget about the correct answer or wrong answer, because even if you're giving any wrong answer, no need to worry, because I'm not going to scold you. I will make you correct. But if you're interactive, if you're giving the wrong answer, then automatically next time when the same type of question will appear, you will definitely make it correct. But if you are not giving the answer, just silently watch like a YouTube videos, then automatically what will happen? You will not make the mistake now, and at the time of interview, there you will make the mistake. So that's why my suggestion is always try to be responsive and try to give answer in the chat box. Let us take the first example. Printf. The value is equal to percentile D, and here I'm writing 20 plus plus. This is my code. Printf, the value is percentile D, 20 plus plus, and my options that are available here is one is 20, one is 21, one is compile time error, and another is runtime error. Tell me, students, what will be the answer in this case? Everyone, forget about correct or incorrect. Just make a habit of responding, and then I will make you correct. Yes. See here, in this example, the operator that I used here is plus plus. So plus plus means what? Plus plus means it is a increment operator. It is a increment operator. Now increment operator, what it does? This is the symbol. Increment operator, what it does? It increments the value by 1. It increments the value by 1. That's the role of increment operator. Now, how many type of increment operator we are having? We are having two variation of increment operator. We are having two variation of number one is pre-increment. Number one is pre-increment and number two is post-increment. This is the variation we are having. This is about the increment operator. Similarly, we can have decrement operator too. Plus plus is increment operator. Decrement operator means it will be like minus minus. There also we are having two different variation. Post-increment, like pre-increment, post-increment. They are also pre-decrement, post-decrement. Now, what about the working principle for pre-increment and post-increment? Pre-increment means first it will be incremented and then with the updated value it will work. Post-increment means it will use the original value in the expression. Later, before moving to next line, it will increment the value. Now, in this example, what will happen is that normally another restriction is there. What is the restriction? The restriction of pre-increment or decrement operator is it can be applicable. It is applicable. It is applicable only to the variables. It is applicable only to the variables. This is the restriction of the increment operator. Now observe here carefully. 20 plus plus. 20 plus plus. The question here is 20 is a variable? Is 20 is a variable? What is the answer, guys? Do you think that 20 is a variable? 20 is not a variable. What is 20? 20 is a constant. 20 is a constant. What is the rule of the increment operator? It is applicable only to variables. Are you applying it to the variables? No. You are applying it to the constant. What is the drawback of applying it to the constant? Suppose, for example, if I assume that 20 plus plus is true, you know that plus plus means it will be incremented by 1. I said that already. So if 20 plus plus is true, if I assume that 20 plus plus is true, then it means 20 is equal to 20 plus 1. Tell me, guys, is it possible 20 is equal to 20 plus 1? No, sir. 20 is equal to 20 plus 1. No way it is possible. That is why if I compile this code now, 100% I am going to get a compilation time error, because the mistake that I am doing is I am not incrementing any variable. I am incrementing a constant. Constant cannot be incremented. 20 means 20 only. You cannot have 20 plus plus. If you have a variable x is equal to 20, then you can have x plus plus, because x plus plus means the variable. Variable can change. That's why the name is called variable. Why it is called variable? Because it varies. It can change. But constant means it should be fixed. It should not be changed at any time. That is why if I now go for compilation of the code, see this, execute, I'm compiling the code. What is happening? Some compilation error is generating, and see in which line the compilation error is coming. 1 minute, show that error also. See the line where error is coming, in this line, because this is where I made the mistake. And along with that, you read this, you read the error. Later I will give the clarity. What the error is telling? L value required in increment operand. What is the error we got? L value required. L value required. Let me copy this. What is the error it got? What error we got? L value required. L value required as increment operand. Sir, why this error is showing L value required? What is that L value, sir? Now listen carefully. This is which operator? This operator is known as assignment operator. Is known as assignment operator. Every operator must have some restriction. You cannot do it whatever you want. You have to follow those restrictions. Like increment operator having one restriction, na? It is to variable, but not to any constant or any expression. Similarly, assignment operator is also having a restriction. What is the restriction? On the left hand side of assignment operator, there should be a value not a constant. On the right hand side, you can have a variable, you can have a constant, no restriction. But on the left hand side, you must have a variable, not a constant. But currently, due to the 20 plus plus, it becomes what? 20 is equal to 20 plus 1. Are you following the rule of assignment operator? No. And the left hand side variable is called as L value. The left hand side variable is called as a L value. That is why compiler is giving the error and it is telling I required as a L value. I required as a L value as increment operand, because here whatever you are trying to increment, it is a constant. I need is a variable. L value means it is a variable which can change. L value means it is a variable which can change. Currently, due to your increment, internally it is the thing that is happening where I am not getting any variable. I am getting the constant. That's the reason of the error. That is why, with respect to this code, this is our question number 1. What will be the output of the following code? So, from these options, these are the options with respect to this particular question. So, what is the answer to this? Answer to this is option number C, compilation time error, and this is the explanation for this one. Tell me, students, anyone is there? Sir, I didn't get this. Everyone understood? Students, make respond in the chat box. Everyone got the clarity about this one? Yeah. Let me move to the next one. Yes, clear. Good, very good. Let us move to the next one. Int I, yes, int I is equal to 0. J is equal to 1. K is equal to 2. And M. Okay. Here I'm writing M is equal to M is equal to M is equal to I plus plus. This is called logical OR. Then I'm having J plus plus. This is called a logical OR. Then I'm having K plus. And then lastly, I'm printing everything. I, J, K, and M. All the values I'm printing here. Let me print. Here, M is equal to I is equal to J is equal to K is equal to. What will be the output in this case? What will be the output, guys? Okay, Prashant, let's see. Let us verify it once. What is the output? Suppose, for example, first of all, here, what about this operator, guys? This is known as logical OR. Here directly. This operator is known as what? It is known as logical OR operator. Now, logical OR operator have one rule. What is the rule? Suppose A, B, A or B. Now, what is the rule here? Very simple one. 0 or 0, it is 0. 0 or 1, it is 1. 1 or 0, it is 1. And 1 or 1, it is 1. Everyone knows that. This is the truth table for logical operator. But what is important point here is, observe carefully. This is where you have to focus. This is the important part of the logical OR operator. What is the conclusion that we can take from here for the logical operator? See, if the first operand, this is called operand, guys. A is an operand, B is an operand, and this is operator. So it becomes operand, operator, operand. How many operand is there? 2. How many operator is there? 1 operator. What is that operator? Logical OR, bar sign. Here the conclusion is, if the first operand, observe carefully, is the first operand is true. True means 1. True is indicated by 1. If the first operand is true, is there any need to execute the second operand? Is it meaningful to go for the second operand? No, no. Because whether the second operand is 0 or the second operand is 1, the result will always be 1, sir. The result will be always be 1. So just from these two lines, what we can conclude, if the first operand is true, second operand will not be evaluated. Second operand will not be evaluated. Why? Because as the final result will always be true. As the final result will always be true. That is why second operand will not be evaluated. But you cannot say this in this case. If the first operand is 0, can you tell the final result? No. Without seeing the second operand, you cannot see the final result. If the second operand is 0, final is 0. If the second one is 1, final is 1. So I have to check the second. But here, if the first operand is 1, sir, no need to check the second. And it is evaluated in that fashion also. They never execute the second part once the first operand is true for the logical OR operator. For the logical operator, once the first operand is true, they will never evaluate the second part. Now you see here, I++. Here, post increment. Post increment is what? Here the value will be considered as 0 for evaluation purpose. For evaluation purpose, here the value will be considered what? 0. So that means M will treat in this fashion. M is equal to, he will treat the value here as 0. But internally here we can me to work as 0. I got here as 0. But internally, before going to the next half, that means the second half, before coming to the next half, internally I will change its value and will become 1. I will change its value and become 1. That result will not come to me. That result will not come to me. That result will not come to me. Right? To me, the result that will come is 0. But internally, I will become 1. So once I got a 0 here, what is my feeling? Should I go to the next step or not? Yes, first operand 0 means second operand you have to check. So I am moving. Logical OR. Then what about this J? Sir, J is 1. So here what value will be considered? 1. Here what value will be considered? 1. Then plus. So that means what? Internally, J will become what? What is the original value of J? 1. So internally J will become what? 2. Internally J will become 2. Now M is equal to 0 or 1. Now you see there is another logical OR operator is there. That is basically for K++. That is basically for K++. Now, in case of the operator, whenever you are evaluating any expression, with respect to operator, a very important concept is there. What is that concept? that concept name is operator precedence and operator associativity. Without having the knowledge of operator precedence and operator associativity, we cannot evaluate any expressions. Without having the knowledge of operator precedence and associativity, we cannot evaluate any expression. Then automatically the question will be raised, sir, what is known as operator precedence and what is known as operator associativity? First precedence followed by associativity. Now precedence determines the order. Precedence determines the order in which the expression will be evaluated. Precedence determines the order in which the expression will be evaluated. For example, if you carefully observe here in this particular example, whatever I have taken here, if you carefully observe here, my expression is 5 plus 10 into 2. So if I ask you what is the value of 5 plus 10 into 2, immediately you will say, sir, it is 25. But is it 25 in your own choice, or it is getting that 25 logically? It is getting that 25 logically. How you are getting that 25 logically? Very simple, sir. See how many operators are present here? 2 operators. Plus and multiplication. Plus and multiplication. Between that, who is having high precedence? Sir, multiplication is having the high precedence. If multiplication is having the high precedence, is it the factor I am telling you multiplication is the high precedence and you started believing that as I said multiplication is having the high precedence and multiplication is having the high precedence? No, no, no. There is a rule is there. What is that rule? Precedence and associativity rule. Is it my own rule? No, no, no. It's predefined rule. Now, if you check that precedence and associativity chart, I will give you the clarity that of the chart slowly. But just for today, observe here carefully. In this chart, you see where is the multiplication. Sir, there is the multiplication. Their multiplication is present. And where is the plus? Here is the plus. Who is having high precedence? Multiplication is on top of the plus now. So multiplication is having high precedence compared to plus. Multiplication having high precedence to plus. That is the reason in this expression you are telling, sir, the answer will be 25 because multiplication precedence is higher. That's why 10 into 2, 20, 20 plus 5 becomes 25. Then what about associativity, sir? Associativity means, suppose in an expression, guys, suppose I'm asking you, simply I'm asking you 5 into 4 by 2, what is the answer? Then you will say, what is the answer? 5 into 4 by 2, definitely the answer will be 10. I know that, but I have a question here. What is my question? Is it 5 into 4, 20 by 2? That's why is it 10? Or my question is it the factor 5 into 4 by 2? That is why it is 10. Because if you say, sir, 5 into 4, 20, I will do 20 by 2, 10. Yes, 10. If someone say, no, I will do 5 into and then 4 by 2, I will make it 2 and then 5 into 2, I will make it 10. So anyhow, answer is correct. If you say 10 as the answer, answer is correct. But the question is, which is the process to get that 10? Which is the process to get that 10? First, you observe here, how many operators are there? 2 operators, multiplication and division. Then what I have to do? Sir, I have to go to the precedence associativity table. Let's go there. In the precedence associativity table, check it out. Multiplication and division, they are in the same block. Same block means same precedence, guys. Don't think sir wrote multiplication before that division and then division is written before that modular division. That's why multiplication is having high precedence. No. I can write these 3 in any order. But in a same block means they are having same precedence. All these 3 are having the same precedence. Different block means precedence is higher compared to this. Now this fellow is having high precedence compared to this. But whenever you are in a same block, that means all of them precedence are same. Doesn't matter how I wrote. Precedence are same in a same block. Once precedence are same, you have to go for the concept that is known as associativity. What is the concept, guys? Name of that concept is associativity. The name of that concept is associativity. This is associativity, right? Now, associativity can be 2 types. One is left to right, one is right to left. Now, for multiplication and division, if you see the associativity, the rule is left to right, guys. The rule is left to right. Now, that is why, sir, if you ask me, both of the answer is giving me 10, but which one is the correct? Sir, I found here associativity. Because why you are going for associativity? Because multiplication and division both are same precedence, sir. So which one will be first evaluated? I don't know. Then you have to go for associativity. What is the associativity? Left to right. That means first this part will be evaluated and then that result will be divided by 2. That means, sir, first will be done 5 into 4. 5 into 4 equal to 20. Now that 20 will be divided by 2 and hence the answer is 10. So if anyone think that, sir, 5 into and then 4 by 2 is 2, that's why the answer is 10. That is incorrect. That is incorrect. Just for this example, you may get the correct value. If you take a different set of values, you will get a wrong value if you thought in that direction. The correct direction is following the rule of associativity, which is from left to right. Similarly here, guys, why I'm discussing this left to right concept. Now, similarly, if you see here, how many logical OR is there? 2 logical OR is there. Can you make the comparison between their, can you compare them in terms of precedence? Sorry, in terms of precedence, I cannot compare. Then what you have to see? Sir, I have to see the associativity. Let's see the associativity of logical operator, logical OR operator. The associativity of logical OR operator is left to right, guys. Where it is, sir? Here. Check it out. This is logical OR operator and associate. Later I will tell you how to remember the entire chart. No need to confuse and no need to thought like that. Sir, such a big chart every time. How can I remember from where I will get that chart? I will give you a shortcut. By that, very easily the entire chart you will able to remember. No need to worry for that. With time you will get that. Now you see the logical OR operator is what? Left to right. Left to right. Now what will happen, sir? First of all, here I am having 2 logical operator. 0 or 1. Associativity is left to right means, sir, this part will be first evaluated. This is one part. Now this part, this is one part and this is another part. This is one part, this is another part. Why you bracketize in that one? In that way, sir, associativity, na sir, associativity is left to right. That's why I have to make sure na which logical OR will work first. Then how can I determine? With the rule of associativity. Associativity is what? Sir, associativity means in the absence of the bracket, how the expression will be bracketized. That is followed by the rule of associativity. What is associativity? In the absence of the bracket, how the expression will be bracketized. Oh, that is why you are bracketized in this fashion. Yes, sir. Then, sir, I will bracketize again this portion of this. The entire thing I am bracketized. Why you are bracketized in this fashion? Sir, left to right I am going na, sir, because the rule is itself left to right. Now you go for it. You will remember, in our country, evaluation always starts from left to right. You may bracketize the expression following the rule of left to right, right to left. That is just the bracketization will be done, not the evaluation. In our country, we always evaluate from left to right, but bracketization might follow the rule of left to right or right to left as per the associativity is concerned. Now I started evaluating, sir. 0 or 1. 0 or 1. Sir, 0 or 1. What is that value, sir? 1. 0 or 1. Already you know na, boss? 0 or 1. What is that value? 1. So this part is giving you what value? 1. Now 1 followed by logical OR. 1 followed by logical OR. Tell me, students, will you show interest to go to this part? Logical OR operator. First operand is true. Will you show interest to go to the second part? Yes or no? Make respond in the chat box. Will you show interest in moving to the second part? No, sir. I will not go to the second part. Why? Sir, meaningless. If first operand is 1, result will be 1. Why should I waste time by going to the second part? That is why this second part will not be evaluated. That is why the second part will not be evaluated. As a result, what will happen? Sir, the K value initially was 2. Sir, K will persist with 2. K will still persist with 2. Now you are having 1 or something. 1 or something means what, guys? Total result will be what? 1 or something. Total result will be what? 1, sir. 1 or something means total result will be 1. Now to M, that 1 will be given to M. So now what will happen? M will get the value as 1. I is also 1. J is 2. K is 2. Let us verify it, guys. Intentionally, I didn't give you the option. If you think of the option, the options are like this. 1 1, actually if you make any mistake now, that will become my option. 1 1 2 3 is an option. Maybe you can think 1 1, because initially if I give you the option, then what will happen, you may find that sir, it's very easy to get the output. That's the intentional, I didn't show you the options. Sometimes I will not show the options. Now 1 2 3 3, let us assume these are the option. Now let's see, as per our clarity, which one should be correct, guys? B should be correct. 1 1 2 2 should be the answer. Let us evaluate. Execute, compile and run. See guys, M value is 1, I value is 1, J value is 2, K value is 2. That is what we predicted now as per the option number B. Everyone understanding? Everyone got the clarity? So this I think, I hope you people get an idea what actually we are going to do throughout the duration of the course. This is what we are going to do throughout the duration of the course. We will take the problem statement and see. I said, I will not discuss this from the scratch, but even I'm not discussing from the scratch. What is happening here? Whenever this operator is come into the picture, at runtime I discussed. Here also, increment operator at runtime I discussed. Here this logical operator also at runtime I discussed. So here it is, answer is C. Explanation, everything not possible to write here, but you will get the video, you will able to watch the video, and whenever you feel that you have to take note according to you, you will able to take the notes by watching the videos again. Otherwise, mostly important things I will add it here as a note. Okay, let us move to the next one. Yes, guys, this is the code. What will happen in this case? Yes, Modulina, your answer is correct. What about others? Yes, Ritik, your answer is also correct. Tithi, your answer is also correct. Okay, very good. See this one. Here, like the previous case, this time I will introduce logical AND operator. This is logical AND. Zero or zero is zero. 0 or 1 is 0. Yes, Prashad, your answer is also correct. 1 or 0 is 0. 1 or 1 is 1. This is the logical AND. Now here also you will take one conclusion. What is the conclusion here? See carefully. If the first operand is 0, see, immediately you'll able to make the conclusion. Sir, final result will be 0. Anywhere you need to check the second operand to make the conclusion? No. So if the first operand is false, second operand will not be evaluated, as the final result will always be false. Just the reverse of the logical OR. In case of the logical OR, if the first operand is true or 1, you will not check the second operand. In case of the logical AND, if the first operand is false, I will not check the second operand. This is one point we have to take here. Next is that associativity of logical AND is left to right. Associativity of logical AND is left to right. It is also for logical OR also it is true. For logical OR also it is true. Associativity of logical OR is left to right. Let me show you. See this, logical AND left to right, and this is, sorry, logical OR left to right, and this is logical AND. It is also having the associativity left to right. Okay. Now you see here, this is the part where we will show our interest, how to evaluate. Okay. How many logical AND is there? 2. And their associativity is left to right. Then how the expression will be bracketized? Sir, this is one part. Now this is one part. Assume that this is X and this is Y. Now you will have another part. This is this, how it will be bracketized. Now evaluation started. First come here, Y plus plus, post increment. So we will not consider the plus plus. What we will check? Y value. What is the Y value? 10. Y value is 10. Initial Y value is 10. So what actually checking I am here? What thing I am checking here? Is 10 is greater than 9 or not? Forget about plus plus now. 10 is greater than 9 or not? See here. What operator is used here? This is called a relational operator. How many relational operator is there, guys? In C, we are having 6 relational operator. We are having 6 relational operator. What are that 6 relational operator? Greater than, less than, greater equal to, then less equal to, then equal to, and then not equal to. These are the 6 relational operators we are having, right? Important point what you have to remember is that whenever relational operator works, we will get the value, we will get the result as 1 or 0. Whenever relational operator will work, we will get the result as 1 or 0. 1 in the form of true, 1 in the form of true, and 0 in the form of false. Whenever relational operator will work, we will get the result as 1 or 0 in the form of true or false. Now you come here, 10 greater than 9. What is the answer you are getting here? True. True means 1. True means 1. But internally, why change this value? To what? 11. But do you have any awareness now? No, internally it's happening. And you evaluated with what? 10. Is 10 greater than 9? 1. 1 followed by and. Will you go to this half? Will you show interest to go to this half? Yes, I will show interest. Because first operand is 1, na sir. That's why I have to see the second operand. Now you came here. Again here plus plus. Again means what? Plus plus means later I will think about that. First think about the current value of Y. What is that? 11. Is 11 is not equal to 10? Is 11 is not is equal to 10? Yes sir, it is a true value. 11 is not equal to 10. So what value you will get here? 1. But internally plus plus will happen now. That will make it to 12. Now what is this value here? 1 and 1. Sir, 1 and 1 is 1. 1 and 1 is 1. Okay, 1 and. Now you will show interest to the second half. Yes. Why? Because first part is 1, na sir. I will show interest to go to the second half. What is there in the second half? Oh, again Y plus plus. Na? First think about Y value. What is that? 12. Is 12 greater than 11? Is 12 is greater than 11? Yes, it is greater than 11. So what it will return here? 1. But internally Y will become what? 13. Internally Y will become what? 13. 1 and 1. 1 and 1 means what, guys? 1. 1 and then 1 means 1. Now come to the coding. Here the total part evaluated to 1. If followed by 1, we know na, if, when if works, if the condition part after if is a true, then if will work. Is the condition the yellow one, the blue one, this if block printf will execute, and what value it will print? Y. What is the Y value it should print? 13, sir. Let us evaluate it. Check it out. This is about the clarity, right, with respect to question. Like every day, 3 question, 5 question, that depends on the length of the question, and that depends on the important the question, what is the important thing I need to discuss. Based on that, number of question will be discussed. Sometimes if it is very easy question, maybe 10 questions. Sometimes so many internal things are there. 5 question, 3 question, 2 question, not 2 question, more than 2 will always be there. At least 3 to 5 question will definitely be discussed each and every day. Like this, today we have started completion of the operator. Like this, at least 3-4 days we will spend time on the operators. Look, actually it is not like a particular topic. Here though I'm talking about operator, if else is coming into the picture. That means what? Control flow is coming into the picture. So it is not possible to discuss with respect to a particular thing only, because all these things are mixed up. Whenever I am discussing about the operators, parallelly control structure will come into the picture. In future, whenever I will go to the array discussion, there are also some if statement, maybe there, operator maybe there. So that's why I said that prerequisite is knowledge of C programming language. And then whenever anything, mostly will have difficulties from here. Pointers, structure, storage class, there you may have difficulties. There first we will cover the theoretical part, whatever needed to discuss this MCQs, and then I will move further from there. That's it, guys. That is it for today's discussion. So note I'm not going to share from today. After few days, I'm going to share the notes. Data structure session is from 6 p.m. That 5 p.m. batch is moved to 6 p.m. now. Satyanarayana. That 5 p.m. data structure batch is not anymore from 5 p.m. That batch is merged with the 6 p.m. batch. Okay, students. Now, if you have any doubt, you can ask me. As because it is the first session, so next 5 minutes I will give you. If you have any doubt, if you have any query, now you can ask me. I think validity, video recordings will definitely be available. I think validity of the videos, I think you can contact to them. I think they give the validity of the video at least one year. Anything else you want to ask? Yeah, 45 to 60 days. If needed, if at runtime, because so many questions will be discussed at runtime, if it is needed, I will extend that. Mostly 45 to 16 days. If you need another 5 to 10 days, I can increase that. That depends on generally 45 to 60 days, but depending on a requirement, if query comes, if the questions are needed to discuss, I will increase that to another 10 to 15 days. Okay, thank you, guys. So our next session will be from Monday, exactly in 1 minute. Yeah, for data structure also everyday running notes are provided. Sir, I am a BAT programmer. I am building my logic strong. Yes, if you are a BAT programmer, no need to worry. Still you can join, because even you are a BAT programmer, all the basics, whatever needed to become good programmer, I started discussing now. Suppose, for example, before attending today's session, you are not having the knowledge of these many things. Which things? I discussed here how many operators? At least 4 or 5 operators I discussed now. Plus operator, multiplication operator, relational operator, logical operator, so many operators I discussed now. So even you are a bad programmer, at runtime you are learning na. Plus operator story today you have learned. Logical OR operator story you have learned. So again, logical AND operator story you are learning. Relational operator story I discussed here. So even if I consider you as a bad programmer, what is the problem? At runtime you are learning all these things na. So automatically what will happen? Once your basics are getting strong, because for learning any programming language, first prerequisite is that you must have to make your basics correct. If you make your basics strong, then learning a programming language will not become difficult. And that's why even if you are a bad programmer, whenever I will discuss, you have to do what? You have to make response. And if you have any doubt, you have to ask me, sir, this is where I have the doubt. That is where I have the doubt. But basic knowledge of C programming you must have. But still, if you are a bad programmer, that part I will take care of that. Because whatever doubt you will ask, I will give you the clarity. Okay, anything else, guys?
Hello, sir. I
Actually, you are not audible. So better if you type it in the chat box. I'm not getting the your audio is not coming as properly. So better if you write it in the chat box. Kajal, that thing will come only after you make practice, because programming language, no one will able to teach you how to develop the logic. Only thing that can be taught here is the syntaxes properly, and also how these things are internally work. Today I have given the clarity of how the logical OR operator works internally, how the logical AND operator works internally, right? How the plus operator works internally. That clarity will be given. That clarity anyone can teach you. But how to develop the logic, no one will be able to teach you, because that will come once your basics are getting stronger. And on top of that, the more you practice, based on that, you will be able to develop your logic, logic building skill, because it's a skill only, and that skill can be developed only through practice. So many C programs are there. If you start practicing, suppose you started with factorial of a number, but how can you write factorial of a number if you don't know operators properly? If your basics are not correct, then how can you how the question of writing the program comes? Logic development, okay, logic will be developed, no problem. But how you write the code if your basics are not correct? So that is why logic development skill is very important thing. But this will be achieved only through practices. Initially, what you have to do is that the basic programs you have to do, you have to see, and you have to practice. After practicing it 3 times, 4 times, 5 times, then you will be able to think it a different angle. You will go for the next level program. That will be possible only if you start practicing first. Without practicing first, if you start thinking, sir, I'm unable to develop the logic, I know basics of C programming, logics are not coming into mind, it will never come to your mind. No one will even be able to teach you also, because it comes directly from the practice. Then and on top of that, very stronger basic, not only having the knowledge, internals are very, very important. Sir, I know pre-increment, post-increment, but internally how it is happening, you don't know. That is why initially, whenever I have given the question, students, most of them know the C programming language, but they made the mistake. Most of them are telling, sir, here 20 is the answer. Some telling 21 is the answer. Why? Because internals are not clear. But when I've given the clarity, people understood that, oh, this will lead to compilation time error. So like that, basics, you have to make it clear first. Then only you will be able to do that. currently I'm not going to not going to, start any C programming batch, Pritik, but in future I may start. Yeah. Okay. Thank you, guys. So next class is on Monday. Yeah. Thank you. Thank you, everyone. Okay, students. So let us start today's session. So in our last session, we have learned few of the operators while practicing those MCQs. Those operators including logical operators. I hope you remember logical and, logical or we discussed. Relational operator, at least one relational operator we discussed. 6 relational operators are there. And increment operator also we discussed in our last session. Let us take the next problem statement. Say for example, here I am having one integer variable is there, I is equal to 20. Now here I am writing I is equal to not I. What is this, guys? This is known as logical not. This operator, this is known as logical not. How many logical operators are there? 3 logical operators are there. Logical and, logical or, and logical not. In the last session, already we discussed what is logical and operator and what is logical or operator along with their truth table also. Now, why they are called logical operator? What is the reason they are called a logical operator? They are called a logical operator as because they work on logic. They work on logic. That's why they are considered as logical operator. What is logic, sir? Logic basically means true logic or false logic. True logic or false logic. So they always works on true logic and false logic. So that's why they are termed as logical operator. Now in this example, this is logical not. What about the working principle? What about the working principle of this logical not operator? It makes the true value. It makes the true value to false and vice versa. It makes the true value to false and vice versa. That is what it actually, this is what is its working principle. Now the question is, what is true value and what is false value actually? In C programming language, any value other than 0 is considered as true value. Any value other than 0 is considered as a true value. Now the question is, who will consider it as a true and who will consider it as a false? Suppose for example, whenever you are writing x is equal to 5, int x is equal to 5, what will happen is that to you it is 5. To the developer, to the programmer, it is 5. But if you give this operator, suppose somehow you are having x is equal to 5 and y is equal to 3. So to you, it is x is equal to 5 and y is equal to 3. But suppose, for example, if you're writing something like that, printf %d, and you're writing 5 and 3. 5 and 3. What is this operator? This is logical AND operator. Now, you consider this 5 as a 5. Okay, no problem. But do you think that logical AND also consider this 5 as a 5? No. Logical AND will consider it as a true value or false value. Already we said that, na? Any value other than 0 is considered as a true value. So this 5 to the logical operator, to the logical AND, this 5 here means a true value. This 3 here means a true value. And in the last session we have learned now the working principle of this logical AND. If both are true, then what will be the final answer? The final answer will always be true. Now you see here, suppose for example, I'm writing this code. What will be the answer, sir? So both are true now, but you will not consider as a true. You will think 5 and 3. But logical AND will consider this 5 and 3 as both are true value. So true and true. As per the what is called truth table is concerned, if both the value is true, final answer will be true. And that's the final answer is coming as 1. Suppose here if you are making -5 and -5. You are making -5 and -3. Let us assume. So what? Even I don't not require this line. Just I'm writing a printf statement. You are thinking it's a -5 and -3. But how logical AND is treating this? He is treating this as a true value. Then again, what will be the answer? Both are true now. Execute, compile and run. Again, one will come into the picture. See this? Now, suppose somehow you make one as the 0. You make one as the 0. To you, it is 0. But to logical and what it is? It's a false value. To the logical and it is a false value. So what will happen? Now, false and true. Ultimately, what will happen? Total result is false. Now, the result will come as 0. Understanding why it is considered as logical operator, because even we consider as 5, 6, 3, minus 6, minus 5, anything, but logical operator always sees whether it is a true value and false value. What is true value, sir? Any value other than 0 is considered as a true value. Any value means it can be positive value, it can be negative value. Only thing is that 0 is considered as a false value, sir. Now, let us come back to our example here. This is the code. Now, what is going to happen here? Observe carefully. I is equal to not I, greater than some value here. I'm writing 24. I is equal to not I, greater than 24. Then what will happen? Observe carefully. In this line, how many operators are used? In this line, how many operators are used? One is assignment operator. One is logical not. This is known as logical not. This is known as assignment operator. And this is known as relational operator. Relational operator. Okay, these many operators are used here. These many operators are used here. Now, who is having high precedence? Among these three, who is having the high precedence? You remember in the last session, I was talking about precedence and associativity chart. I told you that everywhere it is required. Now, if you see the precedence associativity chart, you will find that at the very last level, which operator is there? Comma operator is there. The very last level, which operator is there? Comma operator is there. But before the last level, if you observe carefully, before the last level, all these assignment operators are there. Normal assignment, and these are called shorthand assignment. These are called shorthand assignment, right? So we can say that assignment is exactly second last level. It is having the precedence of second last level. Okay, so that means among these, I can tell that this fellow is having the least precedence. Consider them as last. Consider it as last. Now the fight is between these two fellows. See this? Between these, logical not is having a top level precedence. Check it out. This is logical not. This is where logical not is present. So logical not is having a top level precedence. Means it's there at the top level, right? Second level. They are at the second level, right? This is where logical not is present. So let me bring this logical not. Okay, it's already there. After that, we are having relational operator somewhere in the middle of the table. See, this is where relational operator is present. So now in this expression, which part will be evaluated first? As per the precedence and associativity, logical not will be evaluated first. So that means now I will concentrate here, not I. Okay, let me write here is equal to not. I means what? I means 20. I means 20. You can see it as 20. You can see this as 20. But what logical not is seeing this 20? What is the feeling of logical not? Oh, it's a true value. This 20 is a true value. So the feeling of logical not is like this is a true value. This 20 is a true value. You can see 20, but logical not is seeing it as a true value. Now you read the entire part. Not true. Not true means what? Not true means what? False. False greater than 24. Now how many operator is there? Equal to and greater than. Who will work first? Greater than. Because relational operator is having high precedence compared to assignment. Is equal to. is equal to. False means what, guys? We consider 0. 0 greater than 24. 0 greater than 24. Is it a true value? Is 0 greater than 24? Is the value of 0 is greater than 24? No. If 0 is not greater than 24, relational operator is working. Relational operator, whenever it works, in the last session we said, na, relational operator, whenever it works, it gives the result as true or false. Relational operator, whenever it works, it gives the result as true or false. Did I give that point? Yes. Whenever relational operator works, we will get the result as true or false. Here relational operator is working now, and 0 is greater than 24. No, false. That means what is the answer? 0. Now this 0 will be given back to I. This 0 will be given back to I. So finally at the end of this line, if I print now this I, if I print this I, printf I is equal to percentile D I, then what value will be printed? What we evaluated? The value of I should be printed as 0. So that means answer is I is equal to 0. This is the entire explanation for that. This is the order of the operator as per the precedence associativity. As per precedence table. As per precedence table, we have this logical not first, relational operator next, followed by assignment operator. Now let us evaluate this code once. Execute, compile and run. See these guys. The value of I is equal to 0. This is what we predicted as the answer. Let us take the next one. So with respect to logical operator, I said now at runtime I will discuss, because it's not C session where everything will be discussed from the scratch. At runtime I will discuss those things. So now you can understand that logical operator discussion is done. 3 logical operators are there: logical AND, logical OR and logical NOT. All the logical operator I discussed. Let us now move to the next example. Suppose for example, now I'm writing here int a is equal to 30, b is equal to 50, and c and d, 2 variables I am having. Next and after that, here I'm writing c is equal to a comma b, and here I'm writing d is equal to a comma b. Printf percentile d. I want to print the value of c and d here. C is equal to D is equal to. Now this is very beautiful example. Listen carefully. Observe here. First line, no problem from understanding point of view. Just variable declared, some of the variables are declared and some of the variables are initialized too. An assignment operator is used. Now here one operator is used. What is this operator? This is called comma operator. Comma operator generally comes under the special operator. Under the special operator, generally comma operator comes, right? We are having comma operator as a special operator. We are having address of operator as a, what is called special operator. We are having size of operator as a special operator. There are some special operators are there, right? So comma operator comes under the category of special operator. So what is the working principle? So comma operator actually comes under the category of special operator. Under this the comma operator actually comes. Now looks like just like a comma. It looks like a comma. Symbolically it looks like a comma. So comma operator means it's look like a comma. Now thing is that in C programming language, comma can play both role. What are the both role? Comma can play the role of separator. Comma can play the role of separator as well as operator. Comma can play the role of separator as well as operator. Now the question is where comma will play the role of separator and when comma will play the role of operator. See, in a declarative statement, comma plays the role of separator. Comma plays the role of separator. Example, suppose for example you are writing int x is equal to 10, y is equal to 20, z is equal to 30. Here comma visible na? Here comma visible na? Do you think comma plays the role of operator here? No. Here comma plays the role of separator, not as an operator. Except this where comma play the role of separator. So in a declarative statement, isn't it? It is a declarative statement where we're declaring the variable x and initializing this with 10. So in a declarative statement, or even if you're just writing, not required to have the initialization. Just you're writing, just declaring x, y, z. Here comma visible na? There comma is playing the role of separator, not as an operator. Other than this, in a function call, while passing the arguments, comma plays the role of separator. Comma plays the role of separator. Example, suppose for example you are calling a function m1 and you are sending the argument 10, 20, 30. 10, 20, 30. You are calling a function m1 and you are passing the argument 10, 20, 30. Here what role comma is playing? Do you think comma playing the role of operator? No. Here comma is playing the role of separator. Separating the things, separating 10 from 20, 20 from 30. That role comma is playing whenever we are calling a function and sending some argument. Next and after that, where comma play the role of operator? Except the above two cases. Everywhere comma plays the role of separator. Except these above two cases, everywhere comma plays the role of separator. Example, suppose for example, I'm writing here int x is equal to, or int x comma y comma z. Here comma playing the role of separator, comma as a separator here. Now I'm writing z is equal to, first bracket open, first bracket close, x is equal to 10, comma y is equal to 5, comma x plus y. And lastly I'm writing printf percentile d z. Observe here carefully. First line comma separator. Printf is a function call, guys. Printf is a function. Whenever you calling the function means the things that you are passing inside first bracket open, first bracket close, they are in some sense argument. So here also comma is there na. So what role comma is playing here? Already we mentioned in a function called comma play the role of separator. So first line, third line, comma plays what role? Separator. Sir, in the second line also comma is visible. Now tell me, is it a declarative statement? Are you declaring anything here? No. Is it a function call? No. So what it means? Here comma plays the role of operator. Here comma plays the role of operator. Then what is the working principle? What is the working principle of comma operator? What is the working principle? It is simple. It works from left to right and rightmost value becomes the final value of the expression. It works from left to right. This is what you have to remember, guys. This is the working principle. It works from left to right, and rightmost value becomes the final value of the expression. Rightmost value will become the final value of the expression. Now you come to this line, because this is where only comma plays the role of operator. Let's see how it is evaluating. So assignment operator, already you know that. Here, how many operator is visible, guys? Sir, assignment operator is visible. First bracket open, first bracket close is also operator, guys. Check it out in the precedence associativity table. In the top level, we are having the first bracket open, first bracket close operator. It's also operator. It indicates function call. Basically, it is indicating a function call. So it is having the top level precedence, highest precedence, right? So, and we are having comma operator. Now, comma have the least level precedence. Check it out. Comma is having the least level precedence. Comma is normally having the least level precedence. Very last level is comma. But here in the expression, as you put the comma inside the first bracket open, first bracket close. Suppose someone is asking who is having high precedence between assignment and comma. You have to tell assignment is having high precedence compared to comma. Assignment is having high precedence as compared to comma. Who is telling that? Sir, associativity precedence table is telling that. Associativity of assignment of conditional operator, precedence of the comma operator. Means as per the precedence associativity chart, assignment operator precedence is higher compared to that of the comma. But now what happened is that in this expression, because comma is kept inside first bracket open, first bracket close, then suddenly comma operator becomes high precedence compared to equal to. Why? Because first bracket open, first bracket close is having high precedence now. First bracket close, first bracket open is having high precedence, and now we are putting comma inside it. As a result, comma is now suddenly started dominating over the assignment operator and started telling assignment operator, now I am having more precedence than you. But if you remove the first bracket open, first bracket close, immediately comma will come after the assignment. So in this expression, which part will be evaluated first? This part will be evaluated first. Now, you said that here comma is not a separator but it's an operator. Then how it will work? From left to right. So it will start from here. X is equal to 10. The value of 10 is assigned to X. Y is equal to 5. The value of 5 is assigned to Y. This is called assignment operator, guys. You know that. This is called assignment operator. In the last session, I already discussed about the assignment operator in the sense of L value, R value, like that. So here, this 5 is assigned to Y. 10 is assigned to X, 5 is assigned to Y. And now what is happening? X plus Y. So X plus Y means 10 plus 5, 15. It works from left to right. Now my working is done. I started from here. Left to right doesn't mean you will start from here. Left to right means inside this. I'm talking about left to right movement. So moving, done. Walking from left to right is done. Now what it is telling? Rightmost value becomes the final value of the expression. So here what is the rightmost value? 15. So the 15 will become total value of the expression. Rightmost value will become the final value of the expression. So 15 will become the final value of the expression. And that 15 will now be given to Z. Let's see. If I do write this, what we are going to get. Yes. Now let me copy this. I'm commenting this question. Let me declare 3 variable int x, y, z. let me print the value of z. So as per our discussion, what should be the value of z? 15. Execute, compile and run. Perfectly coming. I hope everyone understood how the comma operator should work. So comma can play the role of operator. Comma can play the role of separator. You have to understand where comma can play the role of operator and where comma can play the role of separator. Now let us come back to our original example here. Now you'll find it is very easy, sir. Come to this line, comma is visible. Operator or separator, guys? Sir, it is simply separator. It is simply separator. Now, this line later. First you concentrate this line because as per our example discussion, this is very similar. So D is equal to A comma B. D is equal to A comma B. What is the value of A, guys? 30. 30 comma 50. 30 comma 50. Right? So the value of D will become what? 50. No doubt about that. The value of D will become 50. The value of D will become 50. Now, you come to this line, guys. You come to this line. This is very important. Without bracket, with bracket, it will behave differently. See here, C is equal to A comma B. First of all, how many operator is visible here? Assignment and comma. How many operator is visible here? Assignment is and comma. Now, who is having high precedence, guys? Sir, assignment is having high precedence compared to comma. When you wrote D is equal to A comma B, there also assignment is there. There also comma is there. But in this case, in the case of D is equal to A comma B, due to the first bracket open, first bracket close, comma is started telling assignment operator, I have more precedence than you because myself is kept inside a first bracket open, first bracket close. Myself is having more precedence than you. But here in this case, assignment operator is having high precedence compared to comma. Then what will happen? C is equal to A will be evaluated. C is equal to A will be evaluated. What does it mean? The value of A will be given to C. Assignment operator now, guys. The value of A will be given to C. Then automatically C value will become what? What will be the value of C? The value of C will become the value of A. That means C will become 30. The value of C will become 30. Like D is 50, C value will become 30. Now, first line, second line, they behave differently. Why? Just for the first bracket open, first bracket close. But as per our discussion, we understood both. Now you execute the code. Execute, compile and run. C30, D50 is our prediction. C30, D50. Okay now, guys. So this is yet another operator which comes under the category of special operator. So many special operator we will discuss. We are going to discuss as a, as I said, runtime with respect to this example. Suddenly comma operator came, we discuss this one. Okay, let us move to the next one. Next and after that. So today we have learned two new things. One is the logical not and another is the special operator, comma operator. Next, this one is a bit easier as already we have done something like this. If y plus plus greater than, let it be 100 here, I'm writing here 90, y plus plus greater than 90, and I'm taking here y plus plus not is equal to 110, and then y plus plus greater than 110. Here I'm having printf %d y. It's almost very similar to last day example. In the last day also, we have learned one example like this. Printf y is equal to %d comma y. This is the code. What will be the value of y? Very simple. Very, very simple. Observe here carefully. Yeah. So first, int y is equal to 100. No problem. The value of y is 100. Now the control will come to the if statement. Control will come to the if statement. In the if statement, it will check the value of y. Post increment is there now. So that is the initial, it will check the value of y. What is the current value of y? 100. Is 100 is greater than 90? Is 100 is greater than 90? The answer is yes. In our last session, we have learned that relational operator, whenever it works, it gives us the value as true or false. So here it will check the y value. Is it greater than 100? Is it greater than 90? Is it greater than 90? Is y is greater than 90? The answer is yes. The answer is yes. Now, once the answer is yes, so this part answer is what? Yes. Now it is followed by logical AND. Yes, answer yes means what? True value. Answer is yes means what? True value. Once it is a true value, and it is followed by logical AND, what it indicates, guys? Remember the truth table of logical AND. It indicates that we will move to the next half. First part 1 means we will check the second part for logical AND. Remember? So here also we will come to the second part. In second part, what we are having? Y value. In second part, what we are having? Y value. Now this time the Y value. What value of Y this time will be considered? When it left this part, Y value has incremented. Let me make it 101. Let me make it 101 again. So when Y reaches here, the value of Y already becomes 101. Why? Because this post increment has performed now. Before leaving that part, post increment has performed and Y value has become 101. Now this 101 is checked against this 101. This 101 is checking against this 101. But before that, you have to understand one thing, guys. Observe here carefully. Here you are having how many logical AND? 2 logical AND you are having. Once you are having 2 logical AND, who will come into the picture? Associativity. Associativity of logical AND is left to right. In our last session, we have seen that. Associativity of logical AND is left to right. So here, as per the bracketization is concerned, this is one fellow. This is one fellow from the bracket point of view. Now this fellow is one fellow and this fellow is another fellow. Like X and then Y. Now you can again go for a bracketization like this. Like this. Now your evaluation has started is equal to Y greater than 90. Answer is 1. But now Y become internally what? Internally Y will become what? Y is equal to 101. Now will you go to the next step? Yes, I will go to the next step. Yes. 101 not is equal to 101. 101 is equal to 101. What is this operator? Not is equal to. Again, it is a relational operator. 6 relational operator we know now. Greater than, less than, greater equal to, lesser equal to, not equal to. So 101 not is equal to 101 means what? It is a false. So now here what value we will get? 0. But Y will increment. Y will still increment. So Y value will become 102. Now this value is what? 1 and 0. 1 and 0. And we are having this thing. We are having this thing. And then this thing. This is the thing we are having. Now 1 and then 0 is what, guys? 0. Once it is 0, you will say, sir, stop. I don't want to move further. Whatever after this is there, I don't want to see. I don't want to see. Because final result will now become 0. So I will not see this part. Whatever is there, I will ignore. And as a result, final result is what? Equal to 0. That 0 will be considered where? Under this. Means it is becoming if 0. It is now becoming if 0. As per the rules of if, what is the rules of if? If must be followed by 1 to execute the body of if. But currently here, if is followed by 0. If is followed by 0. So do you think the body of if will execute? Is the body of if is going to execute? No. Body of if is not going to execute. So that means this printf will not execute. Control will come to where? This printf. And y value will be printed. What is the y value? 102. What value of y is going to print? 102. Let's see. Execute, compile and run. The value of y is coming as 102. Tell me, students, are you understanding? Respond in the chat box, guys. Whatever clarity I'm providing with respect to different operators about their working principle, how they are evaluated internally, everyone who are attending the session, respond in the chat box. Are you getting the clarity? Anywhere you felt that, sir, this point, if you discuss it once more, it will be better for us. You can write that in the chat box. But till now, whatever I discussed, is it understandable to you guys? Yes, very good. Let us move further. Yeah, thank you. Next. Let us take the next example with respect to operator concept. Now, which operator we have discussed? Logical operator completely discussed. Assignment operator already done. Relational operator a little bit in every example. You know, relational operator is there. In some of the example, relational operator was there. Now, under the special operator, as I said, so many operators are there. Among that, one very important operator is known as Sizeof operator. Sizeof operator is very important one. Sizeof operator is basically a compilation time operator. Other than this, most of the operator in C programming language, they are runtime operator. Sizeof operator is the only operator which works as the compilation time. So I will discuss about the Sizeof operator, not immediately, at runtime. If I get some example there, I will discuss. Now suppose int a b is equal to 1. Two variable I am having. Int a, one is declared and another is initialized. B is equal to 1. Here I am taking one array of size 5. I'm taking one array A of size 5. Okay. Now this third bracket open, third bracket close is also operator, guys. You see the precedence associativity table. Third bracket open, third bracket close is also an operator. Where it is having the precedence? Top level. Which operator are having top level precedence, guys? First bracket open, first bracket close, third bracket open, third bracket close, dot operator, arrow operator. They are also operator. I will discuss this about this operator, right? Somewhere I will discuss. And post increment, post decrement. These operators are having high level or top level precedence. They are at the first level as per the precedence is concerned. Now, let me go for the example. Here, I'm having one array where the elements are initialized with some values, guys. 1, 2, 3, 4, 5. My array is initialized with 1, 2, 3, 4, 5. Now I'm writing a is equal to 5 into 4 plus a of, here I'm writing minus of b. This is nothing but known as post increment. Achha, here I have taken already a na, so let me take it as x. X of minus of b minus 9 by b. And then finally I'm printing that value. printf a is equal to percentile d. Can you tell me, guys, what is the answer in this case we are going to get? I'm giving you 2 minutes time. Can you evaluate this and tell me the result? I'm giving you 2 minutes time. Evaluate and give me the result. Give me some answer. Whether it is correct or wrong, forget about that. Give me the answer. I will make this correct. Okay, one student is telling sir answer is 12. Okay, let me go for one student is telling 0. Okay, no problem. Let me go for this. See, guys. As per this line is concerned, what will happen? One array will be created. This is that array. How many cells will be there in that array? Size is 5. So 5 cells will be there. 1, 2, 3, 4, 5. 5 cells should be there in my array. Okay. Next, what I'm doing here, let me put the values 1, 2, 3, 4, 5. Okay. Now you know that location name, this is x0, this is x1, this is x2, x3, and this is x4. These are the locations. Okay. Now you take this line. You consider this line. Okay. You consider this line. Now, actually, what is there in this line? Your precedence and associativity knowledge will come into the picture. Observe carefully. Is equal to 5 into, first let me put the values, then we will go for evaluation. 5 into 4 plus x of minus b. That means it is pre-decrement. It is pre-decrement. B value is what? 1. Minus b means it will become x0. It will become x0 minus. See, guys, it is becoming x0. Along with this, guys, don't you think the b value got also changed? Initially b value was 1. Minus b means minus b actually means what, guys? B is equal to b minus 1. As a result, b is becoming what? 0. So this portion I'm getting a 0 value. Along with this, the b value also becoming 0 now. The b value also becoming 0 now. Yes. Minus 9 by 0. Minus 9 by 0. Tell me, student, can I divide a number by 0? Can I divide a number by 0, guys? Is it possible? Is it possible to divide a number by 0? No, it is not possible to divide a number by 0. In C programming language, it is not possible to divide a number by 0. Suppose, for example, you are simply writing printf %d. Here you are writing 10 by 5. Okay, 10 by 5, not a problem, sir. It will definitely give me 2. It is definitely give me 2. It is definitely give me 2. Okay. But if I divide the number by 0, what will happen? If I divide the number by 0, first of all, am I going to get any compilation error? No. Just I'm compiling, not run. Observe. Any compilation error? No compilation error. Just what it is telling? Just a warning. See, this is the warning. Division by 0. Warning and error are not same, guys. Warning and error are not same. It's just giving a warning that division by 0 you are doing. Are you sure about that? Are you sure about that? You are dividing a number by 0. How often in real life you divide a number by 0? You will say, sir, never. So like that, it is giving a warning. Are you are dividing a number by 0. You said that, still I will go for it. Still I will go for it. Execute, run. Execute, run. If I divide a number by 0, what will happen is that this is called abnormal termination. This is nothing other than abnormal termination. Now my program terminated abnormally. Every time when we run the program, it shows now the program exit by this time like that. But now this is nothing is showing. This is called runtime error. This is called runtime error. In C programming language, we are having how many types of error? One is called compilation error. One is called compilation error. Another is called compilation error. Sometimes are also known as, guys, syntactical error. Syntactical error. Another error is known that is called logical error. Another error is there that is known as runtime error. Runtime error. These many errors are there in C programming language. What is compilation error or syntactical error? If we do make mistake in syntax, or if we don't follow the rules defined for the programming language. If we don't follow the rules defined for the programming language, that is nothing but compilation error. Logical error is what, guys? Suppose I ask you to write a program of addition of two numbers. Addition of two numbers. I ask you to write a program of addition of two numbers, but you didn't understand the logic of addition. Somehow you didn't understand the logic of addition, and you wrote the program of multiplying two numbers. You wrote the program of multiplying two numbers. So where you are making the mistake? In understanding the logic. In understanding the logic. That is called logical error. Runtime error indicates, there are some example of runtime error. For example, division of a number by 0. It's never possible. How can you divide a number by 0? Missing ampersand in scanf statement, in scanf function, is also an example of runtime error. It occurs during the execution time. Some people call it as runtime. It occurs during the execution of time. So these many errors we can have in our C programming language. So as per this coding is concerned, as per this example is concerned, are we going to get any output, or we are going to get a runtime error? Are we going to get any output, or are we going to get runtime error? We are going to get runtime error. Execute, compile and run. Don't say runtime exception. Runtime exception are not there in C programming language. That exception terminology is there in Java programming language. But there, if runtime error occurs, we can get out of that situation. That possibility is there. But in C programming language, we don't have the possibility to come out from the situation if runtime error, runtime error occurs. So that is why for this example, we are not going to get any output. It will be abnormal termination or some runtime issues. So the answer for this one is no output actually, abnormal termination. Okay, guys, let us take the next one, last one for today. I'm making a small change in this code. I hope everyone will be able to give the answer. Here, 5 into 4, I'm just changing it to B++. Tell me, students. Do calculate it properly and tell me the answer. Tell me, guys, what will be the output in this case? Correct. 18 is the correct answer. Observe here. This time, we are having B++. Remaining things are same. Now observe here. Is equal to 5 into 4 plus x of b value. What value of b will consider? 1. But internally, it will give me 1 to work here. But internally, b value will change from plus na. So that means b value will change from 1 to 2. B value will change from 1 to 2. Okay. Minus 9 by, when I come here, I need b value. Na? What is the updated b value? 2. The updated b value is 2. Now here, next line, when I will go to the next line, again, first let me put the value 5 into 4 plus x of 1. Check it out, guys. X of 1 value is what? 2. Minus, see here, 9 by 2. 9 by 2. Actually, we are having how many arithmetic operator? We are having 5 arithmetic operator is there. Under the arithmetic operators, how many arithmetic operator we are having? 5. What are the 5 arithmetic operator? Plus, minus, multiplication, division, modular division. How many arithmetic operator we are having? Arithmetic operators. Arithmetic operators. How many we are having? Plus, minus, multiplication, division, modular division. Now among these, plus minus multiplication, I hope you will not ask me to give the clarity. You know it from your childhood. This is called division, normal division. This is called normal division. And this is called modular division. Normal division, modular division. It gives quotient and it gives remainder. It gives remainder. Example, 5 by 3. What is the quotient? 1. 5 mod 3. What I will get? Remainder. That is nothing but 2. So this is about the arithmetic operators. This is about the arithmetic operators. Now you see here, in this example, 5 plus 4 into 2, 5 into 4 plus 2, x of 1. X of 1 is what? 2. Okay, done. Minus 9 by 2. What I will get, guys? Quotient. Because this operator will give me what? Quotient. So what is the answer I will get? 4 is equal to. Now who is having high precedence? Multiplication. Let me do that. 20 plus 2 minus 4. Who is having high precedence, sir? Plus and minus both are having same precedence. Check it out. Plus and minus both are having the same precedence level. Plus and minus both are having same precedence level. Plus and minus, they're having same precedence level. Don't think, sir, I wrote first plus means plus is having higher than minus. I said, na, once they're in the same block means they're having same precedence level. Different block means different precedence level. So if precedence are same, what I should do? Go for associativity. What is that? Left to right. Then what I will do here? Left to right I will evaluate. So that means this fellow will work first. 22 minus 4 is equal to 18. Then when I go for the execution, let's see what we are getting. Execute, compile and run. Okay, now guys. That's it. That's it, guys. So tomorrow when we will meet, we are going to learn another special operator, which is known as Sizeof operator. Yeah. Now, do you have any question to ask, students? Do you have any query, guys? No. Okay. Yeah. Thank you. Thank you, guys. Good evening, guys. Let us start today's session. So, in our last session, we discussed about logical NOT operator. Then, under the special operator, we learned what about the working principle of the comma operator, how it works. Now, today, we are going to explore another special operator that is known as Sizeof operator. Very important. This Sizeof operator is, let us assume I'm giving you a code where you have to predict what will be the output of the code here. Suppose I take a variable here, int a, and then int I is equal to 1. Or say, let us assume the same line, I is equal to 1. Here, I also have another variable b. Now b is equal to 10 into I plus Sizeof operator hyphen minus minus I plus 4 minus 10 by I. And lastly, we're printing the result of b. b is equal to %d b. We want to get the output. Now, before I tell you what output we should get, we must have the awareness of Sizeof operators in C programming language. Now, there are so many operators are there. Sizeof operators comes under the category of special operator. It comes under the category of special operator. See here, Sizeof is a single word. There is no space between size and off. No, Sizeof is a single word. So the very first point with respect to Sizeof operator is, it is a special operator. Is a special operator. Next and after that, it is the only compile time operator. So it is a compile time operator. Compile time operator means what, guys? This is the only operator which works at the compilation time. Most of the operators like plus, minus, multiplication, division, modular division, greater than, less than, logical or logical not, they works at runtime. When the program is in execution mode, at that time those operators works. This is the only operator which works at the compilation time. Not only that, it is a unary operator. It is an unary operator. Unary operator means what? Unary operator means what? The operator which works on one operand. Unary operator means the operator which works on single operand or one operand. That is called unary operator. Suppose, for example, if you write a minus b, here minus is working on how many operands? 2 operands. Operands means data, guys. Operand means data. So we can say that here minus is acting. Here minus is acting as binary operator, guys. Why binary operator? Because it works on more than one operand. That's why it's called binary operator. But when you say minus x, here minus is working on how many operands? One operator. So that means here minus is working as unary operator. So we have some operators who can play the role of binary operator and who can play the role of unary operator also. Just we have to check that on how many operands it is acting, right? Whenever we say x plus plus or we say minus minus y, they are working on how many operands? One operands, and hence unary operator. Minus minus pre-decrement works on how many operand? One operand, and hence is a unary operator. Similar to that, Sizeof operator works on single operand. That's why Sizeof operator is known as unary operator also. So three special word we have used here. Special word, compile time operator, and unary operator. Now, what about the working principle? What it gives? Working principle. Working principle of the Sizeof operator. First of all, the Sizeof operator is giving the size in terms of byte when operand is a data type. That means when Sizeof operator is used with the data types such as int, float, char, it returns the amount of memory. It returns the amount of memory allocated to that data type. It returns the amount of memory allocated to that data type. Suppose, for example, let us assume you are not having the awareness of size of integer. Then what you will do? Copy here, later I will bring into the picture. Suppose you are writing here printf %d size of int. Similarly, printf %d size of float. We can have so many things, na? Long, double, long, double, so many things. Here it is, let it be long. Let it be, or let it be, this one is long. Say this is float. Let it be double. Next, I'm taking one char. Here it is, say, size of long float, long double. Here I'm writing size of int is equal to colon. Here /n size of long. Same way, /n size of float. Here new line I require /n size of double. Here /n size of char. Here /n size of long double. Size of long double. Execute, compile and run. So one bracket is missing here. Execute, compile and run. Now no error, no warning. Now you see what Sizeof operator is giving me. Size of the data type. It's simply returning the amount of memory that is allocated to the data type, to the particular data type. What is the amount of memory that is allocated to int data type? 4. But what is the unit, sir? What is the unit? 4 bytes. %d bytes. Here also bytes. Here also bytes. And here also bytes. Execute, compile and run. See this. 1 minute. Close this. Yeah. Size of integer 4 bytes. Long 4 bytes. Float 4 bytes. Double 8 bytes. Character 1 bytes. Long double 16 bytes. So moral of the story is what? Whenever we are talking about size of operator, it returns. Returns means what, guys? Returns means it gives. What it gives? Size of the operands, size of the data types in terms of the bytes. In terms of the bytes. So this is one of the application or where the size of operator is used. This is one such example. Except this, where else size of operator can be used? Suppose, for example, and another important note here is that though we are getting here size of integer is 4 bytes, actually it is machine dependent. Machine to machine, it may give you different value, that you must have to be aware of the fact that it is having a machine dependent behavior. Next, here size of operator taking the data type and giving you the size. That means here it is the size of operator. Instead of taking any operand, here it is considering data type. That means data type as operand. So case 1 is when operand is a data type. When operand is a data type. Case number 2 is, let us assume, when operand is not a data type, but operand is an expression. Operand is an expression. Operand is an expression. In that case, what is the behavior of the size of operator? Listen. When size of operator is used with an expression, it returns means what, guys? Returns means it is giving to you. That is called returns here. It returns the size of the expression. It returns the size of the expression. How? What it means, sir? Suppose, for example, you are having a code here, int main, and you have taken one integer variable here, int a is equal to 10. And here you are taking one double variable, double d is equal to 12.34. Double d is equal to 12.34. Now here you are writing printf. Say, for example, you are writing percentile d, and then you are writing size of a plus d. Now you will get the clarity why it is called compile time operator rather than runtime operator. Observe very carefully. Let us assume this is our code. So this is a C program. Let us assume the name of the C program is test.c. Now what will happen? This code will be given to compiler. This code will be given to compiler. Compiler will take this code, and now what compiler will do? It will create, this is, let us assume, high level language. Some people consider it as a high level language. Some people consider it as a middle level language. Whatever. Now compiler will convert it into machine level language. Compiler will convert it into machine level language. Machine level language means the language using zeros and ones. That is nothing but considered as a machine level language. Okay. And here the file that will be created is having an extension of test.obj. Test.obj. This file is having the code written using zeros and ones. Now execution have not started yet. Just compilation happened. At the phase of compilation phase, what is the role of compiler? Compiler role is to check in your program any syntactical mistake is there or not. Whether programmer have made any syntactical error or not. while writing the code. That is called syntactical mistake, whether programmer is following the rules or not. If you are not following the rules and regulations, the guidelines, making syntactical mistake, compilation error will come. If no compilation error is there, now compiler is going to convert your source code from high level language to the machine level language. Now exactly at this phase, means not runtime, sir, not execution, exactly at this phase, means while the conversation happening, high level to machine level language conversation is happening, exactly at the same time, exactly at this time, what will happen is that the Sizeof operator will come into the picture and he will work. Sizeof operator will come into the picture and he will work. How he will work, sir? Observe here. A is what type? Int type. B is what type? Double type. Between int and double, who occupies more memory? Already we know that. As per our previous example output, double occupies more memory, sir. 8 byte. Integer occupies less memory compared to that double, sir. 4 byte. Sizeof operator will decide between these two who occupies more memory. Between these two, who occupies more memory? D occupies more memory. What is that size? 8. Now Sizeof operator will return here a value like 8. That means your printf statement will now look like this, guys. Your printf statement will now simply looks like this. Printf %d8. It will simply look like this. Now when execution will start, when we go for a runtime execution, when your program will be executing, what will happen? He will see this code. Okay, int a is equal to 10, no problem. D is equal to 12.34, no problem. Printf, he is unable to see this code, guys. He will see this code. Printf %d d8. Then what will be printed, sir? 8 will be printed. Let us verify it whether truly these things are happening or not. Say for example, let me copy this portion of the code. I copy paste it. Execute. Achha, before that, let me copy this output. This is having a meaningful. 1 minute. This output is meaningful to us. So for our future references, let us have this value. Okay. Now let us compile and execute this code. Execute, compile and run. Achha, this part is not under comment line. Let it be make under comment line. Execute, compile and run. See here what output you are getting. Do you think that this addition will take place? No. Why? Because when the program will start execution, at that time, this A plus D is not anymore visible, guys. This is not anymore visible. Because at the compilation time, this part worked, sir. Compilation time, this part worked. And as per the highest data type size, the value is returned here. So at the execution time, my code is not going to see that A plus D. It is only going to see the highest data type size here. So when Sizeof is used with the expression, it returns the size of the expression in terms of the highest data type. In terms of the highest data type, it returns the size of the expression in terms of the highest sized data type. In terms of the highest sized data type. That is why with respect to this, your output will come as 8. Now let us take the example with which I started today's session. Let us take this one. Now you will find it easy to give the answer. See here. Go for it, guys. Anyone there who can tell me the answer of this now from this discussion? Observe the code carefully. Apply the rules, whatever you have learned with respect to size of operator, and try to give the answer. Tell me, students, what will be the answer for this one? Very simple. Again, when compilation will occur, size of operator will come into the picture. What he will do? This line at the time of compilation, this line at the time of compilation will become what? This line at the time of compilation will become what? Is equal to 10 into I plus the size of hyphen I at the compilation time, guys. Compilation time never minus is going to work. Compilation time never minus is going to work, right? So at the compilation time, it will check the data type of the I. I is what type? Int type. Int type means it is going to return here 4. Int type means we have seen that in the current compiler, integer size is 4 bytes. I said already that it varies from machine to machine. Then hyphen 10 by I. What is I value? 1 value. What is the I value? 1 value. Sir, why it is 1 value? Because the reason is that this will work at runtime. Currently, I am in the compilation time only, sir. This minus y, minus I will be decremented at runtime, not at compilation time. Currently, I am at the compilation time means what? Minus has not executed yet. So I will have this original value. Now you check this. Precedence associativity will come into picture, guys. 10 into I is 1. So that means it is 10 plus 4 minus 10 by 1. 10 by 1. 10 by 1 is what? 10 by 1 is arekta 4, no? Plus, where is that? 10 into I. 10 into I plus another 4 is there. Yes, this plus 4 is there. This plus 4 is there, right? Plus 4, this 4. Yes. So now 10 into I means 10 into 1, that is 10 plus 4, again plus 4 minus 10 by 1. Quotient, guys, we are dividing 10 with 1. That means what you will get? 10 only, na sir? Now what will happen? Don't say, sir, plus minus 10 will be cancelled out. You can do that in that fashion, but to be technically sound, it will be something like precedence and associativity rule. 14 plus 4, 18, 18 minus 10. The answer should be 8. That should be the answer. Now let's see. Execute, compile and run. Perfect. No? The v value is printing as 8. Such a beautiful operator. So much internal story is there with respect to this. What is called? Another special operator that is known as size of operator. I hope you got complete clarity with respect to the working principle of size of operator, where it is applicable, how it looks like, as well as when it works. Yes, guys. So let us take one more example with respect to the size of operator. Say, just I'm declaring few variables here. IJK, okay, printf, %d, size of k by is equal to I plus j. Okay, and lastly printf %d k. This is my code, sir. What will be the output of the code if I execute this one? Try this one, guys. Yes. Very simple. We should not take this much time to give the answer. Very, very simple. No. Two printf statement is there, na? So two output will come. How many printf statement is there? Two printf statement is there. So how many output will come? Two output will come. No, not 13. Not 13. Observe here carefully. When the program will be compiled, is size of operator is there? Yes, there. What size of operator will do? Sir, it will be considering here size of how many operand is there? K is there, I is there, J is there. Everyone is of what type? Everyone is of int type. So at the time of compilation, he will return here 4. Return means giving here 4. This line, sir, here size of operator is not there. So when it will be executed at runtime only. Only size of operator, whatever is there, that will be executed at compilation time. Except this, everything is at runtime. Yes, Chetan, correct. Sir, here it is 4 and this is K. K value is what? 15. Do you think that this fellow will get the chance of execution? No. Why? Because at runtime, this thing will not come into the picture. Na, sir. At compilation time, this part will work and it will give me 4. So when my program will run, this part will never be visible, sir. This part will never be visible. So even it is there in the coding, it will never be executed. It will never get the chance of execution. So that is why in this case, we will get the output as 4 and 15 respectively. Okay, na? Very easy, sir. If you learn this working principle of the size of operator perfectly, it is very, very easy, sir. Next and after that, let us take one more example with respect to size of operator. See here, suppose I'm writing here printf double quotation %d. Here I'm writing Sizeof and here I'm writing printf. Here I'm writing printf. After writing printf, here I'm writing something like learning C is fun. Learning C is fun. This is my code, sir. In this code, what will be the output? What output we will get it, sir, here? When the code will compile, what output we will get? Okay, let me help you in this case. See guys, printf is a function. Printf is a function. We are generally having two type of function. One is called built-in function, or some people call it as predefined function. Predefined function. Another one is known as user-defined function. User-defined function. Printf function, but actual function is of two types, sir. Built-in function as well as user-defined function. So what is built-in function, sir? The function that comes along with your programming language API. The function that comes along with your C compiler. That is nothing but is the predefined function. Example of predefined function: printf, scanf, next sqrt, next pow function, etc. These are considered as a built-in or predefined function. Similarly, user-defined function means sometimes they call it as programmer-defined function also. Programmer-defined function also. Example of programmer-defined function: suppose you are writing M1 function, fact function, M2 function, right? Prime function. These are not inbuilt. You have to define those functions. You have to write the logic for those functions, right? That is called user-defined function. Now, printf function, how it looks like, sir? How the printf function looks like? If you want to see how the printf function looks like, very simple here. You see here, this is how the printf function looks like. This is how the printf function looks like. This is how the actual printf function looks like. Now, if you make a careful observation here, guys, see the return type, this particular portion, this is not required, just concentrate on this part. This particular portion is called return type. What it is called, guys? Return type. This is what is known. This is known as name of the function. This part is known as what? Arguments. This is known as arguments, right? You know, there is a long stories there. If I try to, explain this part now, why 3 dot, what is this pointer? Currently, we will not enter into that much details, sir. 3 dot means it is stands for variable args, var args. That means printf function can take any number of argument now, guys. Sometimes you write percentile d a b. Sometimes you write percentile d a comma b comma c. Sometimes you only write printf hello world. So sometimes it is taking 0 argument, 1 argument, 2 argument, 3 argument, something like that. Not 0, 1 argument, 2 argument, 3 argument, something like that. It can take any number of arguments. For denoting that part, it is having these 3 dots. It indicates var args. Var arg is a separate story. Currently, we are not going to enter there. Here, the interesting and important point is that return type of the printf function. Return type of the printf function. What is that? Int. Not only that, if you want to see the return type of scanf function, return type of scanf function is also int. You see, return type of the scanf function, it is also integers. So these 2 points you have to remember, because there are so many cases will come where this knowledge will be needed. What is the return type of printf function and scanf function? Return type of printf function and scanf function is integer. This much information is enough. What is there inside it as the argument, how it is, what is this thing, not required. Just to the return type, we must have the awareness. Now you come here, guys. When this line will try to execute, what will happen? At the time of compilation, guys, at the time of compilation, when the program will be compiling mode, that means at the time of compilation, stage, this line will be replaced by something. By what, sir? Sizeof. Here it is the function. Function calling takes place when? At runtime. But currently where we are? At the compilation time. Currently where we are? At the compilation time. We have not reached to the execution mode yet. We are just compiling the code and we want to know what is going to happen. So at the compilation time, function will not execute. But at the compilation time, Sizeof operator will definitely execute. Sizeof operator will definitely execute. What he will do? He will check that array, is there any data type is there? No, not there. Is it an expression to evaluate? No, not there. But then how I will get the size of a function? That is what now the compiler is getting confused. Compiler, you don't require to be confused. Why? Because printf function return type is integer. So whatever printf will return, that will definitely be integer value. Return means I already said to you guys. Return means you have to remember giving. Giving is nothing but is returning. So whatever printf function will return, here always you are going to get an integer value. Here always you are getting an integer value. So if you are always getting an integer value here, because printf function return type integer, na? So always you are going to get an integer value here. So the feeling of size of will be what? Oh, I have to calculate the size of integer only. And size of integer is what? Already we know that. What is that? 4. So this printf statement, compilation done, guys. Compilation done. Now when the program will go to the execution mode, it will simply see printf percentile d4. It will simply see printf percentile d4. Then what will be the output, sir? 4 only. Compilation and run. See this, guys. Only the output is going to come as 4. Sir, if I remove the Sizeof operator, then what will happen? Okay, first let me copy up to this as per the discussion. Okay. See, guys, suppose if I remove the Sizeof operator, what will happen? Then is it going, any compilation activity is going to come here? Means anything is going to work at the compilation time here? No. So at runtime, what will happen? See, one function, printf itself is a function. Inside this, another printf function. Inside this, another printf function. This type of function callings are known as nested function. This type of function callings are known as nested function. Function calling is working as an argument inside another function. These type of things are known as nested function. You have to remember, in case of the nested function, the inner function works first. In case of the nested function, which works first, guys? The inner function works first, sir. Now, here, the inner function is a printf statement only. What is that printf statement? Learning C is a fun. So that means what is going to print? This fellow is going to print. Learning C is a fun. After printing, he will return how many characters is successfully printed in the console. Count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Space have to be counted. 10, 11, 12, 13, 14, 15, 16, 17. 17 characters I'm going to print into the console. Now it is going to return 17 here. First it will print the value, learning C is fun. And after that it is going to return 17 here. Return means already I told you, giving here. This place will get what value? 17. Then what is the output we are going to get? Learning C is fun followed by 17. Learning C is fun followed by 17. This is nothing but known as nested function calling, guys. This is nothing but known as nested function calling. Are you getting the clarity, students? Everyone is understanding whatever clarity I'm providing with respect to this? Yeah. Next and after that, let us go for next one. So yesterday, we have learned about the comma operator. All right. Let me verify. Really, you have learned the comma operator or not? Let's, for example, I'm giving you int I is equal to some values I'm assigning here 10, 20, 30. Int I is equal to 10, 20, 30. Printf %d I. Yesterday I discussed about the comma operator story. Comma can work as an operator, comma can work as a separator. So here you people have to tell that if I write this code, what will happen, sir? What will be the output in this case? What will be the output in this case? Yeah, most of you are thinking, sir, the output will be 30 because you told in the last class, na sir, that comma operator working principle is the rightmost value will be returned. No, first you ask yourself, is comma is going to play the role of operator here? Isn't it a declarative statement? Isn't it a declarative statement? Yes. Once it is a declarative statement, is comma is going to play the role of operator? No. Where comma play the role of operator? Sir, except declarative statement and except function argument everywhere. So first of all, isn't it it's a declarative statement? Yes. Sir, in the declarative statement, up to this no problem. Up to this no problem. I is a variable assigned to 10. After that 20. But where 20 will be assigned? Where 20 will be given, guys? Where is the variable to get the 20? Because if it is an operator, no problem, sir. Rightmost value will be assigned to I, no problem. But it's not on, its comma is not going to play as the operator here because it's a declarative statement. It is a declarative statement here. Now the question will be raised, up to this no problem. Variable I declared, assigned to 10. Now what about this? Compiler will think this fellow is a declarative statement fellow. Means like the way you will write now int I, j like that. He will think, he will treat them like a, like them as a variable declaration. But it's not a variable declaration actually because 20 is a constant. 20 is a constant. Compiler get confused. If you confuse compiler, compiler will give error. If you make confuse compiler, compiler will give error. See this? This is the problem. What it is telling? It is telling expected identifier or first bracket open before numeric constant. Means what they are asking? They are asking that either instead of using a constant, You use some identifier like J, use some identifier like K, I will not give the error. This is one possibility, no error. Other possibility is before the numeric constant, put a first bracket open, first bracket close. That means keep them inside the first bracket open, first bracket close. If you keep it in this fashion, then also I'm not going to give any error. See first, what is the output I will let you know, but see first, error gone. So these are the two suggestions by the compiler. I followed that two suggestions and I'm getting rid of the compilation time error. So as per this coding is concerned, what is the output, guys? No output, sir. This code will suffer from the compilation error. This code is going to suffer from compilation error. Okay. Now as per the compiler suggestion, what I am doing, guys, I'm putting a bracket here. And after putting the bracket, now I am asking, tell me what will be the value this time. Tell me what is the value this time. Now I think you will make it correct. Now there is no doubt about that, sir. What will happen? Int I is equal to, from here some value will come. First of all, is it a declarative statement here? Is the total value is the declarative statement? Yes, total value is declarative statement, but I'm not using comma in the declarative statement. I'm using the comma inside it. Not as a part of declarative statement. As a part of declarative statement means like I, comma, J, comma, K. Here the comma is a separator in a declarative statement like this. After this, if I give a comma, that comma is a part of declarative statement. But here I'm using the comma here inside the first bracket open, first bracket close. So it's not a declarative statement part, sir. It is, the entire thing is a declarative, but here this is not like a declarative part. From here some value will come. Here comma will play the role of operator. And if comma plays the role of operator, you know the working principle now, guys. Left to right it works. Rightmost value will be given. What is the rightmost value? 30. Now if I go for compilation and run, the I value will be given me as 30. Understanding or not, guys? Comma operator. Now another variation, let me give it to you. So this is one more variation. Suppose, for example, you declared I here, only the variable I. Next line you are writing I is equal to, this one you will make it correct, 10, 20, 30. 10, 20, 30. And I'm printing the I value. Tell me, guys, what will happen? What will happen in this case? What is your suggestion in this case? What output we should get? Any suggestion? See here, very simple. This is a declarative statement. Done. Next and after that, I is equal to 10, comma 20, comma 30. How many operator is there, guys? 2. Equal to and comma. Who is having high precedence? Equal to. Simple. Simple, sir. 10 will be given to I. Sir, compilation error will not come? No, not come. Why? Sir, in the first example it came, na? Sir, in this example it came. Here it came. Why not it will come here? There is a difference between these two. Observe carefully. This fellow and this fellow are not same. This is in a declarative statement. In a declarative statement, you must have a variable. In a declarative statement, you must have a variable which you can assign with a value. So it is definitely a declarative statement where compiler is searching for identifier, variable name, not getting. That's why becoming furious and giving you the error. But that thing is not happening here because it is not a declarative statement, sir. Is it an executable statement? It is an executable statement. Here operator precedence associativity will come into the picture. And as per that, assignment operator is having high precedence than comma. 10 will be given to I. After that, what happens? Just two values, 20, 30 can be there. Can't I write a C program like this, guys? Just I wrote 20, 30. Nothing else. No variable, nothing. Just I wrote a C program like this, 20, 30. You ask the compiler to compile the code. Let's see what is happening. No error, no warning. Possible, sir. Possible. Even you can write 20 and 30. What will happen? It will not be used in my program. Because to use it in my program, I need a variable to capture the value. So that's why it is not used in my program. But in a declarative statement, sir, can I write like this? Can I write like this, sir? Int 10, 20, 30. Is it possible to write, guys? Is it possible to write? Can you declare like this int 10, 20, 30? No. Declarative statement means some identifier, some variable should come into the picture. Now you go for execution. Compile, definitely error will come. Tell me, students, getting the clarity? Any doubt, guys? Confirm once in the chat box. Understanding? Understanding, guys? Respond in the chat box. Are you getting the clarity? Yeah, very good. Next and after that. So today, mainly we focus in learning the Sizeof operator. Now, let us assume I'm writing another code here. Int I is equal to 30. Int I is equal to 30. Printf %d. Here I'm writing ++i followed by ++. Tell me, students, what is the answer we are going to get here? What is the answer we are going to get here? I is equal to 30 ++i++. Yes, most of you are thinking that, sir, it will be 31. Now you observe here carefully. In the last session, while learning this ++ operator, somewhere we mentioned that ++ operator or minus operator, they cannot be applicable to a constant. They are applicable to a variable. ++ operator or minus operator, whether it is acting as a pre-increment or post-increment, it is applicable only to variable, but not to a constant. It is applicable only to variables, but not to constant or expression. Not to constant or expression. Sir, what does it mean, not to constant or expression? First of all, let me tell you what is meant by not to constant. You observe here. Here ++i, and you made it bracket. We know now precedence and associativity rule. As per the precedence and associativity rule, who is having high precedence? First bracket open, first bracket close. As a part of that first bracket open, first bracket close, now what will happen? This line will become something like this, guys. It will be becoming something like this. Printf %d. This fellow will work fast, and it will make it like 31 ++. Tell me, guys, can we have 31 ++? Can we write a constant ++? Is it possible to have this constant ++? No, sir. Why? Because if constant ++ is allowed, 31 ++ meaning will become 31 is equal to 31 + 1. But do you think 31 is equal to 31 + 1 is possible? No, not possible, sir. Then immediately what will happen? Sir, compilation error will come into the picture. Execute, compile. See, guys, L value required. Already in the last session, somewhere we discussed L value required. What does it mean? L value required error will come into the picture. Sir, you said that increment or decrement, that is post or pre-increment, post-increment, pre-decrement, post-decrement, they are only applicable to variables but not to constant. Now you understand why I said that it is not to constant. Sir, you also said that it is not applicable to expression. Can you give the proof, sir? It is not applicable for constant. Yes. See here, guys. Suppose, for example, let me copy this code. Suppose, for example, here I am having two variables. A is equal to 5, B is equal to 6. And suppose I'm writing something like this, guys. plus plus a plus b, plus plus a plus b. Think a bit, guys. What will be the output in this case? What will be the output in this case? Tell me, students. What will be the output in this case? Anyone there who is thinking, sir, the output will become 12? No. Good. Who is that? Chetan. Very good. Sir, it will be error. Why? Sir, first bracket open, first bracket close means this fellow will work first. Once this fellow will work, na sir, a plus b means 5 plus 6, 11. And now the expression will become what? Sir, the expression will become plus plus 11. Plus plus 11, guys. Can we have plus plus 11? Sir, if you say plus plus 11 is possible now, I will think 11 is equal to 11 plus 1. And I will think 11 is equal to 12. Total mathematics will be in danger, guys. So not possible. What will happen? Again, you are trying to confuse compiler, na? Compiler will give you error. Execute, compile. See, same thing. L value required. Understanding the operators, how it works, guys. All the possible permutation and combination I am bringing into the picture to give you the more clarity with respect to different operators, right? Let us go for one more example. Okay. So before that, let me copy this one. See, guys, int I is equal to, I'm taking here some variable. What is that, sir? 39 or say 40. This is known as right shift. What is this is known as? This operator is known as right shift. So we are having bitwise operator. Under the bitwise operator, we are having left shift operator, right shift operator. So many shift operator we are having, left shift and right shift. And other than this, we are having bitwise OR operator, bitwise XOR operator, and bitwise AND operator. Why they are called bitwise operator? It is as because they work on bits. That's why they are called bitwise operator, or let it be bitwise operator. Maybe I will discuss tomorrow. Whatever times are there, not possible. Let's take a different one. Suppose I'm taking int x comma y is equal to 5 and z is equal to 5. And here I'm having one statement. X is equal to y is equal to z. Printf %d z. Can you tell me, guys, what value of z will be coming here as output? What value of z will be coming here as output? Sorry, forget about z, let it be x. What values of x will be coming here as output? Anyone there who can tell me, sir, what will be the output of x here? What value will come here? Very good. Sir, the answer will be 1. Why? Because what is this operator, guys? Sir, this operator is known as assignment operator. Already we know that assignment operator is having second last level precedence. Assignment operator is having second last level precedence. Here, what is the operator? It is relational operator. So equal to operator is there, equal to is also there. What is the difference? Sir, this is assignment operator. This is assignment operator. And this is comes under relational operator. 6 relational operator we are having now. This comes under relational operator. Now, who is having high precedence compared to this? So relational operator is having high precedence. So I wrote relational operator first. Relational operator, whenever it works. Relational operator, whenever it works, you know that it gives us what? 0 or 1. Gives us means it returns. It provides what value? 0 or 1. Now you see, y is equal to z. This fellow will execute first as per the precedence associativity rule. So is 5 is equal to 5? Is 5 is equal to 5? What is the answer? Yes, 1 is the answer because it's a true value. that true value in the form of 1, that true value in the form of 1 will given to x, will given to x. And now whenever I will print the value, sir, 1 will be printed. Execute, compile and run. 1 is come into the picture. So this is all about, you know, guys, we are completing here. We are completing almost most of the operators. So bitwise operators are pending, left shifting, right shifting, those operators are pending. So mostly we completed logical operator, assignment operator, increment, decrement operator, we completed. Special operator, under special operator, how many we completed till now? We completed a comma operator and Sizeof operator. There are still some more special operators are there, which I will bring into the picture at the time of pointer discussion, right? Tomorrow, mostly we will spend time in understanding the conditional operator. Yet another very important operator is there, conditional operator and bitwise operator. Tomorrow, this will be our target to focus. This conditional operator and bitwise operator to understand. And operator precedence and associativity, you know that. Every day it comes into the picture. Every day operator precedence associativity come into the picture. And evaluation of expression, what we do. Every time, every example, we are doing evaluation of expression only. Okay, that's it, guys. Hope you enjoyed the session and you got the clarity of whatever we discussed, right? Yeah, thank you, guys. Yes, guys, let us start today's session. Today, I'm going to discuss about conditional operator. In the last session, we have learned about special operator. Under that special operator, we learned about Sizeof operator, the only one compile time operator. Till now, under the category of special operator, we completed comma operator and Sizeof operator. Today, I'm going to explore conditional operator. I'm going to explore conditional operator. Now, how the conditional operator looks like? It looks like this: asking sign followed by colon. Asking sign followed by colon. This is how conditional operator looks like. Now, what is the working principle, or what is the general syntax? General syntax of conditional operator. It is something like expression 1 asking sign, expression 2 colon, expression 3. This is how the conditional operator general syntax is. Now, what is expression? Expression means it is having operands and operators associated with it. It is having operands and operators associated with it. Now, what is the working principle? The working principle is, if the expression 1 is true value, if the expression 1 gives us the true value, then expression 2 is the final result. If expression 1 gives us the false value, then expression 3 is the final result. The working principle is, if expression 1 gives us true value, then expression 2 is the final result. Otherwise expression 3 is the final result. This is the working principle of conditional operator. And another very important feature of the conditional operator is the associativity of conditional operator is right to left. The associativity of conditional operator is right to left. What it means by this word associativity is, in the absence of bracket, how the expression will be bracketized, that is denoted by the word associativity. In the absence of the brackets, how the expression will be bracketized, that is denoted by the word associativity. Now, the associativity of the conditional operator is right to left. There are only few operators are there who are having the associativity right to left. Among them, conditional operator is one of the operator who are having the associativity right to left. Other than conditional operator, assignment operator and all unary operators, associativity is having right to left. Unary operators, conditional operators, and assignment operators, they are having the associativity right to left. Except those, every operator associativity is left to right. Let us take an example so that we can understand that how the conditional operator is working. Let us assume here I'm having a variable int x and a is equal to 10. The value of a is 10 and the x is not initialized. Then I'm writing here x is equal to size of a plus plus, asking sign, that means conditional operator. Printf, here I'm having learning C is fun. Here I'm having the statement learning C is fun. Colon 0. Now in this entire expression, who is expression 1? This particular portion in the entire expression, this particular portion is known as expression 1. This is the asking sign. Now from here to here, up to this, this is known as what, guys? This is known as expression 2. Then we are having colon. Then we are having what? This portion, which is none other than expression 3. Right? Now, here conditional operator is there, assignment operator is there. Who is having high precedence? Conditional operator is having high precedence. So before this assignment part works, first the part that will be working is the conditional operator part, because they are having the high precedence. What about Sizeof? Sizeof is a compilation time operator. So it will work at the time of compilation. Next I'm having printf x is equal to %d x, and I'm also printing the value of a. Here let me write in this way, value of x is equal to this /n and printf value of a is equal to %t and then a. This is my coding, right? What will be the output in this case? See guys, already we have learned about the Sizeof operator. It is a compile time operator. When it will work? At the stage of compilation. At this stage of compilation means when my source program will be converted to the machine language, that is from high level language to machine level language conversion. At that time, Sizeof operator will work. So what it will do? It will consider this line, and at this stage of compilation, this particular portion will be replaced by something. It will be replaced by something. What it will be replaced by? It will be replaced by size of A. A is what type, guys? A is a integer type. So integer type means it will be having a value 4. So at the compilation time, this particular expression 1 got the value as 4. Sir, A++ will never get the chance of evaluation. A++ will never get the chance of evaluation. Okay, 4. Is 4 is a true value? Yes, 4 is a true value. So which part will be executed as per our discussion? Already we said that if expression 1 is true, expression gives us true, then expression 2 is the final result. So that means here, the final result is what? Expression 2. And what is that? Printf learning C is fun. Automatically what will happen? This particular thing will be printed. This particular thing will be printed in the console. So that means in my output, we are going to get that. Learning C is fun. But already we know that printf itself is a function. Printf itself is a function. And it returns what? In the last session we have learned, guys. Printf function returns what? Integer value. So here after printing this, what value will be returned here? Printing part is done. Now what value will be returned here? Sir, the value that will be returned here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 characters are there. So that means what value will be returned here? The value that will be returned here is 17. The value that is returned here is 17. Now what will be assigned to this x? Sir, the value that will be assigned to this x is none other than this value, because this is the final value of the expression now, which is 17. So what will be printed here? What will be the value of x? The x value will be 17. And what about the value of a? Sir, a never got the chance of increment. A never got the chance of increment because this fellow should work at a runtime where due to the Sizeof operator, the entire expression has evaluated at the compilation time, where Sizeof gives the size of the operand here, which is none other than a. So ultimately what we are going to get? Learning C is fun is going to come in the output. After that x value is going to print. That means they are going to print the value of x is equal to 17. New line is there. And then they are going to print value of a is equal to 10 also. So final output is learning C is fun. Value of x is 17 and value of a is 10. Let us verify this once. Execute, compile and run. See here, learning C is fun, value of x is 17 and value of a is equal to 10. Now let me do one thing here. I want to make a new line here. Say here I'm having a new line. So what is going to happen? Execute, compile and run. Value of x is 17. Learning C is fun, right? That is the first line. And then lastly, value of a is 10. So this is about the conditional operator. So moral of the story is what? In case of the conditional operator, it is a ternary operator. Why conditional operator is a ternary operator? You remember somewhere I discussed about unary operator, binary operator. Now, unary operator means the operator which works is, sir, is constant variable executes at compile time. Constant variable executes at compile time. That is not the correct word, Rakesh. The correct word is, if it is a constant value, if the variable is constant, the value is never going to be updated. No question of evaluating. No question of evaluating. The fact is that at runtime, if you try to change that value, you will not be able to do that. That is the factor. If it is a constant value, at a runtime, the value is, if the variable is a constant variable, at a runtime, the variable's value is not going to be updated. So it will be fixed throughout the program. Once you are setting it throughout the program, even at compilation time or even at runtime, throughout the program, the value of the variable is going to be fixed. We are not able to allow to make the changes. Normally at compilation time, what is the role of the compiler? The role of the compiler is to read the source code. Whatever code you are providing, reading the source code. Activity number 1. Activity number 2, after reading the source code, its job is to convert that high level language or middle level language to the equivalent machine level language conversion. And that too also happens, this conversion of high level language to machine level language happens only if compiler finds that there is no syntactical error is there. Then if there is no syntactical error is there, then only it will convert the high level language to the machine level language. Next, at that time of conversion, entire program got checked, no syntactical error, nothing is there. At the time of conversion, if any operator is there, Sizeof operator, that Sizeof operator will be evaluated at that time. If you are taking a constant variable, what will happen? Throughout the program, at the time of compilation or even at the time of execution, throughout the program, you will not be allowed to change the value of the variable. First of all, no question of changing the value of the variable at compilation time. Only thing that we can do is that value of the variable can be changed at runtime. And if you are making the variable as constant variable, then at runtime, the value of the variable cannot be changed. Understanding? Rakesh? Yeah. Let us move to the next one, sir. Let me record the output also. Next week, once your registration is done, I will share all the documents, right? Whatever we have done till now, all the questions, discussion, everything, I will share with you in our next week. Okay. Now, let us take another example of this conditional operator. See these guys. Suppose I'm having a variable int a. Here I'm writing a is equal to 50 greater than 80. So this becomes my expression number 1. And here I'm having a value like 10 colon. Here I'm having 1 not is equal to 2 less than 5 asking sign. Then we are having 20 colon 30. This is my value. Let it be 5 and 8 respectively. And finally I'm printing that printf value of a %d a. This is the code we are having. Now, it is such a big expression, and the beauty of the expression is you will able to find so many operators are present here. See guys, why I said that associativity and precedence is very, very important. Now see, such an expression where almost most of the operators are present. How to evaluate this one? Observe carefully. Here assignment operator is there. Let me list it out which operators are there. Assignment operator is there. Greater than operator is there. Conditional operator is there. Next, not is equal to operator is there. That's it. These many operators are there. And even less than operator is also there. Okay. Then how to arrange it, sir? First of all, as far the precedence and associativity is concerned, Assignment operator is having list level precedence. Assignment operator is having list at the very bottom. Last level is comma. Before that, assignment operator is there. Now here greater than is there, less than is there. Greater than, less than are having same level of precedence. They are having the same level of precedence. Then we have to go for associativity, which is from L to R, left to right. Not equal to operator, yet another relational operator. 6 relational operators are there now, guys. Another relational operator. But compared to greater than and less than, not equal to is being not equal to is present in the next level. Compared to greater than, less than, and not equal to is present in the next level. In the same level, we are having greater than, greater equal to, less than, lesser equal to. But equal to, and not equal to is in the next level among the relational operator. Next, after that, we are having the conditional operator. After that, we are having the conditional operator. Now, if I try to set the expression properly, then you observe here how many conditional operators are present? 2 conditional operators are present. 2 conditional operator is present means what? Who will come into the picture? Associativity will come into the picture. Associativity means what? In the absence of bracket, how the expression will be bracketized. In the absence of bracket, how the expression will be bracketized. Now, associativity of conditional operator is from right to left. So that means once you start bracketization, the bracketization will start from right to left. So which part will be bracketized first? First, you observe that this colon is basically associated with this asking sign. This colon is basically associated with this asking sign. And this colon is associated with this asking sign. Now, with respect to this particular colon, what is the expression 1? This is the expression 1. This part is the expression 1. This is the expression 1. This is expression 2. This is expression 3. What does it mean? I can consider this is one part. This is one part here. Okay. Now, with respect to this asking sign, this is expression 1 and this entire part is expression 2. Or we can say that if this is expression 1, this is expression 2, and then this part is entirely is expression 3. So how can we bracketize? We can bracketize in this fashion. This is how the expression will be bracketized. In the absence of brackets. Now, have you observed one thing? I didn't start bracketization from here. I started bracketization from here. Why? Because associativity is right to left, and hence the bracketization will take place from right to left. But evaluation will always start from left to right. Now we will start evaluation of the expression. Is the 5 value is greater than 8? 1 minute, guys. Is the 5 is greater than 8? This is expression number 1. The answer to this is false. We know that if expression 1 gives us true value, expression 2 is the answer. Otherwise, expression 3 is the answer. So currently where we will come? We will come to evaluation of expression 3. Now in the expression 3, again we are having a conditional operator. Where this particular part is the expression 1. This is expression 2. This is expression 3. Now while evaluating this expression 1, observe carefully, guys. Not equal to is there, less than is there. Who is having high precedence? Less than is having high precedence. Who is having high precedence? Less than is having high precedence. Then 2 less than 5. What is the answer? 2 less than 5. Less than operator. Relational operator, whenever it works, we know that. What it does? Sir, it gives us the value as true or false. Yes, 1 or 0. Now what will happen? This particular part, after evaluation, give me what value? 1. Now you see, 1 not is equal to 1. 1 not is equal to 1. 1 not is equal to 1. Is it true or it is false? Sir, 1 is equal to 1. 1 is equal to 1. So that means what? This part is basically false. It is not true. Once this is false, Conditional operator is here. So which value will be executed? Sir, 30. So that means from here, what value I will get as an answer? 30 we will get as an answer. And already we said that 5 greater than 8. No. Which part will come into the picture? This part. So what is this value? 30. So what value will be given to A? The value that will be given to A is, the value that will be given to A is 30. The value that will be given to A is 30. Now have a look here. Execute, compile and run. The value of A is 30. Now today at the beginning we took one conclusion. What is the conclusion? The associativity of conditional operator is right to left. And this is the perfect example. This is the perfect example to understand that yes, associativity of the conditional operator is right to left. Everyone understand this, guys? All of you understood how this example is evaluating the value as 30? Associativity is from right to left, sir. Then why we start from 5 greater than 8? That is called evaluation. Associativity means in the absence of bracket, how you will set the bracket. In the absence of bracket, how you will set the bracket. Now suppose for example, whenever you say that, say 10 into or 5 into 4 by 2. Suppose you are telling 5 into 4 by 2. What is the answer? Everyone will say the answer as 10. Everyone will say the answer as 10. Now you see here, suppose you are telling, sir, 5 into 4, 20. 20 by 2 is 10. Another fellow is telling 5 into 4 by 2. 4 by 2 is 2. And that's why the answer is 10. Anyhow you come, the answer is 10. But which one is technically correct and which one is technically wrong? If I compare this, if I see this associativity, if I see the precedence and associativity table, we will find that multiplication and division are having same level of precedence. Multiplication and division are having same level of precedence. Then who will come into the picture? Associativity will come into the picture. Once associativity will come into the picture, associativity means in the absence of bracket, how the expression will be bracketized. How the expression will be bracketized. Now you said left to right now. So first which part will be bracketized? This part. 5 into 4. 5 into 4. This part got bracketized. Now divided by 2. Let us assume it is x by 2. Let us assume this is x by 2. Now you bracketize this part. You bracketize this part. And now you put the value of x. Then how it will be looking like? 5 into 4. 5 into 4 by 2. Now this is what is as per the associativity when it is from left to right. Now the evaluation will start. When we will go for evaluation, what we will do? We will start from left to right. That means 5 into 4 first, that becomes 20, and then by 2, that becomes 10. So among this option, which one is correct? This is correct. This one, incorrect approach. In this example, it is giving me correct value if you think in that direction. But for other example, definitely you are going to get the wrong answer. Now, suppose for example, you are writing something like that, 5 plus 2 into 3. Here, no question of associativity. Here, only thing is precedence. As per the precedence, who is having high precedence? Multiplication is having high precedence compared to plus. Does it mean that you will evaluate directly from here? You will directly start from here? No, sir. I will start from left. 5 plus. Plus is having a working principle. Every operator is have some working principle. What is the working principle of plus? Plus always tell that I want this side value. Otherwise, I will not work. I want this side value. Otherwise, I will not work. So you started from here, but you halt it here. You halt at this point. Why? I need here a value, sir. I need here a value. To get the value here, what you are doing? 3 into 2, 6. Now you are giving the value here as 6. Now you are giving a value here 6. And now you are concluding the factor as 11. Does it mean that multiplication is having high precedence? Does it mean that, sir, directly I'm starting from here? Can you start the evaluation from here? Evaluation will always start from left to right. Now, as per the precedence and associativity, if the operators are having high precedence, that part will be evaluated. If the operator is having the same precedence, as per the associativity, it will be evaluated. So evaluation, for evaluation purpose, I will always start reading from left to right. But associativity point of view, depending on the associativity of a particular operator, how the expression will be bracketized, that will follow the rule of left to right or the rule of right to left. But evaluation will always start from left to right. Let's go for another example. Suppose you are having int x, y, z, and z is equal to 5. Let us assume. Now you are writing here x is equal to y is equal to z, and here you are printing the value of x, percentile d x. Now you see here in this line we are having two assignment operator. Once two assignment operator is come into the picture, you cannot go for precedence. How you will compare the precedence? Because both are same operator, no? Both are same operator. How you go for the precedence? No, sorry. What we have to check? Associativity. Associativity of assignment operator is also from right to left. Associativity of assignment operator is also from right to left. That means what? In the absence of bracket, how the expression will be bracketized. So here how the expression will be bracketized? First, this part will be bracketized. Y is equal to z. Sorry, y is equal to z. This part will be bracketized. Now which part will be bracketized? X is equal to. This part will be bracketized. Now whether you keep it in the bracket or doesn't keep, whether you keep it in the bracket or not keep into the bracket, that's a different story. But this is how internally it will be bracketized. Now this part will be bracketized. This part will be bracketized. But evaluation will start from where? Left. What it will do? X is equal to. Stopping here. Why? Sir, I need a value here. I need a value here. What will happen? Z is y is equal to z. Assignment operator. Na? That means what? The z value will be given to y. What is the z value? 5. That will be given to y. That means y value is what? 5. So what value I'm getting here? 5. Now what will happen? The 5 value will be given to x, and finally x value will become the answer. So that means evaluation purpose always will start from left. But associativity point of view, in the absence of the bracket, how the expression will be bracketized, that will be either following the rule of left to right or following the rule of right to left. Chetan, clear na? Yes. So what is the answer for this one? The value of A is 30. Let us go for another one. So two example we have seen. One example we understood the behavior of the conditional operator. That is expression 1. If it is true, expression 2 is the final result. Otherwise, expression 3 is the final result. Now, another example we have seen where we found that the associativity of conditional operator is right to left. Let me take another example. Okay. A is equal to, bring your pen and paper, guys. 2 greater than 5, not is equal to 1, asking sign, 5 less than 8, and 8 greater than 2, asking sign, 15, asking sign, 10, colon 20, colon 30, colon 40. This is the expression. I want to know what will be the value of A at the end. Actually, no space is there. For understanding purpose, you can do that. You can give these spaces. Now evaluate this one and tell me the final answer. For your understanding purpose, let me write by giving some space. How the expression will be bracketized. If you can make it bracketized perfectly, you will be able to give the answer. First, check it out. Syntactically, is this statement is okay or not? Because three conditional operator is there, means 3 asking sign and 3 colon. Check it out. How many colons you are having? 1, 2, 3, and 3 asking sign. 1, 2, 3. So that means there is no question of syntactical error. Okay. Suppose by mistake you write here a 50. Then there is no point of continuing with this, sir. Unnecessarily trying is basically meaningless, because this is syntactical error. How can we 4 colon is there where 3 asking sign is there? So have to be very careful for that. So I'm removing this one. I'm leaving this one. I'm leaving with this one. What will happen here? Let us verify it. First, this asking sign is associated with whom? With this colon. So that means I can make a bracketization of this part. Just this part, I can make a bracketized. Okay, na? This part is bracketized. Okay, and in this part, you see perfectly it is following. Expression 1, expression 2, expression 3. Done. Now I will take this one, this colon. For this is expression 1, this is expression 2, and this is expression 3, guys. So what will happen? This particular fellow, I'm bracketization, making a bracketize now. Yes, this is done. Now who is there? Another asking sign is there. Another asking sign is there. So for this asking sign, this is the expression 1. This is the expression 1. This is the expression 2. This is the expression 2. How far? This is the expression 2. This is the expression 2. Right? And this is the expression 3. This is the expression 3. That means what I can do, I can put it in this way. Right? Now I will start evaluation of this part. Here, this is the expression 1. In this expression 1, what we are having? 2 greater than 5 not is equal to 1. Who is having high precedence here? Greater than having high precedence. Greater than having high precedence than not is equal to. 6 relational operator is there. I already told you. Greater than, greater equal to, greater than, greater equal to, less than, less or equal to, and equal to, not equal to. Among these 6, these 4 fellows are having high precedence compared to these 2 fellows. These 4 fellows having high precedence compared to these 2 fellows. Okay. Now what will happen? 2 greater than 5. 2 greater than 5 is what? False. 0. 0 not is equal to 1. Yes, it is true. 0 is really not is equal to 1. What will happen, sir? This entire part is what? This entire part is what? Expression 2. This entire part is what? Expression 2. And this part is what? Expression 3. So expression 3 is out of the context. Expression is out of the context. I will focus on expression 2. Why? Because 0 not is equal to 1. So now I will work on with this fellow. I will work with this particular expression. Now you see here, this is what with what I will work. So this is 5 greater than 8. 5 greater than 8 means what value, guys? 1. True value. Logical and is there. Will you go to the other half? Yes, I will go to the other half. You came to this half. You came to this half. Here, 8 less than 2 is, sorry, 8 greater than 2. Is 8 is greater than 2? Yes, 1 is the answer. If 1 is the answer, this is expression 2. He will come into the picture. Expression 3 got out of the context. Expression 3 got out of the context. 8 greater than 2 is true. So this part will come into the picture. What is this part? Sir, 15 asking sign 10 colon 20. This part will come into the picture. In this part, what is the value? 15. Is 15 is a true value? Is 15 is a true value? Yes, 15 is a true value. If 15 is a true value, what should happen? Which value should come into the picture? 10 should come into the picture, na? 10 should come into the picture. If 15 is true value, 10 should come into the picture. Now, if 10 is coming here, so just from this part, what value I am going to get? 10. So now what will happen here? 1 and then 10. So both are basically true value. Both are basically true value. If both are basically true value, what should happen is that the final result should come as a true value. The final result should come as a true value. Remember always precedence and associativity. This is the part you have to remember carefully. Here 2 greater than 5. 2 greater than 5. According to the precedence, greater than is having high precedence. So 2 greater than 5 will be evaluated first. And 2 greater than 5 is a false condition. 2 greater than 5 is a false condition. So that's why the expression now becomes 0 not is equal to 1. 0 not is equal to 1. 0 not is equal to 1 is a true value. 0 is not equal to 1. So that means this is a true value. So as a part of the true value, expression 2 will be evaluated. Expression 2 will be evaluated. What is that expression 2? Sir, expression 2 is the entire part. What is that entire part? Sir, the expression 2 is this entire part. Na? This is the entire part. This is the expression 2. This part will come into the picture. This part will come into the picture as a part of the expression 2. Now here, 1 minute. Another thing is that I should consider that logical and. Okay, this is perfect. This conditional operator story is perfect. But before that, logical and operator is here. Na? Just observe here. This part I should bring into the picture. As per the precedence and associativity is concerned, logical and is having high precedence than conditional operator. Logical and is having the high precedence than conditional operator. And what about the relational operator versus logical and? Who is having high precedence? Relational operator is having high precedence or logical and is having the high precedence? Who is having high precedence, guys? Relational operator is having high precedence. That means greater than, less than, they are having high precedence compared to that of logical and. So here one thing we should consider before start evaluating those conditional operator, that's 5 less than 8. 5 less than 8. What about this 5 less than 8? It is a true value. It is a true value. And 8 greater than 2. What is this? 8 greater than 2 is also true value. Now here if you see 8 and 8. 8 and 8. If you consider this part, 8 and 8. 2 true values. 8 is a true value and 8 is a true value. But the thing is that whether we are going to consider that 8 and 8 or not, whether we are going to consider that 8 or not, that is what you have to decide, right? So here I'm mentioning about 3 level of operators: conditional operators, and operators, greater than operators. I told you here how to bracketize the expression with respect to conditional operator. But no, here not only conditional operator is present. Not only conditional operator is present. Here we are having the present of and operator as well as relational operator. That too I need to bring into the picture. That too I bring into the picture. Now, if you think just give the priority to the conditional operator, then as per our discussion, what is the result we are getting here? 1, 1 and 10. 1 and 10 means what? It's a true value, and we thought that 1 should come into the picture, but 1 will never come into the picture. Final result will never become 1. Why the final result will never become 1? The thing is that in this evaluation order, only thing that we bring into the picture is the story of conditional operator. The remaining operator story are not considered. Whereas greater than and, logical and, both of them are having high precedence. Compared to the conditional operator. That is why you cannot prioritize only the conditional operator. Let me show you. The output is surely is not going to be coming. Check it out, guys. The output is not going to come. As per the thing here, what we did, we just only prioritize the conditional operator, and as per that 1 should come. But it will not only prioritize the conditional operator. See here, the output is never going to come as 1. See here, the output is coming here as value of A is 10. 1 is not going to come, because the thing that we have done here is we are only making the priority. We are only giving the priority to the operator, that is the conditional operator. No, sir. And logical and greater than, both of them you have to make the priority. They also should be bring into the picture, not only the conditional operator. So just I'm giving you this as a homework. When we'll come to the next session, you have to tell me, right? How can this result? Already I told you why one should not be come into the picture. You have to identify why the answer should come as 10, where we have to give the priority as per the precedence and associativity, so that we can bring the answer as 10. As per this discussion, we thought that one will come, but no, never one will become, because one should not come, because the answer is because the reason is that I have to bring these fellows into the picture. What you have to do, I already told you what is the precedence and associativity. Now, as per that, you have to arrange the statement, and you people have to provide me the clarity. Sir, how can 10 be the answer? Right? If you are unable to do that, then definitely I will explore in the next session. I will tell you how the 10 is going to come. But before that, I want, because all the discussion from my side is done, all the fallacies also I discussed. If I only prioritize the conditional operator, where is the fallacy? This is the fallacy. So everything I discussed, now you have to arrange the statement as per the precedent associativity, and also have shown you the answer also. Somehow to prove that one is not the answer, you people got the answer also. Now what you have to decide is that you have to find how the answer is coming as 10. So that clarity you people have to provide. If you are unable to tell me how the answer is coming to 10, then I will give you the clarity. Understanding, guys? Any doubt, students? Do you have any doubt, guys? Yeah, some students already started giving the answer, but okay, as because all other students have not given the answer, so I will take it from everyone. Yeah, Chetan, you are correct. Your answer is correct. I have verified that. I can see your answer. Your answer is correct. But for other students also, how the answer is going to come, you people have to tell me. And other than that, do you have any doubt, guys? Where to give the bracket so that the answer can come as 10? And that's not arbitrarily, that following the precedence and associativity order. By following the precedence and associativity order, where I should put the brackets, sir. That is what you have to tell. Tell me, students, up to this, anywhere, any issue? Yeah, let us move further. So take a picture of this. This is the clarity that I'm expecting from you people. Okay. Yeah. Next, and after that, another operator is there which we need to discuss. That is called bitwise operator. So under bitwise operator, yesterday also I mentioned that we are having bitwise and, bitwise XOR, bitwise OR, followed by left shift and right shift. So whatever times are left today, so today I'm not going to discuss too much about the bitwise operator. Rather, we will start from tomorrow. Tomorrow I will discuss about the bitwise operator, because there is a big discussion is there, because positive number left shifting, negative number left shifting, everything I will show. So that discussion I will make tomorrow. But today, let me go for another example and how you can react to this one. I want to see. Okay. Let me copy this. Suppose int a is equal to 1. C. Bring your pen and paper, guys. A, B, C, D. I want to know the values of A, B, C, D, everything. You have to tell me the answer. Yes, correct. Your answer is correct. Who is that? Chetan. Perfect. Very good, man. See here, students. C is equal to assignment operator, logical OR operator, pre-decrement operator. What will happen? Very simple. Here it is 1. Already we have discussed about the logical OR operator. If the first operand is 1, should I go to the next half? No. So that means this part will not be evaluated. This part will not be evaluated. And entire result of this part will become what? A value is 1. Once it is the 1, I will not go to the other half. So the entire part is evaluated to what? 1. And that 1 is given to C. So the value of C becoming 1. That is the only conclusion we can make it from here. Now when we come to this line, again D is equal to later. Concentrate on the A value. What is the A value currently? 1. What is the A value? 1. Post decrement. It is post decrement. So first I will take the decision whether I should go to the other half or not. Yes, logical AND is there and A value is 1. Should I go to the other half? Yes, I should go to the other half. But before going to other half, internally the value of A will become 0. Internally the value of A will become 0. But decision is taken on the value of A's original value. That is 1. Should I go to the other half? Yes, I should go to the other half. But internally A value will become what? 0. Internally A value will become 0. Now once I come into the other half, now this is pre-decrement. That means B will be decremented. B value is what? 1. 1 will be decremented means it will become 0. It will become 0. So what value I'm getting here? 0. Logical AND. Either of the side of the logical AND, if I get a 0, enter result will be what? Enter result will be what? 0. So the value of B will become what? 0. Then what is the answer? 0, 0, 1, 0. Let us verify it once. Execute, compile and run. 0, 0, 1, 0. Okay, now let me give one more example to you. That is also you have to do only. It's a big one. Okay. Observe. In A here, A is equal to 2 greater than 5, asking sign 1 not is equal to 2 greater than 5, asking sign 10 colon 20 colon 5 less than 8, asking sign 2 not is equal to 2 greater than 5, asking sign not is equal to 5, asking sign 30 colon not 1, logical not of 1, okay, not is equal to 1, okay, asking sign 40 colon 50 colon 60 colon 70, right? Printf the value of A is %LD. This is also you have to evaluate. Of course, I will do it for you. I will do it here only. I will give the clarity also how it will be evaluated. But before that, I want you should go for a try. This one and this one. Then tomorrow, I will discuss both of these. These two is your homework, guys. This one and this one. Yes. Take a picture of this. First one answer you know somehow, that is 10. But how the 10 is coming, that you have to give the answer. And for this one, acha, come in the chat box. No? 1 minute. Let me copy this to the chat box. Check it out, you received this or not. Received, no? Yeah. No. 1 minute, 1 minute. So let me do one by one. Okay, this is the first one, right? This is the second one. Now you received now both the example you people received. And now see what I'm expecting. I'm not expecting that you will run the code and tell me the output. I'm not expecting that. I am expecting how you will arrange the expression by the knowledge of precedence and associativity. That is what I'm expecting. Because if you run this code in any compiler, it will show you the output. I'm least interested about the output. I want to know whether you are capable of arranging the statement properly or not. I have shown you one example here, how to arrange it properly. I've shown here one example here, that is while arranging, I cannot give priority only to the conditional operator. Remaining operator, if like operators like logical and is there, those operators also I should bring into the picture. So that is, I just by giving a priority to one operator, I may get a wrong answer, right? So that's why you have to arrange this one properly, as well as you have to arrange this one properly as per the precedence and associativity. Then only I will give you the clarity how it is working. Okay, so in our next session, we are going to learn about the bitwise operator. Other than that, I think almost everything is done, right? Special operator, 2 operators are pending. Conditional operator also we discussed today. Tomorrow also you will spend some time after seeing how you are reacting to this answer. And then tomorrow we are going to learn about the bitwise operator. Thank you guys. Any doubts, students? Any doubt? Yeah. Okay. Thank you guys. Okay, good evening, guys. So, in our last session, we learned about ternary operators, right? And I think I've given one example also to verify how to bracketize the expression. I think I've given two examples, right? One or two. Two examples I've given. Yeah. This is one example for which I ask you people to identify the order of bracketization. And this is yet another example, right? Now, what we are going to do is that we are going to identify the order of bracketization for both the cases. How the precedence and associativity will come into the picture, we want to see. So let us first start with this one. This is the code. This is the coding we are having, okay? Now, so this is the expression for which we want to know what is the order of precedence and associativity. First of all, how many conditional operators are present here? And on top of that, is the statement or expression is syntactically okay or not? One asking sign, two asking sign, 3, 4. So I must have 4 colon. One asking sign, two asking sign, 3, 4, 5. 5 asking sign is there. So how many colons I must have? 3 colons I must have. Okay. 5 or 6. 1, 2, 3, 4, 5, 6. Acha, 6 asking sign is there. 6 asking sign is there. Not 5 guys, 6. Then as per that, how many colons I must have? 6. 1, 2, 3, 4, 5, 6. Okay. 6 asking sign, 6 colon. So syntactically, no issue. Now we can start evaluation. How can we start evaluation? Conditional operator, associativity is right to left. Conditional operator associativity is right to left. So what is the first conditional operator? This asking sign. Who is the associated colon with this? This fellow. Now, for this asking sign, this is expression 2, guys. This is expression 3. This is expression 2. This is expression 3. Question is, then who is the expression 1? So before this asking sign, I'm moving until the colon. Until I'm having the colon, whatever part is there, this is none other than my expression 1. So that means this is expression 1, expression 2, expression 3. So the very first thing that I can do is that I can bracketize that part. So this part is done. Next. What is the next asking sign? This is the next asking sign. For that, who is the expression 1? This is the expression 1. Who is the expression 2? This is the expression 2. Who is the expression 3? This is the expression 3. For this asking sign, this is my expression 2 and this is my expression 3. Then what about the expression 1, sir? What about the expression 1 for this? Just I'm moving from here, and then suddenly one asking sign is coming. So before that, so that means this is my expression 1. So that means for this conditional operator, this is expression 1, 30 is expression 2, and the entire bracketization part is expression 3. Entire bracketization part is expression 3. What I'm going to do is that I can put them in the bracket. Next and after that, another asking sign is there. For this asking sign, who is the expression 1 and who is the expression 2 and who is the expression 3? This is definitely the expression 2. This is the expression 3. This is the expression 2. This is the expression 3. Then what about expression 1? I'm moving from here, moving from here, moving from here up to this. Before I reach the another asking sign, this part is none other than my expression 1 for this conditional operator. So this is from here, expression 1, bracketization part entirely is expression 2, and 60 is the expression 3. 60 is the expression 3. So what I can do is that, I repeat one more time, for this asking sign, this is the expression 1, this is the expression 2, and this 60 is the expression 3. So from here to here, I can make a bracketization. From up to 2 to that 60, I can put it into the bracket. Okay. Anything left? Now, for this asking sign, what is going to happen, sir? I have just done it for this one. Now this asking sign. For this asking sign, this entire part is the expression 1. This entire part is the expression 1. And expression 2. This entire part is the expression 2. And this is expression 3. This is expression 2. And 70 is the expression 3. Then what about the expression 1, sir? How for the expression 1? 5 less than 8. 5 less than 8. Then I'm suddenly getting a colon. So that means from here, this is my expression 1. This is my expression 1. So what I'm going to do? This is my expression 1. This is my expression 1. 5 greater than 8 is the expression 1. For that, this is the expression 2. This is the expression 2. And then this part is the expression 3. So what I can do here, from here to here, what I can do, I can put it in a bracket. Control V. Now, what is left? Till now, up to this, we have bracketized. Next, which part is left? If you see here, still we are having one asking sign, another asking sign is left. Now, for this asking sign, who is the expression 1 and who is the expression 2 and who is the expression 3? That is what we have to decide. All right. For this expression, for this asking sign, who is the expression 1, who is the expression 2, and who is the expression 3? That is what I have to define. And see here, 2 greater than 5. 2 greater than 5. Asking sign, 2 greater than 5. Acha, here I think there is a mistake is there. 2 greater than 5, 2 times came, na? 2 greater than 5, how many times it is there? 2 greater than 5. This one, na? 2 greater than 5. Asking sign, 1 colon, 1 minute. Let me verify it once. 2 greater than 5. Asking sign, 10 colon. Okay. 10 colon 20 colon 5 less than 8. Asking sign 2 colon 2 not is equal to 2 greater than 5. Yeah, this is okay. This is okay. Now we are left with how many asking sign? 1 asking sign, 2 asking sign, and we are left with 2 colon. Okay, for this asking sign, what is the expression 1? Up to this will be the expression 1. Okay, this is the expression 2 and this is the expression 3. So that means what we can do is that for this one, what we can do, we can bracketize that, this part. Yes, perfect. Next, we are left with how many asking sign? 1. For that, this is the expression 1, this is the expression 2, and this entire part is the expression 3. Now my bracketization is done. And now if you want, even you can put one more bracket. That is for your understanding purpose, but not required. If you want, you can put another first bracket open, first bracket close, but it's not required because now I'm going to evaluate this. So whether you are keeping this entire thing in the bracket or not, your choice. Let's start evaluation. 2 greater than 5. What is the answer? False. If the answer is false for the conditional operator, which is the answer? Expression 3 is the answer. So for this conditional operator, who is expression 2? This is expression 2. Who is expression 3? This is expression 3. So who is the answer? Expression 3 is the answer. So that means now my focus will be here because I have to evaluate this part to get the result. Here, 5 less than 8. Is the answer is true? Yes, the answer is true. So for this conditional operator, what is the expression 2? Because once the condition is true, that means expression 2 is the answer. So for this conditional operator, this is what is the expression 2. Up to this is the expression 2. So that means now my concentration will be to develop this part. Now here, see these guys. 2 not is equal to 2, 2 greater than 5. Who is having high precedence? Greater than is having high precedence. So which part will be executed first? This part. Is 2 greater than 5? No. Relational operator. What answer will be returned? 0. Now this part will become what? 2 not is equal to 0. This part will become what? 2 not is equal to 0. 2 not is equal to 0 is true now, guys. 2 not is equal to 0 is true. Then automatically which part will be executed, sir? This is the part that is going to be executed because expression 2 will be evaluated. So now my concentration is to evaluate this part. Now here, see guys, not 5, logical not 5. Already we have learned now. Logical not makes what? Makes a true value to false value. Makes a true value to false value. So logical not will treat here which value? 0. What value will be considered? 0. Is 0 is a true value? No, 0 is a false value. So that means 30 will not be evaluated. Which will be evaluated? Expression 3. Which part will be evaluated? Expression 3. Now my entire concentration came here. Now what I will do? I will start evaluating this one. How many operator is there? See, it's logical not. This is logical not. But this is not is equal to relational operator. This is what? Logical not. Logical not is a unary operator. Unary operator is having high precedence. So not 1 means what actually? Not 1 means what? Sir, it's a false value. That means 0. Is 0 not is equal to 1? Is the value of 0 is not equal to 1? Yes, 0 is not equal to 1. 0 and 1 are not same. Then what should be the answer? 40 should be the answer. 0 not is equal to 1. That is a true value. And which part should be evaluated? 40 should be evaluated. Then what should be the answer? 40 should be the answer. Let's see. Execute, compile and run. Anything is there? Oh, I need to comment this entirely. Let me comment this. Execute, compile and run. The value of A is 40. As per our expectation, the value is 40. Tell me, students, do you have any doubt or you understood this conditional operator, this big drama here, how it is internally evaluated, how to consider the precedence and associativity for the conditional operator? When we are having more than one conditional operator is present, how the things will be considered? Do people have any doubt, guys? Everyone enjoyed this clarity? Everyone make response, students, so that I can understand. Chetan, Rakesh, understanding, guys? Rajshekhar? Yeah, good. Now, let us go for this one. This one is a bit easier one comparatively because the expression is not that much complex like this one. So I hope you people have already, it's the same one I copied now, guys. 1 minute. Yeah, this one. This one I think is a bit easier compared to this one because we are having less number of conditional operator is there. Anyone? Can you tell me, guys, what is the answer for this one? without evaluating. Without evaluating, can anyone tell me what is the answer for this one? Yes. So one student have given the answer. Let's see whether it is correct or not. This is what is the answer of one student, right? Let's see, is it really this one or not? Then what we will do, first count how many conditional operator. 1, 2, 3. 1, 2, 3. How many colon will be there? 3. 1, 2, 3. Syntactically everything is okay. Now first this conditional operator. For him, what is the expression 1? This is the expression 1. Expression 2, expression 3. Very easily we can bracketize. Very easily we can bracketize. Done. Next, this is the conditional operator. Now 8 greater than 2. You have to be very careful here, right? If you consider this as the expression 1, if you consider this as the expression 1, then this will become the part of, if you consider this as the expression 1, obviously this will become expression 2 and this will become expression 3. As a result, what will happen? This entire part will become the second operand of and. This entire part will become second operand of and. No. That is not the correct thing. The correct thing is that before the asking sign, up to this entire part should be considered as expression 1. Why so? Why so? Because then only the logical and will have this fellow only as its second operand. Then only logical and will get this one as the second operand. So that's the reason for this conditional operator, this entire part is my expression 1, this is my expression 2, and this is my expression 3. So what we can do here is that this entire part we can make under a bracket. Okay, na? Lastly, this is my expression 1, this is my expression 2, and this is my expression 3. So what we can do that, if you want you can do that, otherwise not required. Put the bracket here. Now go for evaluation. First, 2 greater than 5 not is equal to 1. Which part will work first? Greater than having high precedence. So 2 greater than 5, false, that is 0. 0 not is equal to 1, that is true. Once that is true, which part will execute? This part will execute. This part will execute. So I will concentrate on this part. Next, this is the expression 1. This will evaluate it first. In the expression 1, 5 less than 8. What is the value? 1. Will you go to the other half? Yes, I will go. 8 greater than 2. What is that value? True. Enter result is what? 1 and 1. Enter result is what? 1. Once it is 1, which part will be taken? Expression 2. What is expression 2? Up to this is expression 2. Next, here, this is my expression 1, which is a true value. Then which part will be considered as the answer? Expression 2. Then what should be the answer? 10. So this is perfectly okay. Very good. Let us verify it once. Execute, compile and run. The value of A is 10. So whatever the fallacy, where fallacy can arise, right? Understanding the operator perfectly, where is the chance where we can make the mistake? Everything with respect to this particular operator. In the last session, I discussed. Today, no fallacy, just directly I'm giving you the clarity. What is the answer for this one and how to evaluate this? Now, I think any problem statement related to this conditional operator, doesn't matter how many conditional operator they put, even you can put any number of conditional operator. I hope very easily you will get the clarity and will be able to get the answer. So this is all about conditional operator. Next and after that, we will start learning the bitwise operator concept, right? And in the bitwise operator, mostly very, very important is left shifting and right shifting of negative number. Positive number left shifting, positive number right shifting is very, very easy. But how to do the negative number left shifting and negative number right shifting? That is very, very important. And there another very important discussion is there, that is called as signed and unsigned. Signed integer, how to represent, what is the range for the signed number, and another one is the unsigned. Both this signed and unsigned story I want to bring for this shift operator under the shift operator discussion. So let us first start with left shift. Yeah. Suppose, for example, first let us start with positive numbers. Okay. Suppose, for example, here I'm writing printf 5. This is called left shift operator. Currently we are discussing about bitwise operator. How many bitwise operator are there? So many bitwise operator are there. Number one, bitwise and symbolically 1 ampersand. Next and after that, bitwise or symbolically this. Next and after that, bitwise XOR. Acha, bitwise OR is like this. Bitwise XOR is like this place. Yeah. Next and after that, left shift. Left shift is basically 2 less than. Basically, how to remember, most of the students forget to how to write the left shift number. Very simple. How you write L, guys? Just make that L a bit angular, it will become left shift, and make it and go for it 2 times. Just the reverse of it will become right shift. There we will discuss both positive number and negative number both. And lastly, we are having bitwise complement or bitwise not, or some people call it as a complement operator. Complement, bitwise not or complement operator. Both the terminology are same. How it looks like, it is the tilde sign. Now, why they are called bitwise operator? Because they works on bit. Bit means what, guys? Bit is the short form of binary digit. Bit is the short form of binary digit. Now, let us start with left shift and right shift first of positive number. Suppose here I'm writing 5 left shift by 3 is equal to percentile d. And here I'm having 5 left shift by 3. Say, for example, we are having another one. Printf here 4 left shift by 4 and 4, it is 4. What will be the answer in this case? Very simple. Left shift means what? Left shift means what? Left shifting of a positive number. Left shifting of a positive number means, yeah, already some students started giving the answer. Yeah. Left shifting of a positive number means multiplying the number. Left shifting of a positive number means multiplying. So automatically you can understand that 100% the number is going to increase. Yes, Chetan, Madhulina, your answers are correct. Left shifting of a positive numbers means multiplying, multiplication. Okay, that means the number will be increased. Left shifting of a positive number means multiplying the number by 2 to the power. 2 to the power. Now, why 2 to the power? Why 2 to the power? Because it is a bitwise operator. And how many bits you are having availability? 2 bits, 0 and 1. Other than that, you don't have any other bits. So always bitwise operator means we're talking about 2 bits, 0 and 1. So that's why it is always 2 to the power. Multiplying the number by 2 to the power number of bits. 2 to the power number of bits. Okay. 2 to the power the number of bits by which we have to make the left shifting. By which we have to make the left shifting. See here, this is the number. 5 is the number. And by 3 we have to make the left shifting. So answer is, as per this, left shifting of a positive number. So left shifting of 5 means multiplying the number. Let me multiply the number by 2 to the power. 2 to the power. Number of bits by which we have to make the left shift. We have to make the left shift here by number of bits is 3. So basically 5 into 2 to the power 3. Exponentiation is having high precedence. So it will become 5 into 8 and hence the result will become 40. With same explanation, 4 into 2 to the power 4. 4 into 2 to the power 4. So basically it becomes 4 into 16 and hence it will become 64. Right shifting is exactly the same story. Only thing is that instead of multiplication, it will become the division. And hence you can understand that positive number left shifting and positive number right shifting is not a very big issue. Very simple one. This will be dividing the number by 2 to the power the number of bits by which you have to make the right shifting. Let's take an example to understand how to go for that right shifting. Suppose we are having 5 right shift by 3. 5 right shift by 3 means what? Tell me, students. What will be the answer? 5 dividing the number by 2 to the power number of bits. What is that? 3. That means what? 5 by 8. 5 by 8 means we will take the quotient. Hence the answer will be 0. Hence the answer will be 0. So right shifting of this means it's 0. Very good. Next, sir, left shifting of a negative number and left shifting of a right shifting of a negative number. How to do that? Observe carefully. So before telling you left shifting of a negative number and left shifting of a positive number, automatically their complement operator will come into the picture. Left shifting of a negative number. How the things actually happens here. Left shifting of a negative number. What is the algorithm we are going to follow? Step 1. Represent the given number. Which number? Negative number. Negative numbers are always represented in computer memory in the form of 2's complement form. Negative numbers are always represented in our computer memory in the form of 2's complement form. So represent the given number. Here given number means definitely a negative number. How? Represent the given number by using 2's complement form. By using 2's complement form. What does it mean? Suppose for example, a given number is there for which you have to make the left shift. Then what is the first activity you are going to do? The very first activity that we are going to do is that represent the number in 2's complement form. Suppose it is given -2 left shift by 3. Here what is the number? -2 is the number. So what is the first activity we have to do? We have to represent -2 in the form of 2's complement. Now here the question that may raise is, what about the 2's complement? What about 2's complement? Okay. 2's complement means 1's complement plus 1. 2's complement means 1's complement plus 1. That is called 2's complement. So what we are going to do here, first -2. How to represent -2? Forget about -2. First you think about how you represent 2. First you think how you represent 2. Yes, 2 is 1, 0. But the problem here is that you will not be able to get the correct answer most of the cases, if you represent it like the number by 4 by 2 digit, 4 digit, 6 digit, 8 digit, no. Just go for, as per this particular compiler is concerned, it is taking the integer size as 4 bytes. 4 bytes means how many bits? 32 bits. So represent it in the form of 32 bits. 4, 5, 6. How many bits are there here? 8. I have to represent the number in the form of 32 bits. No problem. Let me copy this. 32 bits now. 8 plus 8, 16. Of course, definitely on the left hand side. Here, here. Okay, na? Just we represent the number in the form of 32 bits. So this is the representation of 2. Okay, what I have to get? 2's complement of this number. What is 2's complement? 1's complement. What is 1's complement? Symbolically, 1's complement is denoted in this way. Symbolically, 1's complement is denoted in this way. This is denoted as 1's complement. Tilde 2. What it will do? All the zeros that are present here, it will convert it to 1. All the zeros will be converted to 1. And all the ones will be converted to 0. That is what is the role of complement operator or bitwise not. So for the discussion of this one, parallelly, this discussion is also done. Where it is? Where is that one? Yeah, 6th one. These operator discussions are automatically coming here as a part of this discussion. This is automatically coming here. Bitwise not or complement. Okay. So 2's complement is ready. But I want 2's complement of 1. So that means what I have to do here? I have to go for plus of 1. I have to go for plus of 1. If I go for plus of 1, what is the result? Observe carefully. 1, 1 is 0 with a carry in 1. So this is the 1. This is that 1. Now from here to here, all 1 will be copy pasted. All 1 will be copy pasted. This is the result that we are getting in the form of 2's complement of the given number. Here, what is the 2's complement of the given number? Given number also is 2. Given number is 2. Given number can be anything, but I have to always get 2's complement of the number. And this 2's complement number, this is basically equivalent to your minus 2. This is the number, this is the binary number. Sir, why you are converting to binary number? Array, you are dealing with bitwise operator, na? All these are bitwise operator. You need bit. What is bit? These are bits. These are nothing but bits. So this is your minus 2, guys. This is your minus 2. So that means just now I completed the step 1, sir. Next and after that, what about this step 2? What about this step 2? Currently we are dealing with negative number left shifting, where the very first step is find the numbers 2's complement. Up to that we have done. Next, what is step number 2? Now I need to perform left shifting. Left shifting, step 2. What is step 2? Left shift the number. Left shift the number by using the number of bits by which you are asked to make the left shift. So you are asked to make the left shift by 3 numbers. So that means what I have to do? Now I have to left shift the number by how many bits? 3 bits I have to make the left shift. By 3 bits I have to make the left shift. So that means this fellow will be left shifted. This fellow will be left shifted. This fellow will be left shifted. So if all the numbers are left shifted by 3, then automatically what will happen? Automatically what will happen? Automatically what will happen? there will be a vacant position created. There will be a vacant position created. Where the vacant position will be created? If you shift towards left, then where the vacant position will be created? On the right hand side. So in my right hand side, 3 vacant position will be created. All the numbers are shifted towards left. So in my right hand side, 3 vacant position will be created. So how the number is looking now? This is how the number is looking like. This and 3 vacant position. 3 vacant position. Sir, how you got the number? Very simple, guys. If the number is shifted by 3 towards left, automatically he will be gone. This fellow will also gone. This fellow will also gone. So where this fellow will come? To the position of this fellow. Where this fellow will come? To the position of this fellow. So like this 0 will come here. Na? Every number is shifted to the left by 3 bits. Shifted to the left by 3 bits. Shifted to the left by 3 bits. This is what the number is looking like. Now for negative number left shifting, always remember step number 3. What is that? Fill up the vacant position. Fill up the vacant position on the right hand side by 0 value. Fill up the vacant position on the right hand side by 0 value. Then how it will look like? Here 1 0 will come, 0 will come, 0 will come. Next, what we are going to do? Before doing anything, make sure you arrange it in 8-bit form. 3, 4, 5, 6, 7, 8. Next. From here. 1, 2, 3, 4, 5, 6, 7, 8. From here. 1, 2, 3, 4, 5, 6, 7, 8. From here. 1, 2, 3, 4, 5, 6, 7, 8. This is the current status of the number after left shifting by 3 bits. This is the current status of the number after left shifting by 3 bits. After left shifting. After left shifting. This is the status. Okay, na? Next, step 4 and final step. What is that? In most significant bit, if the most significant bit, who is the most significant bit here? This is called most significant bit. This is called least significant bit. This most significant bit is called signed number, signed digit. This is called signed digit. It will decide the sign of the number, signed bit. It is called signed bit. Most significant bit or most significant digit is also called a signed bit. If most significant bit is 0, then very easy. Then just convert the number. Convert the number means whatever number you got. If the most significant is 0, in that case, then convert the number from binary to decimal to get the required answer. But very unfortunately, here the most significant bit is not 0. Then otherwise, that means if the most significant bit is not 0, that is the meaning of otherwise. Leaving the most significant bit means what? We are not going to consider the most significant bit. Why? Because Most significant bit is for the signed representation. Most significant bit is the signed representation. So we're not going to consider the most significant bit. Otherwise, leaving the most significant bit, take the remaining numbers. Take the remaining, not number, take the remaining bits. That means except the most significant bit. Take the remaining bits. Take the remaining bits. Whose complement? Take the remaining bits whose complement to get the required value. Now you see here, this is the most significant bit, which is 1. What they are asking? Leave that bit. Leaving the most significant bit, leave that. Take the remaining bits. What is the remaining bits? This is the remaining bits. Take this. So, as the most significant bit is 1, we are leaving that and taking the remaining bits. Taking the remaining bits. Then what we are getting? From here to here. From here to here. Now what they are asking after taking the remaining bits? Identify its 2's complement. Okay. So to get its 2's complement, first what I have to get? 1's complement plus 1. That is nothing but 2's complement. Now 1's complement of the number. 1's complement of the number. Is 1's complement of the number is, what is 1's complement is? 1 will be converted to 0. 0 0 0 0 0 0 0 0 0 0 0 0 0, then 0 0 0 0 1 1 1 1. This is the 1's complement, na? But actually one need to get what? 2's complement. That means plus of 1. Now what you are going to get after addition of this series? 1 1 0 with a 1 in hand. Again 1 1 0 with a 1 in hand. 1 1 0 with a 1 in hand. 1 1 0 with a 1 in hand. Now we are putting this one here. We are putting this one here. Now from here to here, from here to here, from here to here, all are nothing other than 0. One 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 one. Yeah, perfectly right. Then what is this value, guys? 1 2 4 8 16. 16 is the value. 16 is the value, but the algorithm is not completed yet. Here one more line is there. What is that line? Finally add minus sign. Finally add minus sign to find the required answer. So this is in the otherwise part. Finally add minus sign to add the required result. So what is the required? What is the value you got here? 16. And what about the final result? Final answer? Final answer. They ask you what? Add that minus sign. So minus 16. Let us verify it once. Execute, compile and run. Minus 2 left shift by 3 is minus 6. Easy, na? This is negative number left shifting. exactly same, almost same, just with a little bit difference. What is that? Let me copy this. I will make these small changes wherever it is required. This is negative numbers, right shifting. So right shifting of a negative number. Represent the given number as 2's complement form. Same. Right shift the number by using number of bits by which you are asked to make the left shift. Here it will be right shift. Fill up the vacant position on the, this time not right hand, left hand. If you make right shift, vacant position will be created on the left hand side. If you are making a left shift, vacant position will be created on the right hand side. Fill up the vacant position on the left side by not 0 value, by 1 value. Remaining stories are same. If the most significant bit is 0, then convert it, otherwise same. Let us go for one example very quickly to understand the right shift. Say -1 right shift by 4. This is the example we need to know. Mostly, sometimes you need to do it very fast, rough work. For that purpose, you have to remember -1 equivalent binary number is, guys, all 1. -1 equivalence binary number is all 1. Just for shortcut, I'm telling you. How, sir? 1. 1 means 5, 6, 7, 8. 8, 16, 24, 32. This is 1. What about 1's complement? All 1. 0. 2's complement of 1 I need. What I need to do? Plus 1. Now you see, plus 1. What is this? After taking the addition, all 1, na? So that means what? The 2's complement is nothing but negative number representation. This is nothing but what? This is nothing but your -1. This is nothing but your -1. So -1 means all are 1, sir. Okay. Now what they said? I have to make it right shift, right? So if you make a right shift by how many bits? 4 bits. So that means on the right, 4 vacant position will be created. On the left, 4 vacant position will be created. Everyone will be shifted to the right. So what will happen? On my left, 4 vacant position will be created. Let me create 4 vacant position. 4 vacant position will be created on the right hand side. This fellow will be out of the context. This will be out of the context. He will be out of the context. He will be out of the context. So that means we will have this 8, this 4 plus 4, 8, this 8, and then 4 vacant, and then this 4. Remaining 8, 8, and lastly you are having this 8. Now, here the most important point is, while filling it up, you cannot fill it up with 0 value. With what value you have to fill it up? 1. So that means once you fill it up, after filling it up, how the numbers will be looking like? Same. It will be looking like this, where all are 1. Next and after that, what is the thing? Most significant bit verification. What is that? 1. What does it mean? Leave that 1. Leave that 1. Take the remaining bits. Take the remaining bits. These are remaining bits now. Take them. Take them. Okay. Remaining bits. Take them. Then what to do? Take its 2's complement. First 1's complement. First 1's complement. plus 1 plus 1. Then what we are going to get? Plus 1. Okay, now? So this is the number. But is this your correct answer? No. Sir, finally you have to add that minus sign. Na? Answer. What is the answer? 1? No. What is the answer? Minus 1. Minus 1. Let us verify it once. Printf minus 1 right shift by 4 is equal to %d. What is our answer? Minus 1. Minus 16 and minus 1. Okay now guys, left shifting of a positive number, left shifting of a negative number. I hope everyone got it. So this is all about the bitwise operators, sir. For what is called Chetan, for negative number, even with multiplication, you will get the result. If you feel that I will not go for this approach, by multiplication, you can do that. But for right shift, it will not come in. Right shift, if you start dividing by 2 to the power 4, it will not come. But for left shifting, if you want to take that approach, you can take that. It will also work. For all numbers, it will work. Okay, na? But you cannot apply it for right, what is called right shifting of negative numbers. Then you have to take this approach. That's why I discuss both the algorithm for left shifting as well as for right shifting. Chetan, okay? Yeah. Bitwise AND, it is following that same logical truth table of logical AND. Same truth table of logical AND, whatever we have learned, it will follow that same truth table. Right? Only thing is that it will be working on bits. Bitwise AND will work on bits. Logical AND will work on that particular number. What is the logic for that? What is the logic for that? But other than that, truth tables are same. Here, what is that? Bitwise OR. Here also, the same truth table for logical or whatever we used, that is only is going to be used. Bitwise OR, see, if both are same, result will be 1. 0, 0, 1, 1. Different gives us 1. Different gives us 1. 0, 1, 1. 1, 0, 1. Alternate gives us 1. Right? Let us go for verification of one example here. Suppose printf 2 XOR 3 is equal to %d. 2 XOR 3. What will be the answer? This is for XOR operation. What will happen here? Bitwise XOR. Example 2 XOR 3. Okay, very quickly. 2. Always go for 32-bit representation. Even you know that, sir, 2 means 1, 0. Don't go for that 2-bit representation. That's a bad habit. And in some cases, you can go for mistake also. If you have this habit of representing with two digits, 2 bits, 3 digits, 3 bits like that. Always go for 32-bit representation. Next, XOR operation. So alternate gives us 1. So 1, 0, 1. Remaining all are 0 na? Remaining all are 0. Alternate gives us 1. So what is the expected answer? 1 is the expected answer. Let's see. Execute, compile and run. Yes, 1 is the expected answer. So once we have done this, why not the remaining 2? Simple. Printf. Same. 1 is with bitwise AND and another is with bitwise OR. Only one bar sign. /n. First one is what? Bitwise AND. What will happen? And 1 1 1 0 1 0. Then what is the answer? Next, bitwise OR. 1 0 1 1 1 1 1 1 1. What is the answer? 3. Let's see. First one is 2, next one is 3. 2. Acha, here one /n is needed. Execute, compile and run. 2 3 1 minus 16 minus 1. Let me take that one also. Complement. Complement of 2. Complement of 2. Observe carefully. Don't think just by complementing you will get the result. No. Most significant bit will come into the picture. Here. Suppose you are asked to find complement of 2. First 2. What is 2? What is 2? Sir, 2 means this. 2 means this. What about complement of 2? What about complement of 2? Sir, all are 1. 0 will be 1. 1. 1. 1. 0 1. Now do you think this is the answer? We will convert it to binary to decimal and that is the answer? No. Again, as the most significant bit is 1, remaining story is same. Where I wrote to that? From here. As the most significant bit is 1, we are leaving that and taking the remaining bits. Remaining bits means up to this. Once complement of the number, this is all 0, lastly 1 0. 1 0. Plus 1. What is that? 1 1. What is that? 3. But is 3 is the answer? No. Final answer is -3. Final answer is -3. So 2's complement will be what? 2's complement will be what? -3. Let's see. 1, 2, 3, fourth one. Execute, compile and run. 2's complement is -3. So as we have taken everything, why not positive number, left shifting and right shifting? What is that? Firstly, what we have done? 2 left shift by 3, na? 2 left shift by 3 is equal to %LD 2 left shift by 3. And then printf, another one, /n 2 right shift by 3 is equal to %LD 2 right shift by 3. Positive numbers, negative numbers. This was bitwise and. This is bitwise and. This is bitwise OR. Lastly, bitwise XOR. Bitwise complement. Left shifting and right shifting of positive number. Left shifting and right shifting of positive number. Same. Left shifting and right shifting of negative number. That's it. That is the discussion with respect to bitwise operator, guys. Everything is done. Now it's not the end of the discussion, because tomorrow we will have session, guys. Normally Saturday is holiday, but tomorrow we will have session. Okay. Tomorrow when we'll meet, we will go for practicing of this left shift operator, right shift operator, positive number, negative number, and everything. So next class you have to be ready with your pen and paper, right? And I will give you multiple examples which we have to solve. Thank you, guys. Yeah. Okay, students. So let us start today's session. In our last session, we learned about bitwise operator concept. Bitwise AND, bitwise OR, bitwise XOR, then left shift, right shift, and of course, left shift and right shift of positive numbers and negative numbers, followed by bitwise complement also we discussed. Now let us practice some question from this bitwise operator. Say for example, suppose here I'm writing one code here. Say unsigned int I is equal to 0x80 followed by printf statement printf here %d and then I left shift by 1. Now here it seems a very easy problem statement, but so many things we need to discuss before we can go and attempt to solve this question. So what are the important point here is, first is, what do we mean by unsigned integer? What do we mean by unsigned integer? Or let it be. Suppose for example, whenever we are dealing with integer, for integer, size of integer is 2 bytes. Always, no, not always. Sometimes it may be 4 bytes also. So either 2 bytes or 4 bytes. Depends on the compiler. Size of integer is 2 byte or 4 bytes. Depends on the compiler. Now, suppose for example, currently we are considering about 4 byte integer. If it is a 4 byte integer, you observe carefully here. For 4 byte integer, this is the range. 4 byte means, guys, 32 bit. 4 byte means 32 bit. 2 byte means 16 bit. So 4 byte integer means 32 bit. And this is the range. Minus 21, 47, 48, 36, 48 to 21, 47, 48, 36, 47. So what is the range for 4 bytes? Minus 21, 47, 48, 36, 48 to 21, 47, 48, 36, 47. This is the range of 4 byte integer. But this range is a signed range. This range is a signed range. Why so? Why signed range? Because you bring sign into picture now. Positive, negative. Sign you bring into the picture. Sign you bring into the picture. That's why it is considered as signed range. Now, if I try to pictorially interpret this particular range, if I try to pictorially, diagrammatically interpret it, then how it will look like? 2 side is there, positive side. Nothing is mentioned means positive side. Another is negative side. So in the positive side, from 0, 0, 1, 2, dot, 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 then 21, 47, 48, 36, 47. That is the positive side value. Similarly, minus 1, minus 2, dot, 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 minus 3, dot, dot, dot. Negative side last value is minus 21, 47, 48, 36, 48. See, minus 21, 47, 48, 36, 48. This is the negative value. This is the last negative value in the negative side. Now, as because sign, positive sign, negative sign, it is there. That's why it is called as signed representation. That is why it is called as signed representation. The same thing, the same range, if I go for unsigned, the same thing if I go for unsigned, for the same 4 byte integer, the range will become 0 to 42, 94, 96, 70, 42, 94, 96, 72, 95. This is the value. This is the value. So how to remember? If you remember this one, this is very easy to remember. How? You multiply 21 with 2 times 42. 47 2 times 94. 48 2 times 96. 36 2 times 72. 47 2 times 94 plus 1, that is 95. Just that plus 1. Last one 2 times or plus 1, 95. So very easily you'll be able to remember this. Now, once this is the representation of unsigned, then its pictorial representation is something like this. 0, 1, 2, dot, dot, dot. No sign, nothing. No sign, nothing. Last value is 42, 94, 96, 72, 95. This is signed and unsigned of 4-byte integer. Unsigned representation. This is signed representation. This is signed range. This is unsigned range. This is unsigned representation. This is signed representation. This is signed representation. Now you see the beauty, guys. Say for example, forget about this code. I will bring this later. Say for example, guys, I took one integer here. I took one integer here. Int I is equal to, I'm taking this value, guys. Last value in the signed range. What is that? 21, 47, 48, 36, 47. This is the last value in the signed range. Na? This is the last value in the signed range. Okay. Now I want to print that value. I want to print that value. What is the problem? Easily I can print that. Na? No problem. Let me print that value. Printf %d I. Printf %d I. What will happen, guys? The value will be printed. This value will be printed. This particular value will be printed. Where is the proof, sir? Execute, compile and run. Acha, compile and run. Execute, compile and run. The value that we expected is getting printed. The value that we have inputted here is getting printed here. Now observe very carefully, guys. I made a small change here. What is that? I made 48. Now see, students, in the positive direction, means in the positive side, do you really have the existence of this value? Do you really have existence of this value? No, sir. Up to 47 I have. Up to 47 I have the existence. But 48 I don't have. Then 48 will be where? Other side, na sir. Other side. 48 is other side. But if you go to the other side, this is negative value, na? This is negative value, na? -1, -2. How far? Sir, this one. 21, -21, 47, 48, 36, 48. This is the negative value here. But you give what? Positive 48. Then after this, but after this positive 48 is not there. What is there? Negative 48 is there. So it will pick up that value. It will pick up that value and it will print the negative value. Check it out here. Execute, compile and run. (21, 47, 48). Not 35, guys. 36, 48. Let me compile and run one more time. Execute, compile and run. See these, guys. What value it took? Minus, na? But I entered what value? Positive. I entered what value? Positive 21, 47, 48, 36, 48. But it is taking which one? Negative 21, 47, 48, 36, 48. Why? Because, sir, in the signed representation, this positive value, whatever you are taking in the I, in the signed representation, I don't have that. That's why what I did, I took the negative value, which is equivalent to this. Acha, then if it is 49, what will happen? If it is 49, sir, it is increasing now. One by one, it is increasing. 47, 48 means negative 48. Then you are going to this. 49 means, sir, it will be negative 47. 49 means it will be negative 47. Really, sir? Check it out. 1 minute, guys. Check it out. 1 minute. Yeah. See this. Execute, compile and run. Negative 47, na, guys? Sir, if I make it 50, then minus 46 will come, na? Yes. Execute, compile and run. Okay, na, guys? Perfect, na? Sir, that means if you are talking in terms of unsigned, now what will happen? This is signed. If we don't write anything, guys, by default it is considered as signed int. By default, integer is considered as signed int. I want to make it unsigned. Then you have to write unsigned. Then you have to write unsigned. But if you don't write anything, sir, by default it is signed. See, guys, if it is unsigned and you are writing here 48, is it really exist? Yes, sir, it's exist. Then what will be printed? Sir, that one will be printed. That one means positive, na? Positive, sir. Achha, 1 minute. I didn't save the code, guys. Let me save this. Execute, compile and run. Achha. Whenever you are taking unsigned, guys, whenever you are taking unsigned, you have to change the format specification also. You have to change the format specification also. The format specification for unsigned is %u. The format specification for unsigned is %u. Now you see this. Execute, compile and run. Perfect, na? 48 you give, 48 is coming. Sir, if I take 49, 49 will come. Execute, compile and run. 49 will come. Sir, if I give 50, 50 will come. Positive 50 or negative 50? No. Unsigned, na? Positive 50 will come. Execute, compile and run. So that means what? Observe here carefully. Unsigned positive 48. Unsigned positive 48. It is actually equivalent to signed negative 48. Unsigned positive 49 is equivalent to signed negative 47. Same way, unsigned, this value, guys, what is that? 42, 94, 96, 72, 95. Sir, it is unsigned. The exact value will be printed? Yes, exact value will be printed. Exact value will be printed. But if I make it signed, you identify what is the equivalent value for this? What is the equivalent value for here? -1. Oh, -1 will come, na, sir? Percentile D. Because now we are dealing with signed. Execute, compile and run. Okay, na? Sir, if I make 96, 0 will come. Execute, compile and run. Sir, if I make 97, 1 will come. Now it will be rotating in the circle. Execute, compile and run. Okay, now guys, this is the discussion of signed and unsigned. This is the discussion with respect to 4-byte integer. This is the range for signed. This is the range for unsigned, and these two are diagrammatic representation of signed and unsigned respectively. Okay, now let me go for that original example. I'm removing this. Now here, which thing is unknown to you in the entire coding? This thing is unknown to you? No, not anymore. After that, no. This is not known to me. This is not known to me, sir. What it is? If a number is prefixed with, if a number is prefixed with, if a number is prefixed with 0 small x or 0 capital X, then it is considered as hexadecimal number. Then it is considered as hexadecimal number. Hexadecimal number means what, guys? 0 to 9 same as decimal. 0 to 9 same as decimal. After that we are having A, B, C, D, E, F. You can think small a or capital A. Both are allowed. Both are allowed. This is hexadecimal number. Now, whenever we keep any hexadecimal number here, whenever it will be stored in the variable, it will automatically convert it to it will automatically convert it to decimal number. It will automatically convert it to decimal number. If a number is prefixed with 0x or capital 0x, it indicates the number as hexadecimal number. It is considered, better to write, it indicates the number as hexadecimal number. But internally, whenever it will be stored in the variable, what value it will be stored? Is it the decimal value it will be stored, or is it the hexadecimal number it will be stored? It will be the decimal number. That means hexadecimal to decimal conversion it will take place, and then the number will be stored. How to convert hexadecimal to decimal? Very simple. 0x80. Now what you have to do is that you have to multiply first 0, that means the first digit, with 16 to the power 0. Why 16, sir? Because for hexadecimal, base is 16. For decimal, base is 10. For binary, base is 2. So first digit 0 into 16 to the power 0. Next, plus, what is the next digit? 8 into 16 to the power 1. So what is the final result? This part is basically 0 and this part is 8 into 16. That means what, guys? 128. That means what, guys? 128. So that 128, now it is becoming very easy. Now easily you will tell the answer. 128 left shift by 1. Will you take time to give answer now? Tell me, guys, what is the answer? 128 left shift by 1. Yes, Chetan, very good. Sir, it is 256. Immediately we can say that it is 256. Yes, perfect. 256. Now let us verify. Execute, compile and run. Okay, now. So what we have learned from this particular small coding, the coding is very small here, but you know, internally so many things we have learned. First, complete understanding of signed and unsigned. Then hexadecimal number, how it is represented, and if it is written, how to consider. Okay, guys, let us go for the next one. Monday onwards, I will share the documents with you. All the documents, whatever prepared till now. Monday onwards, every day I will update and I will share all the documents starting from beginning with you guys. No need to worry. Till now, whatever discussed, we have a record here. How many questions, guys? Such a numbering somehow is not continued here. I will update this by making it, giving the numbering and making the perfect document. Monday I will share with you. Okay, sir. So signed, unsigned, we completely understood. Let us go for another example here. Suppose, for example, unsigned int a is equal to 0x for hexadecimal, and I'm writing so all are f. All are f, because f, just now you have learned now, is a valid hexadecimal number. Okay. Next, and after that, unsigned int k is equal to complement of a, and then printf percentile d a comma k. This is the code I have to execute. Now it is very simple. How is that simple? You see here 0x ff. What it means? 0x ff, what it means? You see here 0x ff. Now among this, f indicates what? F indicates what I said now? 0 to 9 is same as decimal. That means whatever decimal 0 to 9, same as hexadecimal 0 to 9. Same as hexadecimal 0 to 9. These two fellows are same. 0 in decimal, 0 in hexadecimal, both are same. But if you say 10 in decimal, that will be equivalent to small a in hexadecimal. 11 in decimal, this is equivalent to small b in hexadecimal. Small b or capital B, guys, that doesn't matter. So in this way, 15 in decimal is equivalent to small f or capital F in hexadecimal. Okay, guys. So this f actually means what? 15. This f actually means what? 15. 15 in binary, how it looks like? 15 in binary. Sir, it will be 1111. It will be 1111. So how many f are there? 4 f are there. So that means the number will be 1111, 1111, 1111, 1111. This number's equivalent decimal number, will be the equivalent this hexadecimal's equivalent decimal. How can we do that? Very easily. What will be the equivalent decimal number for it, guys? Very simple, sir. 1248 16 32 64 128 256 512 1024 2048 4096, guys, 8192 16384 65,536 65,536. This is the value. 65,536. Is it 1248? No. 1 minute, guys. What is the value, sir? 1 plus 2 plus 4 plus 8, okay, plus 16, 32, 64, 128. 16, 32, 64 plus 128 plus 256, 512. 256, 512. Next, 1024, 2048. 1024 plus 2048 plus this one, 4192 plus 2048 na, 2 times 8 into 2, 16, 9, 4096. Next, 8192. 8192. Where it is? 256, 512, 1024, 2048, 4096, 8192. Yeah, next. 16,384. Is it? Yeah. Plus last one. 32,768. If you take the summation of it, guys, you will get 65,535. If you take the summation of it, you will get 65,535. Later, you will go for the addition. Anyone have the doubt, sir, why you started adding 1 plus 2 plus 4 plus 8? Anyone there? Sir, I didn't understand these things, sir. Confirm once in the chat box. Anyone there who didn't understand, sir, why you write those? I didn't got it. Good. No one is there. Everyone got understand. So what is the current value in decimal? 65,535. And that's an unsigned number, guys. That is an unsigned number. Okay. So 65,535 will definitely be somewhere in the positive side, sir. In this positive side, somewhere it will be there. Of course, in case of unsigned, everything is positive. Everything is positive. In case of unsigned, everything is positive. But while printing this A, guys, I should use percentile U, but I'm using percentile D. For unsigned number, what I should do? Go for percentile U, but I'm using what? Percentile D. Percentile D is for what? Signed, not for unsigned. But we are going for signed, sir. Your number is a positive number, which is the unsigned, and we are using percentile D. Any issue will come? No issue will come, sir. Why? Because you see, unsigned 65,535 will be there somewhere in this range, na? Will be there somewhere in this range, na? Similarly, if you come for the signed, there also it will be somewhere in this range. There also it will be somewhere in the range. So that is why whether you are using percentile U or percentile D, at least for positive numbers, no effect will come. No effect will come. But once the number will go beyond this value, na sir, when this number is go beyond this value, then automatically percentile D, percentile U will affect. Percentile D, percentile U will affect. But as long as it is a positive number, percentile D, percentile U will not have any effect. So that is why whenever I will print this one, guys, this A, which I should print with percentile U, I'm printing with percentile D, still it is not going to have any effect, and I will get 65,535. I will get 65,535. Next. Sir, complement of A should be given to K. Yesterday only I have learned, na, complement of operation. Currently, what is your A? This is your A. This is your A. Make it complement. Sir, before making it complement, do one thing, sir. Make the number as a 32-bit representation. Make the number as a 32-bit representation. What I need to do here? 1, 2, 3, 4, 5, 6, 7, 8. Another 8 zeros. Another 8 zeros I added. Okay. So this is the number. Complement means, sir, all zeros will be converted to 1. and all ones will be converted to 0. All one will be converted to 0. This is my complement of A. This is my complement of A. Observe carefully, guys. This is my complement of A. Now, what is this number? What is this number? Are you ready to directly convert to decimal? No. Most significant bit is 1, sir. Now, as the MSB is 1, what to do? Let us take leaving the first digit. We have to take the remaining digits. Whose complement? What to do? Leave this one, guys. This is remaining digit, na? This is remaining digits. It's 2's complement I need to take, sir. But 2's complement is what? First go for 1's complement of this. 1's complement of this is, what will be the value, guys? Sir, here all will be 0, na? Yes. Here all will be 0. Then here all will be 1. And then again all will be 1. This is the 1's complement. Now, sir, I have to take 2's complement. What do I have to do? Plus 1. What is the result for that? From here. What is the result for that? 110 with a carry 1. 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 Again. 110 with a carry 1. 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 Carry 1. Carry 1. Carry 1. Now that carry is here. Now the carry is here. Remaining up to this, all will be 0. Tell me, guys, any issue up to this? No. What is this number, sir? What is this number? 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, okay, 8192, 16,384, 32,768, 65,536. Super. 65,536. What is the number, guys? 65,536. Is it the final answer? No, sir. What is the final answer? Means the K value, guys. Means the K value. Final answer means I'm talking about K value. K is equal to, you assign now. What you are assigning? Complement of A to K. So now K is equal to will be what, guys? So that one I have to bring into the picture now. Minus 65,536. Minus 65,536. But K is a unsigned integer, sir. K is a unsigned integer. In a unsigned integer, forcefully you are assigning minus 65,536. In an unsigned integer where everything should be positive. In an unsigned integer where everything should be positive. Suppose for example guys, here, forget this for the time being. I'm taking one unsigned int I is equal to I'm taking -1. No, sir. It's not capable of taking minus value. It's capable of taking positive value. Still, I'm taking that. What will happen? What will happen? Sir, internally it will be considered this -1's equivalent value. So -1's equivalent value is what? This thing. So internally it will be considered this thing, sir. Even you write -1, internally it is considering this value. Really, sir? Really it is taking this value or not? Let's see. Can we prove that really it is taking or not? Printf percentile u. I'm writing I. Printf percentile u. I'm writing I. Execute, compile, and run. Need to keep this thing under comment line. Yeah. Compile and run. Execute, compile, and run. See this, guys. You given -1, but internally it is considering what? Internally it is considering what? Understanding, guys? Understanding? This is -1. This is this. This is what it is considering, sir. Sir, now what I will do? If I make it percentile D, what will happen? If you make it percentile D, what will happen? Internally, what it is considering? This value. Internally, what is considering this value? Now we are using which one? Format specification? Percentile D. That means you are asking, please print the value. Please print this value like a signed number, because you are using percentile D format specification. Please print this value like a signed number. Then what they will do? It will print this like a signed number. If it is printing this like a signed number means what? If it is printing like a signed number means what? -1 should come now, guys. -1 should come only. Execute, compile, and run. Understanding? Let's come back to our discussion. Up to this we have done. What is the K value, guys? Sir, -65,500. Where? -65,536. But you are printing with what? Percentile D. Then which value should come? Negative of this will come, sir. If you go for percentile U, sir, then I don't know what will come. -65,536 means somewhere it will be there. Somewhere it will be there. -65,536 means somewhere it will be there. These equivalent numbers corresponding unsigned number will be printed. That is what number? How can I tell, sir? Then I have to go for numerical and manual calculation. Somewhere it will be there. That number's equivalent unsigned will be pick up and that will be printed. But currently I'm not doing that. Currently I'm printing with what? Percentile D. Oh, that means the negative itself will come, sir. That means the negative itself will come. Execute, compile, and run. Tell me, guys, understanding? Any issue? Any issue? Okay, na? Next. Unsigned int A is equal to -1. Unsigned int B is equal to 4. Here, A left shift by B. What is the answer, guys? That means simple thing is that, sir, -1 left shift by 4. As simple as that, na? Negative number left shifting. Though we have learned yesterday what is the process, but even you can go for shortcut approach, na, guys? Even you can go for shortcut approach, na? If you go for shortcut approach, what will be the value? Tell me. What will be the value? Yes, -16 only. Achha, one extra thing is coming. Why? Execute, compile and run. Any doubt, guys? Any issue? Next. You have to tell me. Bring your pen and paper and you have to tell me what is the answer. (16 and 31). Okay. What about others? Ketan is telling, sir, 16 and 31. Let's see. Others? Can I start giving you the clarity? Okay. Sir, this is super easy. 32 right shift by 1. That means divided by 2 to the power 1. That means this is 16. No doubt about that. Where we will focus? Complement of yeah. See this, guys. M is equal to 32. 32 means 1, 2, 4, 8, 16, 32, na? 1, 0, 4, 0. 1, 2, 4, 8, 16, 32. Yeah, make it 32 bits. Currently, this is 8 bits. Next, 1, 2, 3, 4, 5, 6, 7, 8, 16 bits. Next. Next. 32 bit is ready. Complement. Complement of M is equal to 1, 1, 1, 1. 0, 1. Is this the answer? No. As the MSB is 1, we leave it and consider the remaining bits whose complement. Remaining bits is what? These fellows. It's 2's complement I need to take. First, what you have to do? It's 1's complement is, let's go for it. Okay, 2's complement. 2's complement, this fellow plus 1. What is that result, guys? Almost same. Here will be 1. What is that value, guys? 1, 2, 4, 8, 16, 32. Check it out. 1, 2, 4, 8, 16, 32. Tell me, guys, what is the value here? Chetan, what is the value here? What is the value here? 1, 2, 4, 8, 16, 32. What is the value? Others, everyone, what is the value? What is the decimal value for this? 33. Correct. 33. Is it the final answer? No. What is the final answer? Minus 33. This minus 33 will be printed here. So what answer we will get? For first one, 16. Next one, minus 33. Check it out. Execute, compile and run. Everyone understood? Everyone got the clarity? Tell me, guys. Are you understanding or not? Yes. Next and after that, one more. You have to tell me the answer. Unsigned int a is equal to -1. Unsigned int b is equal to 15. Printf %d a left shift by 1 %d b right shift by 1. You have to do it, guys. Yes, correct. Chetan, this time your answer is correct. But how you can do this with this much speed? This is okay. This is easily you can guess it. But this one, how can you do that with that much speed? Shortcut method you applied, no? Shortcut method you applied. Okay. -1, it actually means what? -1 left shift by 1. So -1 into 2 to the power 1. Yes, perfect. Execute, compile and run. -2, 7. Let me give some space here so that you can see that. Execute, compile and run. This is all about the shift operator, guys. So almost all the operators, whatever are existing, we discussed. Let me go for one more. Next week we will start flow control, guys. Int I is equal to 45, left shift 3, right shift 2, left shift 1. And I want to print that. What is the answer, guys? Let me show you precedence and associativity chart. Precedence and associativity chart. As it's not there in my machine, another machine maybe I have that. Okay, no problem. I will show you that. I will share that chart with you. Precedence and associativity chart have to be followed here, sir. Left shift, right shift. Left shift, right shift. Both are having same precedence. Correct. Associativity is left to right. Associativity is left to right. Modulina, your answer is correct. So what I will do, sir? First this fellow. 40 right shift by 5. What is the answer? 1. Okay. Next, 1 left shift by 3. 8. 8 right shift by 2. 2. 2 left shift by 1. Super. Very easy, sir. Just the knowledge of precedence and associativity, enough. Super, na guys. People say that C programming language is very difficult. No, not at all. Depends on how you got the delivery. Based on that, difficult or easy it comes in that way. Let me go for another one. I is equal to 10 greater than 9 greater than 7 less than 8. Tell me, guys, what is the answer? Yes, Chetan, your answer is correct. Yes. 1 is the answer. Execute, compile and run. Simple. Greater than, less than. Both are having same level of precedence. Associativity left to right. 10 greater than 9 returns what? 1. 1 greater than 7 returns what? 0. 0 less than 8 returns what? 1. Super. Last one. X is equal to 10, y is equal to 15. X XOR is equal to y, XOR is equal to x, XOR is equal to y. Printf percentile D xy. If you know this, immediately will react. Otherwise, you have to go for calculation. If you know the answer of this, then immediately will react. Okay, let me tell you. Swapping of two numbers, guys. Swapping of two numbers. So whenever we have done swapping of two numbers, we used to go for multiple approaches, using third variable, without using third variable, right? Among those options, one of the option is by using bitwise XOR also, we can go for swapping of two numbers. That is a possibility that can be done. How to do that, sir? This is nothing but the logic for that. It is called shorthand assignment operator, guys. This is called shorthand assignment operator. What it means, sir? Suppose if you are having x is equal to x plus 5, no need to write that. You can write x plus is equal to 5. You are having x is equal to x star 3. You can write x star is equal to 3. This is called, this star is equal to is called shorthand assignment operator. Less you have to write now, that's a shorthand. Now, if you carefully look into this expression, it actually means x XOR is equal to y, y XOR is equal to x, x XOR is equal to y. This is the coding actually, sir. X XOR is equal to y. X XOR is equal to y actually means what, guys? X is equal to x XOR y. It means what, sir? Y is equal to y XOR x. And it means what? X is equal to x XOR y. X XOR y. Okay, na? Now you observe here. X XOR y. That is what you have to do. 10, 15. X is 10, sir. See this? X is 10. Y is 15. What we will do? 10 means, guys, 1, 0, 1, 0. 15 means 1, 1, 1, 1. But you have to go for what? 32-bit representation, sir. Always go for 32-bit representation. But it will take a bit time, na, sir. Are how many times you will do? Only once, na? Why you are worried about time? Every day you are going to do that? No. That means only one time. Or if it is one time activity, if it is taking a bit time, what is the problem? Done. Go for it first time. X XOR y. XOR means alternate gives us 1, sir. 1, 0, 1. 1, 1, 0. 1, 0, 1. 1, 1, 0. Alternate gives us 1, same gives us 0. Now what will happen? From here till end, everything will be what, guys? 0. Arrange. What is this number? What is this number, sir? 1, 2, 4. Okay, na? 1, 2, 4. 1, 2, 4. That means what? 5. Currently, the value of x is 5. Next is what? Y is or x. This is my y. This is my y. XOR x. Currently x is what? 5. Currently x is what? 5. That means what? This. Go for it. One, one. Same is 0. 1, 0, 1. 1, 1, 0. 1, 0. 1, 0. 1 now, guys. Yes. Remaining everything 0. 9 or 10. 9 or 10. This is equivalent to 10. Given to whom? Y. So y value will become what? 10. Last. What you have to do? X XOR y. X XOR y. What is y? What is y? 10. What is x? 5. Okay. So this is x. This is y. This is y. Current value of y is 10. Don't forget. Go for it. 1, 0. 1. 1, 0. 1. 1, 0. 1. 1, 0, 1. Remaining all are. Remaining all are. You got the answer, guys. You got the answer. What is this? What is this, guys? 15. Given to whom? X. Lastly, x value is what? 15. Y value is 10. Initially, x value was 10. Y value is 15. So ultimately, what has happened here, guys? What has happened here in this coding? Swapping. Execute, compile and run. Okay, na? 15 and 10. Got swapping or not? Super. If anyone asks, write a program of swapping of two numbers in one line. I want the code to be written in one line. This is the logic. This is the logic to write the swapping of two numbers in one line. Thank you, guys. We will meet on Monday.
This conference will now be recorded.
Okay guys, so last week we mainly discussed about the operators. Now under the operators, almost 95% operators we discussed, their syntaxes, their working principle. Now which operators are left, sir? Of course, first bracket open, first bracket close is the operator. Explicitly we have not discussed, but whenever we learn function concept, this first bracket open, first bracket close will come into the picture. Like third bracket open, third bracket close is also an operator. When it will be discussed, when the array will be discussed, this will come into the picture. Next, dot operator, arrow operator. These two operators are mainly related to structure concept. So whenever we will go for structure discussion, these two operators will definitely come. Post increment and pre increment is a big discussion, not only here at the operator level, in different level, in loops, in functions, so many places will be there where this post increment, post decrement operator will come into the picture. So these are mostly the operators which currently we are not in a position to discussion, not in a position to discuss, but with time, with different chapters comes into the picture, we will go for a discussion of these operators. Next, this is already we discussed logical not, bitwise complement we discuss. This is another one, indirection star, or some people call it as a value at address operator. This also related to pointer concept. This also related to pointer concept. So when pointer will come, this operator will be discussed explicitly. Address of operator, we know that we discussed not bitwise and, it's address of operator. Every time scanf statement ampersand comes into the picture. Unary plus, unary minus, minus 5 is the unary minus. If you write only 5, that means unary plus, normal thing. Sizeof operator we discussed. Next and after that, one vital unary operator we missed, that is called typecasting. That is called typecasting. So today we are going to learn this one, this typecasting. Except that, see, multiplication, division, modular division, plus minus, left shift, right shift, we explored. Between conditional operator, sorry, comparison operator, greater than, greater equal to, less than, lesser equal to, we discussed. Equal to, not equal to, we discussed. Bitwise and, XOR, OR, we discussed. Logical and, logical or, logical not also we discussed. Logical not is a unary operator. This is nothing but conditional operator, already we discussed. Comma operator also we discussed. An assignment operator, equal to, we discussed. Short and assignment operator, in few questions we discussed. This will come, this fellow will also come. Now first let us concentrate on typecasting. Typecasting operator. See here all operators are unary operator because they work on one operand. That's why they are considered as a unary operator. So what is typecasting, sir? Typecasting is basically a conversion from one type to another type. What is typecasting, guys? Typecasting is a conversion from one type to another type. Typecasting. Today I will share all the notes till now. What is typecasting? Typecasting, a typecast is basically a conversion from one type to another. Typecasting is basically a conversion from one type to another. Now, what are the different type of typecasting we are having? Two different type of typecasting we are having. There are two types of type conversion. What are the two type of type conversion? Number one, it is known as implicit type conversion. Implicit type conversion means automatic type conversion. Automatically happens. I will show you with programmatic explanation. Implicit type conversion or automatic type conversion. Another one is there, that is called explicit type conversion. Another one is there, that is called explicit type conversion. So these two type conversion we are having. One is implicit or automatic type conversion. Another is explicit type conversion. Now what is Implicit type conversion. What do you mean by implicit type conversion? Implicit type conversion means we are not responsible. Compiler is responsible to perform this type of typecasting. We will not do anything. Everything will be taken care by the responsibility will be taken care by the compiler. So compiler is responsible to perform this type of typecasting. In C programming language, C automatically converts any intermediate value to the proper type. Any intermediate value to the proper type. What it means? Converts intermediate value to the proper types. What it means? It means that, suppose for example, for usual conversion, for usual typecasting, it follows a particular order. What is that order? I will let you know that order. But before that, let me go for an example and then I will show you what is that order that actually it follows for automatic typecasting. Say here, just I'm writing one program here, int main. Say for example, I'm having one variable of what type? Double A. And I'm having two int variables. Int x is equal to 6, y is equal to 4. Now what I'm doing here, I'm writing a is equal to x by y. A is equal to x by y. One double variable, two integer variable. I'm taking their division, as simple as that. I want to print the value. Which value? Sir, I want to print the value of a. If you want to print the value of a, what format specification will be required? Because you are using double. So for a double, what format specification will be required? It will be like elif, long float. It will be like elif, long float, return 0. Now in this case, what will be the output that will be coming, sir? What output will come? Observe here. This is my coding here, sir. What is the output that will come here? This line, no problem. This line also no problem. Third line, simple. X by y means what? 6 by 4. 6 by 4. Here what is going to happen? 6 divided by 4. As simple as that. What operator you are using? Normal division. Normal division gives us what? Quotient. What it gives? Quotient. This is called quotient. This is known as quotient. And this is known as remainder. This is known as remainder. Normal division gives us what? Quotient. So after division, what is the value of a? Or rather, after division, what is the value of this quotient? 1. Integer division, no, sir, 1. Now what is the statement is becoming? A is equal to 1. A is equal to 1. A is what type and 1 is what type? Sir, A is a double type. 1 is a int type. 1 is double type, 1 is int type. What will happen? The lower data type will be automatically converted to higher data type. So how we will remember, sir? How we will remember this thing? Observe here. Say for example, what is the exact, where it is, guys? Yeah. So what is the exact chart, sir, that it follows for conversion? First, it is int. On top of that, we are having unsigned int. Now these words are not new anymore to you. unsigned int. After that, we are having long, then unsigned long. Next one after that, long. That is also a data type, guys. Long. I'm not satisfied with long value. I want much more larger value than long data type. Then you can go for long. Next, we are having unsigned long followed by unsigned long. Then we are having float. Then we are having double. Then we are having long double. This is usual arithmetic conversion. This is usual arithmetic conversion. That means what? This int, it will be automatically converted to what? Unsigned int. Similarly, unsigned int will automatically converted to long. He will be converted to unsigned long. He will be converted to long. He will be converted to unsigned long. He will be converted to float. Float will be converted to double. These things you don't have to do anything. Implicitly it will happen. That's why called automatic typecasting. So currently, as per our example, the value of A is 1, which is int type, and A is double type. Now, as per this chart, the int data type will be automatically converted to double. And the value of A will become, after conversion, the value of A will become 1.6 zeros. How many zeros? 6 zeros. Why 6 zeros? That's a convention. For any real number after decimal point, 6 zeros get printed. That's a convention. Based on convention, we just have to know that it's a convention. Now you see here, if I execute this code, and I'm printing with %lf, so 100% it should print 1.6 zeros. 1.6 zeros. So who converted your 1 to double type? You converted? No sir, I didn't convert it. It is implicitly happening. This promotion takes place implicitly, internally. That is why it is considered as implicit typecasting. The usual arithmetic conversion are implicitly performed to cast their value to a common type. So the compiler first performs what? Integer promotion. After that, if the operands still are having different type, next level. So continuously they are converted to the upper type. Which upper type? The upper type which is there in the hierarchy. The upper type which is there in the hierarchy. So here also int started from the beginning, gradually converted to double. That's the reason we are getting here as the output 1.6 zeros. No, sir. I don't want to get 6 zeros. Then what you are expecting? Sir, I want to get 1 point. If you divide 6 by 4 now, 1.5 I want to get, sir. 1.5 by 1. Then you have to go for explicit typecasting. Then who is responsible for that? Programmer is responsible for this type of typecasting. Typing in the editor, na, that's why whenever we type 4, it thinks that it's a loop. And these things come automatically. For this type of typecasting. Now, when it is required, guys, it is generally required whenever we are assigning bigger data type value to smaller data type variable. Generally, this is the case where explicit typecasting is required. What is the syntax, sir? What is the syntax? Syntax in C. What is that? Simple. Type followed by expression. What is this? Type indicates the data type to which the final result to make it of a particular data type. Let me bring one example here. Suppose in this code, I'm not expecting that 1.60s. I'm expecting 1.5 as the answer. What we will do here? In this case, you are not allowed to change the data type. Let us assume. If you are allowed to change the data type, then no problem, sir. If you are allowed me to change the data type, then no problem. To make it float, now definitely 1.5 will come and followed by 5 zeros. See? Think, guys, this 5 have no relation with 5 zeros. Thing is that after decimal point, 6 digit will be printed, whatever it may be. But suppose you are not allowed to change the data type here. You have to work with int x and y4, int y. You are not allowed to change the data type. But still you are expecting that result. Normally not coming. Normally not coming. Not coming. What we will do? Here out of x and y, any one of them, your choice, either x or y, you can make that explicit typecasting. What is the syntax? First bracket open, first bracket close. Then the required data type, what you are expecting, double. Required data type, whatever expecting. Yes. Now here, what is the beauty? Don't think that throughout the program x will now become double. No. Throughout the program means after line number 5, x type is still int. 7, 8, 9, 10, 11, 12. As long as the program is there, the type will be int only. But just in this line, you are asking x, can you please behave like a double? Can you please behave like a double? Just in this line, nowhere else. Then x will tell, okay, I will do that. But before that, you have to write that double inside first bracket open, first bracket close. Then I will behave like a double. What is happening here? I wrote. Then immediately, now this division is becoming 6 point, what is that, guys? 6 zeros. 6 digit after decimal point is always whatever is the value. Divided by. Why I have not typecasted yet? Why I have not typecasted yet? What is this y? 4. Now you see, one is double type and another is int type. Again, automatic typecasting will come into the picture, na? Two different data type, automatic typecasting will come. Arithmetic conversion. This int4 will automatically typecasted to 444. That means 4 followed by 6 zeros. Now the division becomes actually 6.60 divided by 4.60. That definitely 1.5 followed by 5 zeros. No sir, it will come. It will definitely come. No, sir, I will not do this to X. I will do this to Y. You do this. What will happen? First fellow is what? 6. Next fellow is what? 4.60. One is int, another is double. What will happen? Here also automatic typecasting will come into the picture and make it to double. Here also result will become 1.5 followed by 5 zeros. Means after decimal point 6 digit. This is what is known as explicit typecasting. Who is doing that explicit typecasting? Is compiler is doing or you are doing it? No, sir. I am doing this conversion explicitly as a programmer. That's why what we said, programmer is responsible for this type of typecasting. What is the advantage you are getting? Sir, when I am not performing this typecasting now, sir. When I was not performing, and anything you can do, I'm showing this with X. Sir, whenever I was not making the typecasting, sir, output was not coming perfectly. Some digit was lost. This should come. This is what is coming when I was not doing the explicit typecasting. So by doing the explicit typecasting, what benefit you achieved? Sir, the benefit that I achieved is that maybe a chance of loss of information. There may be a chance of loss of information in this type of typecasting. So whenever we are assigning higher data type value to lower data type variable, the most significant bit will be lost. The most significant bit will be lost. I don't want to lose anything, sir. Earlier I was getting 1.60. Some digits, some bits we are getting lost. I don't want to get it lost. Then go for explicit typecasting. So this is where typecasting is important. And remember, typecasting is also a operator basically, where it stands under the category of unary operator. Because whenever you typecast, you are basically typecasting on one particular operand. What it indicates? It indicates that it is a unary operator. Let me give one example, guys, based on this. What is question number currently we are having? Up to question number 22 I prepared, okay, with this everything written properly. Up to 22, 23, 24. I think I took up to 24 I prepared. 1 minute. This is 22, guys. '23. Okay. 24. Up to 24 I prepared. From 25 onwards I have to prepare. I will do that for you. 25, 26. These are roughly done. 27. Already we practiced this, na? 28 last week, last class. 29. 30. So last week we practiced at least 30 question guys. Yeah, question number 31. Let me tell you. Int a is equal to 9. Float x. X is equal to a by 2. X is equal to a by 2. Printf. I'm writing here percentile f, and here I'm writing x. Tell me guys, what is the output here? Perfect, very good. Chetan, very good. What about others? What is the output here? Yeah, good. 4.60. Execute, compile and run. Perfect. Next, in this coding, I'm making a little bit change. What change, sir? Today we have learned explicit typecasting, na? So I will make a small change here. What is the change? I will make here float. What is the output this time? What is the output in this case? What is the output I will get in this case? Yeah, 4.5 followed by 5 zeros. 4.5 followed by 5 zeros. So I think now you are feeling comfortable with this implicit and explicit typecasting. Let us move further. 4.6 zeros and 4.5 followed by 5 zeros. These are the two cases. Okay. Let us move to the next one. Now almost all the operators are discussed. Now anything arbitrarily, you people have to give the answer. Say for example here, relational operator I discussed, na? Relational operator discussed, conditional operator discussion done, shifting also done. Now let us assume this one. Int a. Int I is equal to 1 minute guys. Yeah, come back students. Int a. Int I is equal to 4. Here a is equal to 24 logical or minus minus I. I'm printing here printf percentile d a comma I. Yes. What will happen in this case? What will be the output? Everyone, What is the output, sir, in this case? Okay, let me tell you. Already we discussed about the logical OR story. In logical OR operator, we know that if first part is true, if the first part is true, control never goes to the other part. Control never goes to the other part. Remember, guys, if the first operand is true, control never goes to the other part. So what will happen? Is 24 is a true value or not? Any other than 0 is true value. Any value other than 0 is a true value. Minus 24 a true value, sir. So will the control will come to the other half? No. Will this minus minus I will be executing? No. So I value will be remain what? 4. What about A value? Sir, it's a true now. True value means now whatever is the other thing I am not interested to know, total result will be true. True means 1. So the value of A will become 1 and the value of I is as it is 4. Chetan, 1, 4. Execute, compile and run. Okay now? Understanding why it is coming as 1, 4? Yeah. So you have to always careful about this logical OR operator. If the first part is true anyhow, control will never go to the other half. Okay, sir. So what it is? 1, 4. 1, 4. Let us take another example. 1 minute. Just OR operator. Okay, let me tell you. Here I am having int x is equal to 4, y4, z4. If x is equal to y is equal to z, printf c, else printf c++. Tell me, what is the answer? Observe. What is this operator? Sir, relational operator. Equal to. Acha, before that, guys, how will you remember the entire table? This precedence and associativity table, how will you remember, sir? Right? What is the shortcut for remembering this table? Just I will ask you to remember this thing. Not entire table, remember this fellow only. And here it's not difficult to remember. Why? Because from your childhood you know that na, that Badmash rule. Am I audible, students? Others, please do confirm once. Am I audible? Am I audible, guys? Yeah, Modulina, from my side, it's okay. Right? You just log out and log in once. I think problem will be resolved. Just log out and log in once. Okay? Yeah. Come back. Now, how do you remember, sir? How do you remember this entire precedence associativity chart? Such a big one, sir, bigger one. How can I remember? Okay, my suggestion is you just remember up to this. And here also it's not difficult to remember because due to that Badmash tool, you know, na, from that you know that first bracket open, first bracket close is having high precedence. Just remember that. Once you remember up to this, along with automatically third bracket open, third bracket close, very easily you'll be able to remember. So till now nothing to remember because everything already you know that. Okay, then I'm telling remember up to this only. Dot operator, arrow operator, and post increment, post decrement. Here a big thing is there, guys. Later it will come. See, post decrement, post increment, it's having high precedence compared to pre increment, pre decrement. Post increment, post decrement is having high precedence compared to pre increment, pre decrement. What I ask you to remember, just these two. Who is having high precedence? Dot, arrow, post increment, post decrement, and the remaining twos are automatically coming now. First bracket open, third bracket, first bracket open, first bracket close, third bracket open, third bracket close. Next, the entire thing to remember, I will ask you remember this thing. You ask black. You ask black. Now actual spelling is what? Actual spelling is what? You ask black. This is the actual spelling now. But forget about correct spelling, because while doing WhatsApp we also write MSG, that is for message. But is it the spelling for message? No, but still we write now. Pronounce, if I ask you pronounce this, what you will pronounce? Message, sir, but not the correct spelling. Similarly here, you ask black, you remember in this fashion. You ask, instead of KC and black, BLAC, BLAC, black, BLAC, black. Don't go for correct spelling here. To remember this, what is this U? Unary operator. What are the unary operators? Already you know that. Already we practiced. Pre-increment, pre-decrement, logical not, bitwise complement, address of operator, unary plus minus, size of, typecasting. That's for unary. U for unary. A for what? Arithmetic operator. In arithmetic operator from your childhood you know that. Sir, multiplication, division, modular division having high precedence compared to plus and minus. Yes. In the table, these two part is coming by that, just by remembering that. Next, you ask S for shift. S for shift. Let's see here. After this, shift. Left shift, right shift. Next, ask C na comparison. These many comparison operator we are having, but you see this fellow are having high precedence. How to remember? Remember greater than, na? Greater than, less than, greater equal to, lesser equal to. They are having high precedence compared to that of equal to and not equal to. Easy. Next, you ask black. Who will come? B. B means bitwise. In bitwise you are having, sir, bitwise and, bitwise or. How to remember? See, and is a 3-letter word, ZOR is a 3-letter word, OR is a 2-letter word. 3 is more than 2, na? That's why these two are having high precedence than that bitwise OR. Don't think it's logically. For your understanding and remembering purpose, I'm telling you this story. Now, between and ZOR, both are having 3-letter, but it starts with A, it starts with X. A comes first, na? Bitwise and first, ZOR second, OR third. Next, black, L. L means logical. How many logical operator? 3. Logical and or not. Not already comes under unary operator, already done. Comes under unary operator, already done. Logical not. What remains? Logical or and logical and. And is a 3-letter word, sir. 3 is more than 2. Then and will have high. Then after that, you see here BL. Then see the gap between. See the gap between L and A. So much gap. Why so much gap? Why? You are asking now, asking. Asking means conditional operator will come. Ternary operator or conditional operator. After that again A. This time means assignment operator. Equal to, plus, equal to, minus, equal to, multiplication, equal to, bitwise and is equal to, left shift equal to, done. C means comma operator. Easy na guys, now to remember this. You ask black. Sir, what is unary minus C? X is equal to minus 5. Minus acting as unary operator. X is equal to A minus B. Minus acting as binary operator. Unary minus, binary minus. You understood? I hope now very easily you will able to remember this chart. You ask black. So I ask you very small thing to remember. This thing. Dot, arrow, post increment, post decrement. Remaining top to bottom, everything is automatically coming. just by remembering you ask black. Now here in this code, sir, both are assignment operator. Then what? Sorry, both are relational operator. Then what you will do? Sir, I have to go for associativity. Regarding associativity, very easy, guys. Remember, conditional operator, assignment operator, and unary operator associativity is right to left. Remaining everyone is left to right. One more time. Conditional operator, assignment operator, and unary operator associativity right to left. Remaining everyone is left to right. Now here, sir, what we are going to do, as per the question is concerned, having equality operator 2 times. So no question of precedence, because with whom I will compare? Both are having same operator. No? Then go for associativity. What is the associativity? Sir, left to right. What is that? Left to right. So now very easily you will able to give the answer. Sir, is Z is equal to Y? Yes. Relational operator, whenever it works, what result it returns? 1. So now it returns what? 1. Now what you are checking? X is equal to 1. X is what? 4. Is 4 is equal to 1? No. That means it is returning what now? 0. If 0, is this line will execute? No. Where the control will come? Else what? What will be executed? C++. Understanding? Everyone understood, sir? Why this not enter in the if block, but why it should enter in the else block? Can I move further, guys? Everyone got clarity? Yes. Let us go for the next one. Very simple one. Printf %d 1 2 plus 3 4. What is the answer? Precedence and associativity will definitely come into the picture. What is the answer, guys? Very simple. First you tell me, no. First you tell me how many operator is there? 2. Left shift plus. Who is having high precedence? First tell me. As per that table, who is having high precedence? Plus is having high precedence. You ask black. You ask black. Ask A for arithmetic. A for arithmetic. Ask S for shift. So plus is having high precedence. Plus is having high precedence compared to shift. You ask black. Remember, you ask black. So what will happen here, sir? Plus will work first. So now, as per the precedence associativity, plus first, left shift later. So 2 plus 3, 5. What will happen? 1 left shift 5, left shift 4. 1 left shift by 5 means you know that. Yes. 1 into 2 to the power 5, 32. 32 left shift by 4 means 32 into 2 to the power 4 means 16. So it becomes 512, sir. Okay, na? Precedence associativity you are getting perfectly. You ask black, you will able to remember. Very easily you will able to give the answer of any question, sir. Next and after that, I'm writing here int j. All the operator discussion is done now. That's I'm mixing up. Int j is equal to size of I plus plus. Printf %d ij. What is the answer, sir? Assuming size of integer is 4 bytes. Rakesh, assuming size of integer is 4 bytes. Yeah. So in some sense, compiler dependency is there, na guys. 12.2 is also not an incorrect answer. If size of integer is 2 byte, then automatically 12.2 is a correct answer. So better this question I should write in this way. Assuming the size of integer is 4 bytes. Predict the output of the following. Yeah. So what will happen, sir? 12 and 4. Execute, compile and perfect. We expected 12 and 4 should come. 12 and 4 is coming. Next. Tell me, what is the answer? Or 4. Okay, I don't know. We have to evaluate and reach to that conclusion. Let's see what others are telling. Okay, let me go for it. A is equal to 2. 2 means 1 0. But what I said, 8 bit. 8 bit. 5 6. 8 bit. 8 bit. 2 done. Next, B is equal to 5. Let me copy this. 5 now, guys. 1 1 5. Next, XOR. XOR means Same gives us 0, alternate gives us 1. 1 0, alternate 1. 1 0, alternate 1. 1 0, alternate 1. Remaining all are zeros. Remaining all are zeros. This is what you are getting after first one, and that value is assigned to A. So what is the value of A? A is equal to 7. A is equal to 7. Done. Next, B is equal to B is or A. B is or A means this part will be now XOR with A. What is the current value of A? 7. Current value of A is 7. 1 minute. What happened here? 8, 8, 8. Yeah, 7. Now this is what I will make a XOR operation. Again, 1 1 same 0 sir. 1 0 1 1 1 0 sir. Remaining after that everything will be 0. What is that? 2. Where it will be assigned? To B. So what is the final value of B? 2. Final value of A? 7. Then what is the answer? 7 2. Understanding? Everyone got the clarity? You know that, just only thing is that maybe in hurry you are making the mistake. Seven two. Next and after that, say I'm taking here int x is equal to 10, y is equal to 20, x plus is equal to y plus is equal to 10. Print a percentile d xy. Tell me, what is the output in this case? Simple. How many plus equal to is there? 2. What is plus equal to? Yes, correct. Plus equal to is such shorthand assignment operator. Where it is? Here. This is where plus equal to is present. They are known as shorthand assignment operator. If more than one is present, sir, go for associativity. Right to left na? Go for associativity. Right to left na? Oh, that means, sir, first this part will work. Y plus equal to 10. Acha, y plus equal to 10 means y is equal to y plus 10. Yes. That means y value is 20. 20 plus 10 means y will become 30. Y will become 30. Next, x plus equal to y. X plus equal to y, sir. What it means? Sir, x plus is equal to y means x is equal to x plus y. X is equal to x plus y. X is 10. Y is 30. 30 plus 10 is 40. So x value is 40. Y value is 30. Okay, na? Next. So all the operators we are practicing, guys. No operator we are leaving it. Whatever we are leaving that are related to that particular concept, there it will be discussed. Like dot operator, arrow operator, you have to wait for the structure concept to come. Next, here int x is equal to 10. Int y is equal to, I am having x plus plus, comma, x plus plus, comma, x plus plus. Next, printf percentile d x comma y. Already we know the comma operator story. Apply it, tell me the answer. Ten 13. Achha, let's see what others are telling. 13 12. Okay. Next 12 12. Okay, let's see. Here x plus plus. Observe here. Initially x is 10. Y value you need to get. This is what we are expecting, y value. Okay, from here x plus plus. Sir, plus plus later. First x will give the original value here 10. Next I will come here na, but before coming here increment the x value. Oh, x become 11. But here in the expression what you got? 10, comma. What is current value of x? 11. Returns here. Returns means giving. Then due to plus plus x will be incremented and will become 12. But given you what? 11. Next, when you come here, again you are asking, oh x, what is your value? X is telling 12. But internally what it will do? Change it to 13. Now what it means? 10, 11, 12. In case of comma, which value is considered, guys? Which value is considered rightmost? Then which value will be considered? 12. That 12 will be given to y. And see the x value, guys. See the x value. 13, sir. 13, 12. Tell me, guys. Understanding? Comma operator also discussed. Last one. Int y is equal to 0. Int x is equal to here. Complement of y is equal to 1. Lastly, I'm printing the x value. That's it. What is the answer? Okay, 1. Your prediction is 1. Now see. Sir, y is equal to 0. Who is having high precedence? Bracket portion will be evaluated first. In the bracket portion, which part will be evaluated? This one. Why? Sir, unary operator, na sir, unary operator high precedence. Complement of y. Complement of y. Complement of y means, sir, 0 means all 0. Bitwise, na guys, bitwise complement. So it will work on bit. It will work on bit. Now what will become? Sir, all 1. Tell me, guys, this number, is it equal to 1? without even testing we can say that, sir, this total number is 100% not is equal to 1. I can give you the guarantee, sir. But still if you want to verify, you know how to verify. Sir, this 1 is basically means for negative. Final answer will be -1. Final answer will be -1. But what about the value? Sir, to get the value, take the remaining number, take it, make it 1's complement, and then go for +1. What it becomes? What it becomes, guys? 1, sir. It becomes 1. But final answer is? Tell me, final answer is -1. Final answer is -1. That -1 you are comparing with 1. Is -1 and 1 are same? Is -1 and 1 are same? No. What is the answer here? 0. X value will be given to what, guys? 0. Super na, boss. Execute, compile and run. Execute, compile and run. Tell me, understanding? Sir, I want to see that complement of y value as -1. Printf complement of y is equal to %d, then complement of y. Execute, compile and run. 1 minute. X is equal to /n. Execute, compile and run. Okay, now suppose anyone is asking you in this code, after this I'm printing the y value, what will be the answer? I'm printing the y value, what is the answer? Respond. What is the answer of y value, sir? Good. 0. Because after complementing y, I have never reassigned that value to y. I never reassigned that value to y. So that's why y value is never changed. Y value is still 0. If I have y is equal to complement of y, then last line value will also become -1. Complete clarity you are getting, guys? Tomorrow also we will go for few more questions, because now this is done. So arbitrarily by taking everything we will practice few more. After that we will enter into the flow control. Let me create the classroom for you guys. Acha, video drives are not share. 1 minute. Let me check it out. 1 minute. If not, I will ask them to share. I think they have not shared with me yet also. Yeah, they have not shared with me. Sri, I will ask them to share. I will ask them. I will talk to them today. Okay? To share that. Acha, Madhurina, why it is not possible to attend? Because they will not share the Zoom link. In this, why it is not possible? Everyone is attending. What is the problem? What is the problem? No. That is your network problem. That is your network issue. If the network issue is there, that same thing will happen with Zoom, or same thing will happen with Zoom or whatever. Zoom or webinar, basically whatever you use, first you must have the net connection. No? Net connection you have to ensure. Acha, two things, guys. First, let me. Okay, whatever explanation got missed, you will get that in the video. In spite of that, if you are not having, then I will let you know. No need to worry for that. So let me create class. I will talk to them to share the videos as early as possible. Yeah. So this is the classroom code. Take this, and make sure you add here yourself. KZPN BTC. Okay, KZPN BTC. So current document, whatever I have, I'm sharing with you. Of course, this will be updated, guys. This note will be every day updated. Currently, up to question number 22, I prepared perfectly with explanation when with answer. 22 or 24. 25 onwards, I need to, what I need to do? Arrange properly. They are not arranged properly. Up to 24, it's okay. I'm sharing this document also, and it will be updated every day. So no need to worry. Today also I will update from 25. Tomorrow again I will share. So every day it will be updated. You will get the updated one. Only one document. Okay. And along with that, I want to share something with you. That is precedence associativity chart. Okay. That is, you may require that. Acha, signed, unsigned also you require. Along with this, just go through once, and tomorrow let me know once if anything I discussed but not shared with you. If it happens, anything is there, I will share it with you tomorrow. So just check it once. Right? Anyone joined yet? Okay, already started joining. Okay, no problem. Yeah, thank you guys.
This conference will now be recorded.
Okay, guys. So, am I audible, students? Yeah. Okay, thank you. So, let us take the next problem statement. So, almost we are very close to completion of the first topic, that is the operator, because so many questions we discussed, almost all operators, with respect to all operators, so many questions we practiced. Let us take the next one. Suppose, for example, here I'm having one variable int y, and here two variables I want to take. One is x and another is y. So let us assume x value is equal to 0 and this is y. What I'm doing here, I'm writing here x is equal to again x is equal to 1. This is the code. Printf %d x. Tell me, guys, what will be the output in this case? Good. See, guys, whenever we are having more than one parenthesis, if you see parenthesis having top level precedence, parentheses are having highest level precedence, top level. Actually, here all the operators are having same precedence, guys. Don't think that I write third bracket open, third bracket close later, first bracket open, first bracket close first. That means first bracket open, first bracket close is having high precedence compared to this. No. Inside a block, all are having same precedence, but associativity left to right. Now you see here, in this case, we are having how many first bracket open, first bracket close? 2. Then what about their associativity left to right? I will start working from here. X is equal to. Now I need something. Here I stop and I need something. To get that something, I need to evaluate this part. To get that something, I need to evaluate this part. Execution started from left to right. Now I need to get something here. For that purpose, I need to evaluate this part. What is that? 0 is equal to 1. Is equal to is what operator? Relational operator. Relational operator gives us what value? True or false. Is 0 is equal to 1? No, false. Then with respect to this part, what we are going to get? What we are going to get with respect to this part? X is equal to, here x is equal to, this part 0 is equal to 1, no, false. So what will be assigned? 0. Next, this will be equal to, again, is x equal to 0? Yes, x is 0. 0 equal to 0? Yes. What will be returned? 1. That 1 will be given to x. That x we are going to print. Execute, compile and run. Perfect. Next, and after that. Next one is from arithmetic operator, right? Now you have to choose which one is the correct statement here. Suppose, for example, I need to divide, I need to make a modulus operation. This is called modulus operation. What it gives? It gives remainder. Say I'm having two numbers. One is 2.1 and another is 1.1. How many number I'm having? Two number. Now these two number is of what type, guys? 2.1 and 1.1 is of what type? Don't say they are float type. Don't say they are float type. Yes, they are double type. By default, every real number is of double type. Inject this here in your brain. By default, every real number is of what type? Double type. Sir, what is called real number? The number which is having some digit after the decimal point is called as real number. The number which is having some digit after the decimal point is called real number. From 9th onwards, guys, from 9th onwards, due to some unavoidable circumstances, from 9th onwards, we are going to have the changes of time, guys. Instead of starting the session from 5 p.m., we will start our session from 8:30. We will start our session from 8:30. It will be continuously going on up to 9:30. 8:30 to 9:30. Every day we will have session hour 8:30 to 9:30. Okay. As I said, due to some unavoidable circumstances, I didn't. No. 8:30 to 9:30 p.m. No chance of having that AM option are not left. Only option is left either 8:30 to 9:30 or 9:30 to 10:30. Either of these you have to choose. As I have given 9:30 to 10:30 for a DS session, so that's why for you people I have given the time from 8:30 to 9:30 p.m. Okay, from 9th onwards. Yeah. So let us assume. So these two are now what number? Real number. These two are real number. Now for real number, in the context of modulo operation, in the context of modulo operation means that is remainder or division. That is remainder or division. Modulo operation means remainder or division for floating point number. Floating point number. Though I'm writing here as floating point number, actually they are not float number, they are double number. Pick the best statement. Pick the best statement. Which statement is the best one? Option number A. 4 options are there. A, B, C, D. Which option is the best option, sir? Option number A. For floating point modulo operation is not defined, and that's why modulo can't be found. For floating point number, modulo operation is not defined. That's why modulo cannot be found. Now this statement is not correct, guys. This statement is not correct. Why? Because yeah, it's true that we will not able to apply that operation while doing the C programming. Suppose for example, here you are writing printf percentile f, printf percentile f. Here you are writing 5.6 modulus 2.3. What will happen? Immediately I will get compilation time error, sir. Immediately I will get compilation time error. Observe, execute. Just I'm going for compile to get the error. Acha, first this is my typo, guys. Execute, compile. See here, invalid operand to binary modulus, and see on top of that double and double. So 5.6 by default is considered what type? Double type. 2.3 by default considered what type? Double type. So if I directly apply this operation on double number or floating point number, they are not applicable. It doesn't mean it cannot be done. It doesn't mean that it cannot be done. Definitely it can be done. But to do that, we have to take the help of a function that is called as fmod. If we are using fmod function, then definitely you can do that. But for fmod function, we need to include math.h header file. We need to include math.h header file. Now it can be done. Execute, compile and run. Now see, no error. Some result will come. As per that operation, some result will come, sir, as a modulo. So it's not correct that it cannot be done. It is correct that it cannot be done with the help of modulus operator. So that is why, as the first option is demanding, what it is demanding? For floating point, modulo operation is not defined. Actually, it is defined, but using modulus operation, it cannot be done. That's why modulo cannot be found. No, it's not the correct option. What about option number B? 2.1 modulus 1.1 is the result of modulo operation. Is the result of modulo operation. That is also not correct, because you cannot write like this, sir. 2.1 mod 1.1 you cannot write. You are going to get the error. Okay. F mod 2.1 comma 1.1 is the result of modulo operation. Is the result of modulo operation. D. What is D? Already we know na typecasting. I'm making typecasting to that int. 2.1 I'm typecasting to int. I'm asking please behave like an integer. Modulus. Again, typecasting of int 1.1 is the result of modulo operation. Now my question is, among the 4 options, which one is correct, guys? Which option is correct one here? These 4 options, which one is correct? Yes, C is correct option. Why? Because this is incorrect, sir. This is incorrect. This cannot be done because we are going to get compilation time error. This already have shown you perfectly it is possible. If you want to get modulus operation between 2 floating point number or 2 double number or whatever, this can be done. Sir, this is also okay. As you are typecasting to int na, sir, this is okay. But there the problem will be, you are not going to get the correct output, sir. Because you are asking it to behave like int, means some digit after decimal it will not consider. And as a result, what will happen? As a result, what will happen? We are not going to get the correct result. So fmod function, how it looks like, guys. If you want to see fmod function prototype, this is how fmod function looks like. See, guys, this is how fmod function looks like. Forget about this part. Just see the function name fmod. It takes argument as 2 double type and it returns argument as double. It returns argument as double. Similar to fmod. Let us search here. Fmod f. Yeah, we can have another function, guys. See, fmod f. Don't concentrate on this. This thing will come in future. Extern, what is extern, etc., etc. This is for floating point division. Fmod f. Earlier one was fmod. That is for dividing to double type. No. So I'm expecting float. Then correct function is fmod f. But fmod will also work. And if you are expecting long double, then f mod l, I think. Yeah, long double. Next one only. The next one only. See, this is for long double. So basically 3 functions. These two here. Forget about extern, not needed for the time being. Fmod function, fmodel function, and another one is fmod function for double and double. If both the argument are double type, then you have to go for fmod. Real type, fmod f. You can even go for real number also, you can go for it because it is higher data type, not an issue. And for long double, this is the function. Fmod f, and fmod l, guys. So here, which option is correct, sir? Option number C is correct. Next and after that, Another very important question. Observe here. Suppose A, B, C and D are invariables. A, B, C and D are invariables for ternary operator. For ternary operator in C. What is the ternary operator? Asking sign followed by colon. Pick the best statement. Pick the best statement. Option number 1. What is that? A greater than B, asking sign, colon, semicolon. A greater than B, asking sign, colon, semicolon is a valid statement. That is second and third operand. Second and third operand means expression can be empty and they are implicitly related with non-zero value at runtime. Can I do that, sir? Can I keep that portion as blank? Suppose, for example, int a is equal to 10, b is equal to 5, c, and here I'm writing c is equal to a greater than b, asking sign, then expression 2 should come now, sir, followed by expression 3. I'm leaving both of them as blank. I'm printing the value here. First of all, syntactically, is it okay? Can I keep that part as blank? Can I keep that part as blank or not? Expression 2, expression 3. Execute, compile and run. See this error. Expected expression before semicolon. That means here it is expecting some expression, sir. So moral of the story is what? Sir, this option is a valid statement. No, invalid statement. It is telling that it's a valid statement and telling that at runtime some value will automatically come. No value will come. So this option number A is perfectly invalid with respect to ternary operator. So for ternary operator, expression 2 and expression 3, can I leave those as blank? No. Next, A greater than B, asking sign, C is equal to 10 or D is equal to 15 is a valid statement. Here, based on the value of A and B, either C or D gets assigned the value of 10. Let me make both of them 10. Tell me, guys, what do you think about the B statement? Is a valid statement. Based on the value of A and B, either C or D gets assigned the value of 10. What is the suggestion, guys? Achha, one student is telling valid, another student is telling not possible. Why not possible? Why it is not possible? What is the reason? Why do you think that it is invalid? Assignment with ternary is possible, definitely possible. Assignment with ternary is definitely possible. But the problem here is, see, where is the problem? Suppose this is my code. A greater than B, and what they say, C is equal to 10 and D is equal to 15. This is the code they said. Or both of them 10. Both of them 10. Here, where is the problem, sir? Observe carefully. Now, in this line, seems everything is okay. Seems everything is okay. People will think that this is expression 1. What is the problem? This is expression 2. Expression 2. And lastly, this is expression 3. Everything seems okay. Syntactically, everything is fine. But bring precedence and associativity into the picture. Rakesh. Precedence and associativity will come here. Of course, associativity will not come, Rakesh. Associativity will not come. Why? Because you are having only one conditional operator. You are having only with one conditional operator. If more than one conditional operator is there, precedence associativity will come. Now here, how many operator is there? Greater than is there, conditional is there, assignment is there. And you see, I wrote them as per their precedence. Greater than, you ask black, you ask black, ask C comparison. Their greater than includes having more precedence compared to asking sign, and asking sign is having more precedence compared to equal to. So I write perfectly. Now if I bracketize this expression as per the precedence, how it will be bracketized? Say, will say, sir, first bracketize this part. Okay, done. Let it be X. Asking sign. Asking sign. C is equal to 10 colon D is equal to 10. Now how many operators are left with? 2. Conditional and assignment. Who is having high precedence? Conditional. So what you will do? You will bracketize the conditional first. For that purpose, what you are trying? Expression 1, expression 2, colon, expression 3. Expression 3. Who told you that expression must have operand and operator both? Operand is also an expression. Operand plus operator is also an expression. Only operator cannot exist. Only operator cannot exist. Now what will happen? Due to the conditional operator having high precedence, he will collect up to this part. Once he gets a colon, after that he will collect up to this part. Then what he will do? He will bracketize that. He will bracketize that. Now what will happen? Nothing, sir. It's simple. It seems like capital Y is equal to 10. What is capital Y? This fellow. Now the code becomes very simple, and it seems like it says very simple. Y is equal to 10, sir. Everything is okay, na? But what is Y? What is Y? Sir, Y is this. Then evaluate that part. Evaluate that part. Sir, here one problem is there. X is there, na, sir? Okay, substitute X with A greater than B. Now evaluate. What is A, sir? 10. 10 greater than 5. Asking sign. C is equal to 10 colon D. Observe. Is 10 greater than 5? Yes. Which part will be evaluated? The C is equal to 10. C will get a value. What value? 10. And C will get a value 10. No doubt about that. And here one value will be returned. What the value will be returned here? 10. What value C is getting? C will return that value. Returning means giving the value. So what value are getting here? 10. Ultimately now, what is happening, sir? This 10 I evaluated, this 10 becomes the value of Y. The 10 becomes the value of Y. And as a result, now the expression becomes 10 is equal to 10. The expression becomes 10 is equal to 10. Tell me, guys, on the left hand side of assignment operator, can we have a constant? On the left hand side of assignment operator, can we have a constant? No, we must have a variable. What error will come? You know that. You are familiar with that error. What error will come? Oh sir, that L value required error will come. Na? That L value required error will come. Correct? Now you see. Let me compile the code. Execute, compile and run. See, that is the problem. Acha, they are telling D undeclared. That is my typo. Let me declare that D. Execute, compile and run. See, read the error. L value required as left operand of assignment. You understand why it is telling? You may think, sir, everything is okay. After doing all this thing, it understanding that, oh, 10 is equal to 10 is a big problem. And then they are telling L value required as left operand of the assignment. Tell me, guys. Interesting. Everyone got clarity, sir? So you have to apply properly. Then only we will be able to make the conclusion. Out of 10%, if you ask this code, they will say everything is okay. Everything is okay. Code should work perfectly. Now we are going to make a small change here. What is the change? Suppose I write here this fellow inside a bracket and this fellow inside a bracket. This fellow inside a bracket. Am I going to get the error? Am I going to get the error? No. Now they will be treated a bit different way. They will be treated a bit different way. Because now if you go for precedence and associativity, who is having high precedence, sir? Definitely first bracket open, first bracket close is having high precedence. Definitely first bracket open, first bracket close is having high precedence. But they are a part of conditional operators, so don't think that you will evaluate directly. Don't think that you will evaluate directly. Even if you evaluate it also, no problem. Because here 10 will come, here 10 will come, no problem. A greater than B, 10 greater than 5, no. 10 greater than 5, yes. Then what value will be coming here? 10. Now you see, I'm going for compilation. Execute, compile and run. Now code will be compiled successful and C value is also showing as 10. So now let us take all those options. So this is the option number 2, guys. This is the option number 2. So till now what we can conclude? Sir, both option A and option B are incorrect. Let me bring option C into the picture. A greater than B. Asking sign. C is equal to 10. D is equal to 20. Colon. C is equal to 20. D is equal to 10. Is a valid statement. Is a valid statement. Here also, based on the value of A and B, either C is equal to 10, D is equal to 20 gets executed, or C is equal to 20, D is equal to 10 gets executed. What do you say, guys? Valid or invalid? Good. Sir, this one is a valid statement. No problem, sir. Once you keep it in the parenthesis now no problem. You see here, I kept it in the parenthesis means no problem. C is equal to 20, D is equal to 10. C is equal to 10, na first, okay. C is equal to 10, D is equal to 20. Similarly, D is equal to 20, C is equal to 10. Print both. Now no problem. Execute, compile and run. Okay, na? Understanding, guys? Yeah, valid statement. And last option. Option number 3. All the above are valid statements for ternary operator. No. Option number C is correct. Everyone got the clarity, students? Whatever I am doing here, rough work, I'm adding here. Later I will arrange it. Okay, guys. So yesterday I have given the document where up to 22 or 23 or 4. Up to that it was arranged. Now today also I arranged a few. I think up to 30 it is arranged. Today also I will share the document. Every day I will arrange few, questions because it takes a bit time. 25, 26 arranged, 27, 28, 29, up to 30. No, up to not 30, up to 29 I arranged. So every day I will arrange the questions properly with answer, options, explanation, and otherwise the rough work and everything I will share with you. That is the rough document. Then updated also you will get every day. Few questions will be updated every day. Updated means with proper documentation. Okay, sir. Next and after that. So ternary operator, this is one very valid point, right? Okay, let us move further. One minute. Here, I'm deleting all this. Observe here. Int shifty. I take a variable name as shifty. Shifty is equal to 0570. Shifty is equal to shifty by 4. Shifty is equal to shifty. This is the right shift, guys. This is left shift. I'm printing the value. Printf. The value of shifty is, observe here, percentile O. O means octal representation. Percentile O means octal representation. Octal. In octal, the valid values are 0 to 7. The octal, the valid values are 0 to 7. How do you know that it's octal number or any number? Octal numbers are preceded with a 0 value. If a number starts with a 0, what it means? It's an octal value. It's an octal value. Now you come here. Shifty is equal to 0570. So it's an octal number, sir. Valid octal number, guys. Yes, valid octal number. Why? Because all the digits are within the range of octal values. All the digits are taken from the octal range. Octal, the allowed numbers are 0 to 7. So all the digits that have been taken here are from the allowed digits 0 to 7. Sir, can I write 0580 octal? See, guys, immediately it is showing the color is got changed. It becomes red. Ask the compiler. Execute compile. See error. In octal 8 is exist, guys? No, sir. In octal 8 is not exist. Up to 7. Now what we are going to do? First we are going to convert this number to decimal number. How to do that? Very simple here. Last digit is what? 0 into 8 to the power 0. Next, plus 7 into 8 to the power 1 plus 5 into 8 to the power 2. Tell me, guys, what is the result of this? This what is getting out because multiplied with 0. 376, no? This is 56 and this is 8 into 2, 16, 16 into 8 into 8 square. 8 square means what, guys? 64. 64 into 5, 320. And 320 plus 56 is 376. That 376. Now first you have to go for right shift. So shift T is equal to shift T. Right shift by 4. That means what, sir? 376 divided by 2 to the power 4. That is 376 divided by 16. What is the result? Integer division, only quotient. What is the result, students? What is the result? 23. 16 into 2, 32. And then 5, 6, 23. We will only take the integer part. 23, not 21, 23. Now, shift T is equal to shift T left shift by 6 means what? 23 into 2 to the power 6. What is the result, guys? 23 into 2 to the power 6. 1472. 1472. This 1472 is in the octal form. This 1472 is in decimal form. Okay, na? We have to bring this into octal form because it will be printed in the form of percentile. What is that? O. It will be printed in the form of percentile O. Okay. How we can do that, sir? Decimal to octal. Tell me, guys, what will be the value? Decimal to octal. If I now convert this from decimal to octal representation, what value we are expecting? What should be the value? From octal representation. Means I need to convert it to, before printing, let us check it one thing, guys. Let us do one thing. Let us verify the result first with D. Yeah, first let us percentile D and percentile O. Both we want to print. So percentile D will be 1472. No doubt about that. And then I need to convert it into octal. Yes. How to convert it into octal? Decimal to octal. What is the process? How do you get that 2700? What process you followed? Divide by 8. Sir, take the number 1472 and start dividing by 8. If I start dividing by 8, what is the quotient? 8, 1, 6, 7. 6 7 means 8 6 7 8 into 8 64, then 32, that means 4. What is the remainder? 0. What is the remainder, guys? 0. Next, what to do? Divide this one again with 8. 8 into 2 16, 24 means 23. What is the remainder? 0. Next, sir, how long we will divide until the quotient becomes 0? How long I will divide until the quotient becomes 0? Now 8 into 2, 16, 2 is the quotient, 7 is the remainder. Next, divide again. What will happen now? Sir, 0 is the quotient, 2 is the remainder. Now I will stop the process. And now you collect the number in this direction. Collect the number in this direction. That will become your final result. That's why the students are started saying that, sir, it will be 2700. Now go for it. Let us execute the code. Compile and run. The value of Shifty is 14722700. Actually, we printed both to check that 1400. That's why it's showing that 1400. Otherwise, that 2700. Everyone understood, guys? Any issue in this example? Yeah. Good example. Okay. Achha, tomorrow we will not have any session, guys. Tomorrow we are going to have the holidays because of Diwali. So tomorrow we are not going to have any session. Okay. Next session will be on Friday. Next, sir. I want to give one homework to you guys. For this, I want to take the answer Friday from you. What is this? It is a bit time consuming one, but you have to do that. This is the homework. Suppose this is the coding I'm having. Unsigned int. Now unsigned int is not an issue for you because you know that. What is that unsigned int means? I'm having a variable num. Here I'm writing int I. Then I want to read that value, scanf. For reading unsigned number, generally we use a format specification with %u for unsigned integer and ampersand num. Then I'm rotating a loop for I is equal to 0, I less than 16, I plus plus. This is my loop. Inside the loop, I'm writing printf %d. And here what I'm doing, I'm writing num less than I. Bitwise and 1 left shift by 15 followed by conditional operator 1:0. 1:0. That's it. End by semicolon. I want to know what it is going to print. After completion of the number, after completion of the loop, of course, you will take a number as input. let us assume I'm giving you that option also. Take 4 as input. Any number you can take, guys. Not necessarily even number, odd number also you can take. You have to work on this example manually, not by writing the, but just writing the code and getting the evaluation done. No. I'm expecting this one that you should do it manual work. Manually, you will work on this example and then you have to reach to the conclusion what it is going to return for us. That I will check. I will take it from you in the next class, guys. Because here all the operators, whatever I used here, all those things are nothing new to you, and every operator is, you people are familiar with all those operators. Okay, let me go for another example. Everyone have taken this one picture? Take the picture of this one. Yeah. See this. Here I'm taking a variable. Int top is equal to 0. It is called a global declaration. The variable I declared globally. Global declaration means what? Inside your C program, how many number of functions are there? No problem. Every function will recognize this variable and they will use it. Every function will recognize the variable and they will use it. Second thing, if any function changes the value, everyone will be affected. Everyone will have the updated information. That is called global variable. Here I am writing a function, int fun. Inside the fun function, I am having a character array. Character array A is equal to, here I am keeping some value. Character array, na? So character will be there. A, B, C, right? First bracket open. That's also a character, guys. D. Writing anything in single quotation indicates it's a character. Writing anything inside double quotation indicates it's a string. Return A of top plus plus. Where to return? To return inside the main function. What is the main function? Here I'm having one character array of size 10. One character variable, char ch. Int I is equal to 0. No problem. I'm writing here one loop while ch is equal to fun function calling not is equal to single quotation. First bracket open. Inside the while loop, what I'm writing, b of I plus plus is equal to ch. Lastly, printf b. Printf %d b. What is going to happen, sir? What is going to be printed? That is what we have to see here. Observe carefully, guys. Execution will start from main function. Execution will always start from main function. This line will execute. As a result, what you will have? Sir, I will have a character array. What about the size? 10. Three, 5, 6, 7, 8, 9, 10. Name of the character array is D. Next, it's a character variable ch. Simply a character variable ch. Oh. Variable I is initialized with 0. Ch is equal to, this is function call, guys. What is this function call? Already we know that function call is having high precedence. From the precedence associativity chart, we know that function call is having high precedence. What will happen? First function will be called. immediately where the control will go? Sir, from here, control will go to the fun function. Inside the fun function, what we are having? One character array is there. This is the character array. This is your character array. Okay. Next, what it is telling? Return a top, not a top plus plus. Return value will become a top. Return value will become a top. What is top? 0. A0. That means what value will come? Sir, first time small a will come. First time here small a will come. And internally top will change from 0 to 1. Small a is coming here. Now what is there? CH is equal to small a not is equal to first bracket close. Which one will work first, guys? Now fun function has done it. How many operator is there? Equal to, not equal to. Who is having high precedence? Not equal to, sir. Equal to, sir, almost last, comma last before that. So which part will work now? This part. This part will be working now. What you got here? Sir, A. Is A is not equal to first bracket open? Yes. A is not equal to first bracket open. What value will be returned? 1. CH is equal to 1. That means what? While 1. True value now, guys? Yes. What will happen? Sir, this 1 will be kept where? In the B array. Which location? Sir, I is equal to 0. In the B0 location, this 1 will be kept. And internally, I will become 1. Internally, I will become 1. But sir, I have a doubt here. What is the doubt? Sir, here it is the CH value which you get. That is 1. That is numeric 1. Can a character hold a numeric 1? Yes, character can hold both the things. Character value and numeric value. If you give numeric value, then the numeric values corresponding ASCII. Then the numeric values corresponding ASCII character will be stored. So once corresponding ASCII will be stored here. So here actually 1 will be stored, or once corresponding ASCII will be stored. 1 will be stored or once corresponding ASCII will be stored. Sir, once corresponding ASCII will be stored. Next and after that, what will happen? Sir, the loop will again rotate. This loop will again rotate. Again function will be called. Again control is coming here. This time return a top. Top is what? 1. Top is what now? A1. Then what will be returned? Character B will be returned. And top will become, character B is coming here. Is character B is not equal to first bracket open? Yes, that's true. Then what value will be returned here? Numerically 1 value will be coming. And where 1 will be assigned? To the character CH variable. Character variable can capture numeric value. Numeric value it can capture. But what it will capture? Is it going to capture numeric 1? Character 1? Sir, not character 1. Then numeric 1? Yes, numeric 1. Numeric 1 indirectly means what? Sir, some character is there whose ASCII value is 1. That character is going to store. Some character it is going to store whose ASCII value is 1. See guys, 1 and 1 are not same. These two are not same. It's a numeric 1. It's a character 1. Currently you are giving numeric 1. CH is equal to 1 you are telling. You are telling CH is equal to 1. So what will be stored? Sir, there are some character whose ASCII value is 1. That character will be stored. There are some characters whose ASCII value is 1. Don't think once corresponding ASCII character will be stored. See guys, we are having 256 characters. We are having 256 characters. For example, small a character ASCII value is what? 97. You know that. Capital A, ASCII value is what? 65. Similarly, character 0, ASCII value is what? 48. Character 1, ASCII value is what? 49. Currently, I'm not talking about character 1. Currently, I'm not talking about character 1. I'm talking about numeric 1. So that means what? Some character is there whose ASCII value is 1. I don't know which character, that can be proved programmatically. There are some characters whose ASCII value is 1. That character will be stored here. So second time also the same thing happens, sir. Loop rotates again. In the meantime, I++ means I becomes 2. Third time, again function called, again control comes here. This time A top means A2, A0, A1, A2. What is that? C. C will be returned. It will become 3. C is coming here. Is C not equal to this? Yes. Again 1. So one's corresponding ASCII character will be stored in the array. I'm writing here 1, but actually not 1. They're stored what? One's corresponding ASCII character. The ASCII character corresponding to the value 1 is stored. Right? The ASCII character with ASCII value 1 is stored. Okay. Next and after that, sir, again the loop rotates. Again the function got called. This time A top means 3. A0, A1, A2, A3. A3, which will be returned first bracket open. This is coming here. First bracket open not is equal to first bracket open. No, sir. First bracket open is equal to first bracket open. So this fellow is giving you what value? 0. CH is equal to 0. Is the loop is going to entertain anymore? No. Loop stopped. So what you are getting basically in this example? In the B array, what you are getting? Sir, let us print the B array. Let us print the B array. How can you print the B array? Because in the B array, it's a character array. Na? How can you print the character array? Simple, sir. Use %s, because character array is what, guys? String, na? String is what? Collection of characters. Character array is what? Collection of characters. Now I want to print that string. Execute, compile and run. What it is telling? Int fun. First bracket open, first bracket close. Execute, compile and run. Guys, this is the character for which ASCII value is 1. This is the character for which ASCII value is 1. Now, if you want to write a code to see all the characters and their ASCII value, can it be done, sir, in a program? Yes, no problem. Just 1 or 2 line program. See here, all character and their ASCII value will be able to see. Observe here. For loop, int I, (256) character we are having. Let me write a printf statement. Printf /n ASCII value of the character %c is %d. ASCII value of the character %c is %d. That's it, sir. Execute, compile and run. All the characters and their ASCII values are there. All the characters and their ASCII value is there. And how you will justify? Acha, your known, check it out, your known. Small a, sir. Everyone knows that small a is what? 97. Go there. See, ASCII value of the character A is 97. Capital A, 65. Character 0, 48, sir. Space, 32. But the problem here is all characters are not printed, guys. Some non-printable characters are there that you will not able to see. For example, non-printable character is there. So that's why my suggestion is always go for online chart to get the ASCII value. Now you see ASCII value of the character, this is 0. You may think, sir, this is also space. No, actually it is null. ASCII value of the character, null character ASCII value is 0. Now you see this one, your favorite, which I got as the output. ASCII value of the character, this is 1. Now you understand why this character was coming, guys. Look, these two smiles are not same. Is these two smiles are same? No. We got which one? This one. Now you understand why these characters are coming. We are keeping 1 there, but actually 1 is not stored, sir. One's equivalent ASCII character gets stored, or we can say those characters are stored whose ASCII value is 1. This is the character whose ASCII value is 1. That's why it is stored 3 times. Everyone understood this example, guys? You enjoyed this example? 100% clarity you got? Any doubt is there? Along with that, you learned how to print all the characters, sir, with their ASCII values. Okay, that's it, guys. Let me share today's class note with you. Yeah. So I requested them to share the recorded session. Chetan, I asked them today. I contacted them 2 times. I made the phone call and I asked them to share the video lectures. They said that they will do that. So you people can also make a phone call and request them, because it is not in my control. It's not in my hand. I requested them. They said that they will do that. Maybe they are busy with some other activity. I requested them 2 times. I made the phone call and I asked them. They said that they will do that. You people also can make one-time call and ask them to do the same. They will do that. No need to worry. Right? They will definitely do that. Data structure videos they shared, but somehow maybe they are busy with some activity and unable to share that C videos. So that will do that. They will definitely do that, but you can make a request to them to do that as early as possible. Okay, so our next class is when, guys? Friday, day after tomorrow. And from 9th, we will have the session from 8:30 p.m. guys. Thank you, students.
This conference will now be recorded.
Okay, guys, am I audible, students? Am I audible, guys? Respond in the chat box, students. Am I audible? Am I audible today? Yeah. Okay. So let us start today's session. Almost we completed learning all the operators. Now we will learn about the control flow of the what is called conditional statement. In a conditional statement like if else or in switch case, how the control flows, and even in the iterative statements like all kind of loops, for loops, while loops, do while loops, how the control flows there. Because till now most of the examples are very simple example, though we have used those ifs, those fors, but our target was to learn those operators and just these sequential statements. Now we will enter technically to those conditional statements, which includes if else block, which includes repetitive statements, which includes switch case, and how the control flows there. Let us take the first example today. Say for example here, I'm writing here int I. Just I declared a variable, and then if I is equal to 0, comma 2, comma 3, then printf. Here I'm writing C, and here else printf double quotation C++. Now what will be the output in this case? And even after this if else block, I also try to print the value of I, print a %ld I. Now observe here carefully. In this line number 5, what is this? This is conditional statement. Earlier we have learned about conditional operator, asking sign followed by colon. That is called conditional operator, and this is called conditional statement. So now inside the conditional statement, here we are having the first bracket open, first bracket close. That is the part of if syntax, and after that we are having comma. Here comma is visible. Now already we have learned that comma can play the role of operator, comma can play the role of separator. So where comma play the role of operator and where comma play the role of separator, already we have learned that. In a declarative statement, comma plays the role of separator, and in function argument, comma play the role of separator. So first of all, is it a declarative statement? Are you declaring anything here? No. Is it the playing the role of function argument? Is if is a function? No, if is not a function. So these are not function argument. So these are not function argument. So here what comma does? Here comma plays the role of here comma play the role of operator. Here comma play the role of operator. Now what is happening here? I is equal to 0. What does it mean? The 0 value will be assigned to I. The 0 value will be assigned to I. Then next 2, then next 3. We know that comma play the role of operator here. Operator means what? Left to right it will execute, and rightmost value will be considered for here to consider. Rightmost value will consider for here to consider. So for this entire part, what value will be considered? That is the rightmost value. What is the rightmost value here? 3. So basically it becomes, basically this statement actually becomes if 3. Basically this statement actually becomes if 3, and we know that after if we are having any non-zero value, after if we are having any non-zero value, the corresponding if block executes. The corresponding if block executes. So here what will happen? As we are getting a non-zero value, after the if block, so automatically the corresponding if block will be execute. 1 minute, guys. Yeah, corresponding if block will execute. As a result, which line will execute? This printf statement will execute. This printf statement will execute. So as the output, what we will get? This C we will get. On top of that, in this line, 0 is assigned to I. In this line, 0 is assigned to I. So when, look, don't think that 3 will be assigned to I. No. 3 is the entire expression's value. In comma operators works from left to right, and rightmost value become the final value of the entire expression. So the entire expression value is 3, but the I value is what? The I value is written as 0. The I value is considered as 0. Now, what will happen? Once I reach to this line, if I print that I value, what will be printed? 0. And before that, due to the 3 consideration here, if block will execute and it will print C also. So ultimately, what will happen? We will get the output as C0. Let us execute the code. Execute, compile and run. C0. This is what we executed. This is what we thought. That is what we are getting, sir. C0. Let us move to the next one. Now, suppose for example, I'm making a little bit change here in this code. What I'm doing here, I'm writing I is equal to this part I'm keeping inside bracket. This part I'm keeping inside bracket, and here we change the value 210. 210. Now you see here, first of all, how many first bracket open, first bracket close is there? 2. Which one will execute first? Innermost. The innermost. Associative it is left to right. So we start from here. I is equal to. Now what is that I? For that we need to evaluate this part. What is the I value? To know that we need to evaluate this part. So after evaluation of this part, we need to get the I value. So what is the value of this part? Here comma is playing what? Separator or operator? Is it a declarative statement? No. Is it a function argument? No. So automatically comma is not a separator here. Comma is a operator here. Once comma is the operator, which value will be considered? Rightmost value. What is that rightmost value? 0. So that value will be given to I. So I value will become what? 0. I value will become 0. Once I value will become 0, is the if block will execute? No, because it will become if 0. Now it will become if 0. So automatically if block will not execute. Which block will execute? Else block will execute. Then what we will get as output? C++, and finally the I value. That means what will be printed? C++ 0. Execute, compile and run. C++ 0. So as per we expect, the output also came in that way. Let us move to the next one. C++ 0. Next. Let us move to the next one. Suppose for example, already we have learned typecasting, guys. Implicit typecasting, explicit typecasting we have learned. Suppose for example here I am having an expression like this. -1 L. L stands for what? Long. L stands for what? Long. Capital L or small l. And 1 UL. 1 UL. What is the difference between L and UL? Sir, L means long. L means long. UL means unsigned long. What is the difference between this? One is long, unsigned. This is unsigned long. And what is this? This is the signed long. This is signed long. Now already we have learned what about the signed and unsigned representation. What is the signed and unsigned representation? With respect to integer we have learned. Only thing is that where it will differ. Only thing that where it will differ is that 1 minute, let me show you. Where it will be differing is not here, signed, unsigned. 1 minute, guys. Unsigned, 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 signed, unsigned here. So we have seen signed, unsigned representation with respect to integer. So with respect to long, what will happen? The range value will become more. The range value will become more. No other differences, right? Now you see here, even if we are talking, forget about long, even if we are talking in terms of integer, then unsigned int this value is equivalent to signed minus 1. So signed minus 1 is basically equivalent to unsigned of this. Unsigned of this. Now you see here in this example, and on top of that, when we learn that typecasting, there we have the entire flow. How the typecasting automatically, what about the automatic typecasting, which type to which type automatically, it get converted. Now you see that in the typecasting, int is automatically converted to unsigned int. Similarly, long is automatically converted to unsigned long. Long will automatically converted to unsigned long. Now here long means what? Here what does this long means? Here long means it's a signed long. Here long means signed long. Nothing is mentioned means it is a signed long. If nothing is mentioned, it is none other than is a signed long. Now signed long will automatically convert it to unsigned long. Signed long will automatically convert it to unsigned long. Now you see here, this is basically signed long. This is basically signed long, and this is what? Unsigned long. Now what will happen? This signed long and unsigned long we are comparing. So as a result, the signed long will be converted to unsigned long. Now you see that signed integer minus 1, if it is converted to unsigned integer, this is the value. Similarly, signed long minus 1, if it is converted to unsigned, then automatically I will get a value which will be a positive value, and which will be a very big value. Some positive value I will get, and which will automatically a very big value. So automatically, if it is converted to a big value, as a result, what will happen? This condition will become true, because this will get a big value, and that big value is greater than this one. Big value is greater than this, low value 1. This is low value 1, and this will be converted to is a big value. Is it greater than 1? Yes, it is greater than 1. As a result of that, what will be printed? Only C will be printed. As a result of that, what will be printed? Only C will be printed. Execute, compile and run. Execute, compile and run. Even if it is not long, just normally I'm writing. This is unsigned 1, unsigned int, you am writing, and this is normal, signed integer. Let's see in that case, is it really considering this one as unsigned 1 or not? Execute, compile and run. Execute, compile and run. You see, in this case also, it is considering C. Normally what happens, if you are thinking minus 1 greater than 1, if you remove this one, if you remove this U, now anymore is it going to true? Let's see, minus 1 greater than 1? No, minus 1 is not greater than 1. So it becomes false, and control is coming to the else part. Now once you are writing here U, that means what you are telling? I'm talking about unsigned integer 1. Which one? This one. Which one you are talking about? Unsigned integer 1, right? And with this, what you are comparing? You are comparing signed integer minus 1. Signed integer minus 1 means which one? This one. So these two fellow are compared. These two fellow are compared. Minus 1 in signed and 1 in unsigned. As a result of automatic type conversion, unsigned signed int is automatically converted to unsigned int. Signed int will automatically convert it to unsigned int. So automatically, if this minus 1 is converted to unsigned int, what will be the value? This will be the value. This will be the value. And is this value is greater than 1? Is this value is greater than 1? Yes, this value is greater than 1. Then automatically what will come into the picture? C will come into the picture. Execute C. So that means we can have two different cases with respect to integer. With respect to integer, we can have two different cases. What is the first case? -1 greater than 1. It's false. It is simply a false. But if you say -1 greater than 1 unsigned, in that case the result will be true, guys. In that case the result will be true. Why? Because, sir, this is signed integer I. Signed integer I automatically converted to unsigned integer I. Already we completed learning this one in typecasting. So that is why this fellow will give me a true value. So this is what we have to remember. Not. I hope everyone got the clarity, guys. Why these things are getting as true value and why this if block is executing. Yeah. So what is the answer here? See. Let us move to the next one. Next, yet another conditional flow of execution I want to show. Here the conditional statement I'm going to here is as switch. Now you see here, suppose for example, taking a variable num which is initialized with 2, switch num plus 2, switch num plus 2. Here I'm writing case 1. Here I'm writing case 1. Inside that printf, I'm writing case 1. Some message I need to write, I'm writing. Then I'm having case 2. Next I'm having case 3. Next we are having default. Printf default. This is my case 2. This is my case 3. Tell me, students, in this case, if I execute this code, here of course we are having case 2 and here we are having case 3. In this case, if I execute this code, what will be the output, guys? Very simple one. What is the output in this case? Yes, default. Because here num plus 2. Num plus 2 means what? Num value is 2. 2 plus 2 is not 4. Is it matching with this case? No. 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 If none of the cases match, then only default will be executed. Inside switch case default. When default get executed, guys? If none of the cases match, then only default get executed. So automatically in this case the output will be default only. Execute, compile and run. Default is the answer. Let us move to the next one. Next one. Say for example, here I'm having a variable int movie is equal to 1, and here I'm writing switch movie left shift by, here it is 2 plus movie, and here it is my default is at the beginning. Default is at the beginning. Here case 4, case 5, case 8. This is the code. And here, say for example, I'm having some message here. Traffic. This is something like Sultan. Here this is something like say Dangal. And here it is something like say Bahubali. and I'm giving some space here. Tell me guys, in this case, what will be the output? That is first question. And second question is, can I have default at the beginning or not? The answer is that inside a switch case, we can have default anywhere. We can have default anywhere. Anywhere you can place default. But remember, placing default anywhere means normally where we place at the end. Anywhere means at the beginning can be placed and the middle can be placed. But it doesn't mean that keeping a default at the beginning means it will be executed, or keeping at the middle means it will be executed. Default wherever you want you can keep. That is not a syntactical issue, but it will be executed only if none of the cases match. Only if none of the cases match, then only it will be executed, right? So here, what is the movie value? 1. 2 plus 1, what is this? 3. And movie is what? 1. So basically it becomes what? 1 left shift by 3. 1 left shift by 3, what is the answer guys? Already we know that. 1 left shift by 3, what is the answer? 8. Then automatically, which printf will be printed? Only this one will be printed. Let us execute, compile and run. Perfectly, it is executing. So what we have learned from here, that inside a switch case body, we can keep default anywhere. That's not a syntactical factor, but default will be executed only in the case when no matching case is found. Default will be executed only in the case when no matching case is found. Next, suppose for example here I'm declaring a variable auto A is equal to 10, and here this is my switch A comma A into 2, A comma A into 2. Then I'm having here one case is there, case L, here one case is there, L into 2, and here one case is there, L into 3. And lastly, we are having default. Here say printf, something I'm printing, say MNO. And lastly, this is the proof to show you that default can be even placed in the middle. That's not a syntactical factor. And here it is printf www. Okay, na? Lastly, we are having one break. Here I'm changing this to ABC. Break. Next, XYZ. Break. Next, PQR. And then break. Remaining things are okay. Question will be raised, what is that L, sir? L means, I'm writing here, has defined L 10. Later I will explore this thing in details, guys. When the preprocessor directive will come, there I will let you know what is called the preprocessor directive, how the things are working internally. That I will discuss there. But currently only thing is that all the occurrence of L before compilation start will replace by 10. Currently up to this much knowledge is enough. Later I will explore preprocessor in details. Currently how far knowledge is enough, sir? Just before compilation, before my program starts getting compiled, all the occurrence of L will be replaced by the value 10. Now you see here, that means it will become what? 10. This will become 10 into 20, 10 into 2, 20, 30, and this will become 40. Now you come here. What is this? Comma. Comma is visible here. Now whenever comma is visible, we can have two things, operator or separator. Is it separator, sir? You ask yourself. Is it a declarative statement? No. Is it a function argument? Is switch is a function? No. Switch is a conditional statement. Switch is not a function. So is these things are here? Is the comma is playing the role of operator or separator? Definitely operator. What is the rule of operator? Sir, left to right it will go. Correct, Chetan. 10 comma 10 into 2, 20. So what is this value? 20. Case L, that means 10, mismatch. Case L into 2, 20, matching X, Y, Z, and getting the break. And getting the break. Break means, remember, break statement can be associated with, very important word I'm using, break statement can be associated with either with switch case or with loop. Either with switch case or with loop. So here, break means it is associated with the switch. It is associated with the switch. So once the break statement will execute, what will happen is that immediately control will be getting out of the loop, out of the switch. Control will be getting out of the switch. So automatically, once this break statement will execute, control will be sent outside of the switch, means here. And then what is the line it will execute? Return 0. Return 0 means you know that it is sending the return 0 value to the operating system, and hence program will be terminated. So as a result, what we are going to get? We are going to get the output as XYZ. Execute, compile and run. 1 minute. So here once printing mistake guys, hold on. Execute, compile and run. We thought that XYZ will come into the picture, and XYZ itself came into the picture.
Sir, default is not a required break statement.
Default, generally, if you are keeping the default at the end, then default doesn't require the break statement. But if you keep default at the beginning, at the top, or somewhere in the middle, then normally default statement needs the break. Suppose, for example, here you are keeping default. Forget about this code. Suppose forget about this code. You are keeping default here. This is switch. Inside it, I'm having some cases. One, we are having case 2. That's it. And I'm keeping the default here. Suppose here you are writing something as printf default. Printf default. And now you are not using any break statement. But here you are using break statement. Printf case 1 break. And here also you are having printf case 2, and then break. Now you are not keeping break after the default. What will happen? Suppose here you are having some value like 3. I'm directly hard code the value. You can write coding, you can take I variable, you can take the value, anything you can do. So I'm taking here 3. What will happen? First, when the default executed, if none of the cases match, case 1 matching, no. Case 2 matching, no. Let us assume nowhere break is there. For the timing, nowhere break is there, and none of the cases match. Then what will happen? Default will execute, and then it will fall through. This is called fall through, right? After execution of default, it will execute all the simultaneous cases until it encounters a break. So now nowhere break is there. So what will happen? Default case 1, case 2, everything will come into the picture. Execute the code, compile and run. Default case 1, case 2. Default case 1, case 2. Everything came into the picture. Now you said that, sir, I will give a break here. If you give a break here, how far it will execute? Until it gets the break. So default and case 1. Up to this it will be executed. So that means this time the output we are going to get the default and case 1. Execute, compile and run. Default and case 1. Default and case 1. Same thing may happen if you are keeping default anywhere in the middle. Suppose we are keeping default in the middle, then what will happen? If none of the cases match, then only default will execute. First this default will execute, then what will happen? Sir, it will fall through. How long it will fall through? Until it encounters a break. So what will happen in this case? First default will execute. After execution of default, as it falls through and not encounters any break, so that means default and case 2 will come into the picture. Let's see what we are getting. Execute, compile and run. Default and case 2, it is going to get default and case 2. So moral of the story is what? Normally if I keep the default at the end, in that case generally break statement is not needed, because after that even it will fall through what to execute, sir. Nothing to execute, so no need to give the break. Now only default will come into picture. But if you are keeping it anywhere else, in those cases it is recommended to use the break. But currently we are not doing any C programming here. We are just testing different test cases. So that is why we are not keeping the break statement here, because it's not a C programming we are writing, just some find the output type of coding we are doing. So that's why we have not used the break statement. But normally recommended is to use the break statement with the default if it is not placed as the last statement, last one. And another important word I want to use here, that is what about that auto. Auto actually in C programming language, later we will explore. We are having 4 different storage class, guys. What are the 4 different storage class? Auto, register, static and external. 4 different storage class we are having. So normally auto storage class means what? If we write int x, that automatically means it is automatic storage class. So writing auto int x and writing int x, basically both same. 3 things are basically same: int x or auto int x or auto x. All these are basically same. All these are basically same terminology. Int x, auto x, auto x. All those cases it is considered as the automatic storage type. Later we will explore what is called storage class. Storage class tells us about what is the default value of a variable, where the variable will be stored, what is the life of a variable, what is the scope of the variable, etc., etc. We will explore that thing. So the doubt regarding default gone, Chetan? The doubt got clarified with respect to this default state. Yeah, better Chetan, better to respond in the chat box, because these videos will be shared with you. So if your voice is there, later you will not be happy with this. So better to respond in the chat box. Okay. Yeah. Let us take the next one, sir. So this one, what is the answer, guys? XYZ. Acha, I have already prepared up to 40. This is 54 today, except today's question up to 48. I think I prepared the document for you up to 47. Okay. Today I will share. Last week I think up to 22 it was prepared. Up to 47 today I have prepared. Then again tomorrow I will add few more. Right. Next. Suppose here switch to, this is case 1L, right? This is 2L. Suffix L means it is talking about long value. It is talking about long value. No problem, sir. Integer 4, long 4, basically all are the same. Here I'm writing something like C, and here I'm not using any break. Here I'm writing %s, comma. Here I'm writing inside a double quotation Java. This one, instead of writing any break, using go to statement. Go to. Normally we should not use go to. Currently they never recommended to use go to, but just as a part of this example I'm using it. Go to. Go to where? After go to you have to provide a label. After here you have to provide a label. Suppose I'm giving some label name as love. Go to love. Okay. Now you can have any valid level name. You can have any valid level name. Suppose here printf. I'm writing here Python. This is also not having any break. Case 4 here. Under this, I'm having that level name. I'm having that level name. And here I'm having C++. This is the code. And of course, it is not ends with a breaks. In this case, initially, my switch value is 2. Remember that. My switch value is 2. Now, first of all, first case 1. 1 is what? 1 in long. So 2 and 1 are same? No, 2 and 1 are not same. Next, case 2. Is case 2 is case 2 and switch 2 matching case? Yes, matching case. Then what will be printed? Java will be printed. After printing Java, as the matching case is found, after printing Java, what it is telling? Go to this particular block. Go to this particular level. Sorry, not block. Go to this particular level. Go to this particular level. Now I have to search where is this particular level. This is where is the particular level. This is where is the particular level. So that means from here, control will be directly coming here. Remember, in a programming, usage of goto is never recommended. Now, this is where the control is coming. After coming the control, this particular label block statement will execute, which is none other than C++. Which is none other than C++. So what we are going to get? We are going to get the output Java followed by C++. Let's see what it is showing us. Execute, compile and run. Java, C++. Just as a part of one example, yes, showing this one, because normally it is never recommended to use the goto in C programming language. Yeah. Let us take the next one, sir. Now we want to go to the repetitive statements. Say for example here, int I is equal to 0, comma j is equal to 0. Two variables are there. While loop guys, while I less than 5, j less than 10. In between that I have a comma. Now here I'm writing I++ and j++. Outside of this printf %d I comma j. Okay na? Very simple, sir. What will be the output? First, your favorite comma is there. You decide whether what role comma will play. Sir, is it a declarative statement? No. Is it a function argument? No. So comma will play the role of operator. Every time it will encounter line number 4. Every time control come to line number 4, comma will show his talent as a operator. Now observe here. First time 0 less than 5. Okay. Comma 0 less than 10. Okay. So 0 less than 5 returning what? 1. 0 less than 10 also returning what? 1. So basically it becomes what? 1 comma 1. Which one you will take? Sir, the last one. That means from here whatever value is coming, that will be taken. What is that? 1. While 1. Will you enter in the loop? Yes, I will enter in the loop. After entering in the loop, what you will do? I++. I value will become 1. J++. J value will become 1. Sir, this is nature. It's not like I am telling. As the nature of the loop, control will be coming back here again. What will happen? Sir, again I less than 5. What is I value now? Sir, I value is 1. 1 less than 5, yes. What it will return? 1. j less than 5, 1 less than 10, yes. What is returning 1, 1, 1. Which one you will check? Last one. Will you enter? Yes. I value will become 2, j value will become 2. Next time, 2 less than 5, 1, 2 less than 10, 1. Will you enter? Yes. It will become 3, it will 3 less than 5, 1, 3 less than 10, 1. Will you enter? Yes. 4, 4. Next time, 4 less than 5. What is this? 1. 4 less than 10. What is this? 1. Which one you will take? This one. Will you enter? Yes. 5, 5. Now both the I and j value is 5. Now what will happen, sir? Control comes here. 5 less than 5. What is this? 0. 5 less than 10. What is this? 1. First time you are getting something like that. Before that, every time you got like this 1, 1, 1, 1, 1, 1. Now you are getting like this 0, 1. But what one? Which one you will consider? 0 you will consider or 1 you will consider? 1 I will consider. So will you enter in the loop? Yes, I will enter. So what will happen? Sir, 6, 6. Like this next time 7, 7. 8, 8, 8. Next 9, 9. Now see. 9 less than 5, 0. 9 less than 10, yes. Will you enter? Yes, I will enter. I plus plus, 10. J plus plus, 10. Next time again. 10 less than 5, 0. No. 10 less than 10, 0. No. Will you enter? No. For the first time loop condition violated. Will you enter? No. Outside of the loop, I and j value will be printed. What is that? 10 and 10. Execute, compile and run. Everyone understanding, guys? Everyone got the clarity? How the control flows here? Any doubt, students? Ten. Can I move further, guys? Any doubt? Yes. Now I'm making a small change here. I'm just removing comma from here, guys. I'm replacing it with a bitwise AND. All these things are known to you now. I'm just replacing it with a bitwise AND. Sir, what will be the output in this case? Tell me, guys. What will be the output, sir, in this case? See, first time 0 less than 5. Will you enter? Yes. This is 0. Currently what you are getting? 0. Followed by bitwise AND. 0 less, 0 less than 5, no, 1, sir. 1. And bitwise AND. 0 less than 10 and 1. 1 and 1. What is that, guys? 1. Will you enter? Yes. I plus plus 1. J plus plus 1. Control automatically come back. 1 less than 5, guys. 1. Bitwise AND 1 less than 10. 1. 1 and 1. 1, sir. Will you enter? Yes. 2, 2. Next time loop come. 2 less than 5. 1. 2 less than 10. 1. 1 and 1. 1, sir. Will you enter? Yes. Next time. 3 less than 5. Yes. What it will return? 1. And 3 less than 10. 1. 1 and 1. 1, sir. Will you enter? Yes. 4, 4. Next time. 4 less than 5. Yes. 4 less than 10. Yes. In between 1. In between and. Bitwise AND. 1 and 1 and 1. 1. Will you enter? Yes. 5, 5. Next 5 less than 5. What you are getting? 0. And will you go other half? Yes, sir. I will go other half because it's not logical AND, sir. It's not logical AND. So I will go other half. Bitwise AND, sir, I have to go to the other half because bit by bit it will compare. So I have to go to the other half. So 0 and 1. What is that? 0. While 0. Will you enter? No. Outside of this. What answer we are going to get? What answer we are going to get? 5 and 5, sir. Execute. Compile and run. Understanding? Getting clarity? Operators, sir, are they? Without operator, we cannot move a single step. Everywhere operator will come into the picture. In every example, operator in some sense will come into the picture. So even we said that okay, operator story has done, but actual thing is that in every example operator will be there, sir. Okay, let us take the next one, sir. For see this, guys. In this case, what will be the output? Or if I ask you learning C is fun, how many times will be printed? Observe here. Observe the control flow. Yeah, observe the control flow. So this is the outer for loop, sir. This is outer for loop. So that means this outer for loop, whenever it encounters, it takes the control back to here. It takes the control back to here. So how many loops we are having? We are currently working on 2 loops. This is inner for loop. This is taking the control here. This is inner for loop. Execution started, sir. I is equal to 0, 0 less than 5. Will you enter? Yes, I will enter. You entered. Next, you get a for loop. J is equal to 0, j less than 1. Is it true? Yes. Will you enter? Yes. What you will execute? Break. This break is associated with which for? Outer for or inner for? The break is associated with outer for or inner for? Inner for. Inner for. So that is why whenever this break will execute, your control will come outside of inner for loop. Outside of inner for loop. What will be printed? Learning C will be printed one time. After that, you encounter this curly brace. Means what? Sir, control is coming back to the outer for loop. I plus plus. I value will become 1. 1 less than 5? Yes. Will you enter? Yes. Again, same story. J is equal to 0, 0 less than 1. Yes, true. Break. This will be printed 2 times. Again, coming back here. I will become 2. 2 less than 5. Yes. Same thing will happen here. This line will be printed 3 times. Now loop come here. I become 3. 3 less than 5. Yes. Same thing will happen. Printf 4th time. I becomes 4. 4 less than 5. Yes. Same thing will happen. It will be printed for 5 times. Next, I become 5. 5 less than 5. False. Control will be sent outside of the loop. Return 0. Everything finished. How many times it will be printed? Sir, it will be printed for 5 times. Execute, compile and run. Learning C is fun. Learning C is fun. Learning C is fun. How many times? 3 times. Okay. Learning C is fun. 4th time. Learning C is fun. 5th time. Okay, na? 5th time, sir. Everyone got clarity? Understanding the control flow of the nested loop stories? Everyone understood the control flow, sir? Yeah. Next and after that. Suppose here I'm taking short I. Short I is same as short int I, guys. Short I is same as short int I. Short int I means it is 2 byte integer, sir. 2 byte integer, 16 bit. Here I have I is equal to 1, I greater than 0, and I plus plus. Inside this, I'm printing the I value. This is my code. Now, what is my doubt here is, whenever I will execute this code, option number 1, control will not fall into the for loop. That means it will not enter into the for loop. What is your suggestion? You have to tell. Lastly, second point, numbers will be displayed. That means it will enter in the for loop and numbers will be displayed. Numbers will be displayed until the signed limit of short, and throw runtime error. Option number 3 is, copy this. Numbers will be displayed until the signed limit of short and program will successfully terminate. Program will successfully terminate. D. This program will get into an infinite loop and keep printing numbers with no errors. Remember, guys, short int I means its range is minus 32768 to plus 32767. 32767. This is the range. Of course, signed, because no question of unsigned. No question of unsigned. Then what will happen? Let me show you this diagram for better clarity. This is for what, sir? This is for 4 byte. No. We are expecting for 2 byte. Where is 2 byte? Here. This diagram will help you to understand. You see here, guys, 2 byte signed. That means which picture we should concentrate? The left one. Just the left one we should concentrate, sir. Now, in the left one, 1 minute, guys. Yeah. Now you see, one by one, option number 1. Control will not fall into the for loop. Sir, I can see I is equal to 1, I greater than 0. 100 to 100% it will fall. So this option have no chance. This option number A have no chance. Option number B, sir, number will be displayed until the signed limit of short. What is the signed limit of short? What is the signed limit of short? Observe here. Observe carefully. This is your code. As per the code is concerned, yeah, that is the signed limit. As per the actually not like that, Chetan. The signed limit is from here to here. You can think like that. In that case, not 1 to minus 1. right? Then 0 will be excluded now. If you're saying 1 to -1, 0 will be excluded. So that is why signed limit is this to this, -32768 to 32767. So numbers will be displayed. First time is what? 1. Next time 2. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to 32767 it is displayed, sir. When it becomes 32768, 32768 actually is equivalent to what? The positive side 32767, no problem. But when it positive side value become 32768, what is its equivalent to? -32768. It is equivalent to -32768. Now is -32768 is greater than 0? No. No. Loop will be terminated. Nothing will be printed anymore. So how far printed? 1 to 32767. It says that number will be printed until the sign limit of a short. That's perfect. Up to this is perfect. And throw a runtime error. No question of runtime error, sir. Why runtime error? Everything should work perfectly. Number C. Number will be displayed until the sign limit of a short. That's same as previous. Okay. And program will successfully terminate. Definitely. Definitely it will terminate successfully. This program will get into infinite loop. No way. No way, sir. But the problem is, sir, can you show this? How can I show you guys? I don't have 2-byte compiler, but I have one 2-byte compiler. Let's see, guys. Can I show this code or not? Okay. Just let me open that 2-byte compiler 1 minute. Where it is, guys? Yeah. It's a bit olden days compiler. Will take a bit time to run, but I will try to show you this happening or not. So what I need to declare? I need to declare a variable of short type. So what is our prediction, sir? 1, 2, 3 to 7, 6, 7. Up to that it will be printed. After that it will be terminated. Compile. Run. Wait. Observe the last value, guys. Done. 32767. Observe the last value. Let me press the enter button to come back. Yes. Everyone understood why the option number 3 is correct, guys? And it's not possible to show you in that DevC compiler. Why? Because there the size of the integer is automatically considered as 2-byte. Then how can I show you that? Sir, why we use conio in that? Because we use one function getch. You observe there, Chetan. At the end, we use a function called getch. Now for getch function, the corresponding header file is conio.h. Okay. Yeah. That's it, guys. So when is our next session? Our next session is on Monday, right? Monday is our next session, but there is a doubt of our Monday class, right? Actually, Monday, my son is having a vaccination. So if I can reach by the time, I will take the session, right? So you just join once, check it out whether I'm coming or not. Wait for 15 minutes, up to 5:15 you wait. If I'm not coming up to 5:15, you will leave the session. Acha. Along with that, remember from Tuesday onwards, our session time will be on from 8:30 p.m. Right? Same link, everything is same. Timing will be from 8:30 p.m. Okay, Monday I will try my level best. If possible, I will take. If not possible, no need to worry. On that week, Saturday or somehow in any weekdays, any holidays, I will take that additional session. Yeah, thank you guys. Acha, let me share the document up to today, whatever we done. Acha, videos are shared now, guys. I think video today they have shared with you. Yeah. Now next few days, this thing will be, loop, then if statement, else statement, switch. This thing will be happening continuously, parallelly. As per our syllabus, this is currently the second module through which we are going through, where it is here. So now everyday loop, switch, if else, continuously we will practice, right? Nothing like this after this one like this. All operators almost 98% done. 2 operators are pending. I said the dot operator, arrow operator. It will be discussed at the time of structure and pointer respectively. Other that now control structure. Under the control structure, everything, right? If else, switch, for while, do while loop, jump in loop. Already have seen today. Go to statement, then break. Already we have seen. Continue will also come into the picture. Nested loop. These things we will continuously do that for next 1 week, right? And then we will start the next level concept, that is arrays and pointer, guys. Yeah. So next week mostly, if we have 5 sessions, at least 3 sessions mostly we will try to spend on control structure. After that we will enter into the array concept, guys. 1D array, 2D array, 3D array. Yeah. Thank you, students. Bye, class.
This conference will now be recorded.
Okay, screen is visible, guys. Respond once in the chat box, students. Is my screen is visible and am I audible or not? Yeah, good. Okay, so let us start today's session. So in the last week we discussed few questions regarding to switch case as well as loops, different type of loops, for loops, while loops, do while loops, and then if statement, switch case. Now as I said, this week entirely we will spend time on if else, switch case and loop structure. Let us take the next problem statement, guys. You have to tell the output of this code. Here I'm taking here int x is equal to 2. Inside this I'm having switch x, guys. Switch x. Inside that I'm writing x minus minus. After that again I'm writing switch x. This is what is called, guys, nested switch. Switch within another switch is called nested switch. Loop inside another loop is called nested loop. If else entirely inside another if or else or both is called as nested if else. Now here inside this inner switch case, I'm having case 1, which corresponds to printf C. Next and after that, here I'm having break statement. Case 2, guys, here I'm having another printf statement with C++. Here also I'm having one break statement. Case 1, case 2. Next we are having case 3, guys. Here we are having printf Java followed by, here we are having break statement. Next and after that, default, guys. Inside the default we are having printf Python. This is my code, sir. And after this, at the very last stage, we are having return 0. You know that it is returning 0 to the operating system. This is my code, guys. Now in this code, as per this coding is concerned, now what will be the output of the code? What is the output of the code? Observe very carefully. Now listen carefully, guys. The very first point is, forget about inner switch, guys. Forget about inner switch. First of all, concentrate on outer switch. Tell me, guys, can we write any statement? For the timing, don't concentrate here. Assume it is not even present. Tell me, guys, inside a switch case default, inside switch body, if we write any statement which not falls under any cases, do you think that that statement will execute, guys? Inside switch, all this statement will be executed only if they are present either inside any cases or inside any default. Suppose, for example, forget about that. We will bring this coding later. We will concentrate on this later. Suppose, for example, here I am having int main, guys, and here suppose, for example, I am having int x is equal to 2. Then I am writing switch x. Here I am writing case 1, guys, and here I am having case 2. Case 1, case 2. Here I am having break statement. Here also I am having break statement. Simple. And then we are having default. This is normal switch case default, guys. Now suppose inside the case 1, you are having some printf statement, printf high. You are having some printf statement high. Here you are having some printf statement hello. Next and after that, here you are having some printf statement, say bye. And let us assume inside this switch case, inside this before or inside the switch, 1 minute, guys. Yeah, come back, guys. So here, for example, I'm writing one printf statement. Printf welcome. And here, even after this default also, I'm writing some printf statement. Learning C. Tell me, guys, If I execute this code, what will be the output? What will be the output in this case? First question is this line will execute? No, this line will never execute. Inside the switch body, if you write any statement which is either inside any case or inside any default, they will be executed only. They will be executed only. Except this, anywhere if you write any code, they are not going to execute. Check it out. Execute, compile and run. Let's see what we are getting. Just we got the answer as hello. Why? Because sir, x is equal to 2, case 2 matches, hello got executed outside of the loop. Even if you are not having this break here, what will happen? Sir, hello will be printed, bye will be printed. Is learning C will be printed? Check it out. Execute, compile and run. Hello and bye will definitely be printed, sir. Check it out. Hello, bye. This is printed. Acha, this line they considered, even I'm giving this space, as no brackets are there, this line is considered under this default. So doesn't matter whether we are writing by maintaining the indentation or if we are writing in this way. Both these lines are considered as a part of the default statement. And once you are having this break, now default will not have the chance, only hello get printed. So moral of the story is what, sir? Inside switch case, if any statement have to execute, he have to be placed either inside any cases or inside any default. Here indentation, if you maintain or doesn't maintain, both will be considered under default. Because inside switch case we never give curly brace na guys. If it is multiple statement, do we ever write by using curly braces? No. Why? Sir, whatever statement you write na, whatever statement we will write here, no need to give curly braces. They will be considered under case 1 only. Similarly here, sir, after default, whatever statement you will write, whether you are giving curly brace or not, sir, can I give curly braces here? 100% you can give. 100% you can give curly braces here. Do we ever provide curly braces under this default or any cases? No, because it is not required actually, sir. Why it is not required? Sir, because here even if you write multiple statement, all will be considered under this default here. Now what will happen? Matching x is 2, hello will be printed, by learning C will be printed. Execute, compile and run. Check it out. Hello, by learning C will be printed. So every statement inside a switch case to execute, I have to keep them either inside any cases or inside any default. Now, from this basic discussion, guys, now you come to execute this code. You observe here carefully. My question to you, before you start making any evaluation, see this, guys. First x is equal to 2, switch 2. Is this line will execute? No. Why? Sir, it is not kept under any cases or any default. Is this switch will execute, guys? Is this entire switch will execute? Yes or no, boss? Is this entire switch will execute? No, it will not execute. Why? Sir, it is not even either any case or any default. It is not kept either any case or any default. So that is why this fellow will also not execute. This fellow will not execute. This x minus minus fellow will not execute. With this similar reasoning, this fellow will not execute. Are switch case, why not execute? You kept it in another switch, na? In another switch you are keeping means everything I have to keep inside either cases or default, which I am not doing. So neither x minus minus nor this will execute. Then what will be the output? Sir, no output will come. No output will come. Execute, compile and run. Check it out, guys. Any output came? Everyone got complete clarity? Everyone got complete clarity? Switch case. Great example, na guys? Yes, sir. Okay, up to 59 is ready, guys. I will share today. Up to question number 59, everything is ready. Yeah. Next. Let us take the next one, sir. Here, int x is equal to 2, switch x. I'm not having the nested switch anymore. Just switch x. Then I'm having case 1, printf C, break. Case 2, printf C++ break. Case 3, printf Java break. Default, printf Python. Return 0. End of everything, sir. Now, in this case, what will be the output, guys? In this case, what will be the output? Very simple one. Sir, x is 2. Matching case found. C++ will execute. Get out of the switch case. So, C++ is the answer. 2 bracket. Now, guys, 1. Execute, compile and run. We thought C++ should come and C++ is coming. Very simple one, sir. Control C. Next. Next and after that, sir. Suppose here I'm taking a for loop, guys. Int I, the variable I have taken here as I. Then I'm having a for loop for I is equal to 1, I less or equal to 100, I plus plus. Inside the for loop, I am having printf. Learning C is fun. Learning C is fun. Learning C is fun. After that, suppose I'm writing if I is equal to 5, break. If I is equal to 5, break. That's it. Now my question here is, how many times learning C is fun will be printed? How many times learning C is fun will be printed, guys? 5 times it will be printed, sir. Simple, very simple one. /n. Execute, compile and run. Only 5 times is going to be printed, sir. 1, twice, 3 times, 4 times, 5. Simple. This is very simple. Next and after that, let us take the next example, sir. Suppose here I'm having, guys, simple for loop which is rotating for 10 times, and inside the for loop I'm having one message here. What is the message? Welcome /n. This is the message. And now after that I'm having one continue statement, and after that I'm having printf hi. This is the code, guys. Now what you have to do is that you have to tell how many times welcome will be printed. Calculate and then decide. Chetan, your second answer is correct. First answer was not correct. Second answer is correct. Okay. Yeah, Modulina, your answer is also correct. What about others? What about others, guys? Okay, let us verify it. First time I is equal to 1, welcome will be printed. Next, which statement will execute, sir? Continue will execute. Once continue will execute, guys, remember, listen carefully. This is very important point. When the continue will execute, guys, in case of the for loop, the continue statement take the control to the modification part. But if it is while loop, now guys, in while loop, continue statement take the control not to modification part but to the testing condition part. I repeat, inside the for loop, execution of continue statement means control will be going to the modification part. But in case of the while loop and do while loop, if continue statement is present, that continue statement will take the control to the testing condition part. Okay, so continue, sir. I becomes 2. 2 less or equal to 10? Yes, welcome. Condition part. In the testing condition part of the loop, this is called testing condition part, guys. This is called initialization part. This is called testing condition part, guys. And this is called loop counter modification part. This is called loop counter modification part. So what will happen? Enonil, observe. I is equal to 1. 1 less or equal to 5. Printf welcome. Continue. Control comes here. What is the I value? Still 1. Na? Less or equal to 5. Welcome. Continue. Still 1. Na? Ultimately, what will become, sir? Sir, it will become an infinite loop. Execute, guys. Compile and run. Check it out. Welcome. It's printing continuously. It will continuously printing. It will never stop. Understanding, guys, the difference of continue statement with respect to for loop, with respect to while loop, with respect to, let me show you, with respect to do while loop also. Suppose here, guys, you are having one condition. While I less or equal to 5. While I less or equal to 5. This is with respect to do while loop. Do while loop, you know that it is an exit control loop. So control will enter directly, sir. No problem. Welcome will be printed. Continue. After continue, where the control will go? Testing condition. Tell me how many times welcome will be printed, guys? How many times welcome will be printed here? Again, infinite times, sir. Check it out. Welcome. Okay. Then continue. Where the continue will take the control? Sir, directly in the testing condition part. Directly in the testing condition part. Again, 1 less or equal to 5. Yes, true. What will happen? Sir, it will go back to the loop again. It will go back to the loop again. Printf welcome. Again continue. Again come here. Is I++ is getting the chance of execution? No, not at all. Not at all. Then what will happen? Sir, it will also become infinite loop. Execute, compile and run. Check it out, guys. Sir, started printing infinitely. Started printing infinitely. So what is the difference of continue statement with respect to do while loop versus for loop, guys? I hope you will able to give the answer, guys. Sir, continue statement inside a for loop takes the control to the modification part. Continue statement inside a while loop or do while loop take the control to the testing condition part. Everyone got the clarity? You will able to remember, guys? You will be able to remember? Yeah. So let us take the next one. Let us take the next one. Suppose, for example, here I am having what happened, guys? Yeah. Suppose I'm writing int I for I is equal to 2. Then I is equal to 100. And then I plus equal to 2. Then I'm having printf I. Printf I slash n. Printf I slash n. Observe carefully and then give the answer. How many times the high will be printed? Why Madhulina? Why compilation error? What is the reason of compilation error? Why you are thinking in that angle, sir, this code will have the compilation error? Why? What is the reason? Why you are thinking of this compilation error? Syntax error, : condition part missing. Why condition part missing? Condition part is there, na? Condition part is there. I is equal to 100. Are condition part means what? You think that always I have to write I less or equal to 5, I greater equal to 5. Here semicolon is kept, here semicolon is kept. Condition part, this is my condition now. This is my condition. Who told you that condition part always means I greater equal to 5 and I is equal to I lesser equal to 5? Anything I can have, na? Anything I can have. Only thing is that what is the rule? This is the for loop general syntax. Observe carefully. Loop counter initialization. Loop counter initialization. Then semicolon. It is a part of the syntax. Remember. After that testing condition. After that testing condition. Followed by loop counter modification. Followed by loop counter modification. This is the syntax of the for loop. Then what is the working principle? Sir, if the testing condition is true, if this fellow gives me a true value, then body will be executed. If testing condition become false, body will not be executed. Body will not be executed. And as a part of this semicolon, these two are part of the syntax. You cannot skip anything. You can skip loop counter initialization part, but you cannot skip the semicolon. You can skip testing condition part. If you skip testing condition part, it will be forever true, guys. It will be forever true. Loop counter modification, you can also skip. Suppose, guys, for example, you want to print welcome 5 times. What are the options for printing welcome 5 times? Let me comment this one. I want to print welcome 5 times. Simple code, what you will write? Sir, for I is equal to 1, I less or equal to 5, I plus plus, I plus plus. Here it is printf welcome. Here it is printf welcome. This is what normally you do. And it will be printing welcome 5 times. Execute, compile and run. 5 times welcome will be printed, sir. Welcome, 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 welcome. Next and after that, what are the different variation of writing this for loop? Sir, I will not write here. Then where you will write? Sir, I will initialize here. Is it possible? Yes. Same welcome 5 times now, guys. Yes, sir. Same welcome 5 times. Only thing I added slash n means will be in different lines. Done. Sir, I will not write the modification part here. Then where you will write? Sir, I will write in the body. But if you write in the body, guys, now body is having 2 statements. Now body is having 2 statements. Then what you have to do? Sir, I have to compulsory go for the curly brace. I have to compulsory go for the curly brace. Sir, is it going to print for how many times? Execute, compile and run. This is also going to be printed for 5 times. Sir, I want to skip the testing condition part also. I will not write here. Now if you miss the testing condition part, by default it will be forever true. By default it will be forever true. Then automatically what will happen, sir? It will become an infinite. It will become an infinite loop. Check it out. Welcome, 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 printing, printing, printing. Still it is printing, guys. So different variation of writing for loop. I hope everyone got clarity. Everyone got clarity. But here one very important point is that, guys, for while loop, you cannot skip the condition part. That will be considered as a syntactical mistake. Suppose I is equal to 1. This is initialization loop counter for while loop, guys. Testing condition is how? While I less or equal to 5, and then inside it something say welcome, something say welcome, welcome, and lastly say, sir, I plus plus. How many times welcome will be printed? Sir, welcome will be printed 5 times. No doubt about that. Execute, compile and run. Execute, compile and run. Now here someone is asking, Acha, in a for loop you can skip testing condition part, it will consider by default always true. In a while loop, can you skip testing condition part? Will it consider by default always true? No, it is a syntactical mistake, sir. It is a syntactical mistake. Now compiler will give left and right. If you have to make it true, write 1. Only 1, sir. Are any value, guys? Sir, if I write -1, then it's a true value. Then also infinite loop, no, sir? Yes, infinite loop. Any value other than 0 is considered as a true value. So -1 is the true value. Once it is a true value, loop will be rotating continuously. The basic doubts, the basic clarity with respect to for loop, while loop, different approaches. Getting clarity, guys. Now you consider this one. Sir, what is the output in this case? How many times do you think that I will be printed? Now everyone should give the answer. Chetan, observe here. I is equal to 2. After that, I is equal to 100. I is equal to 100. Is 100 is a true value? Chetan, is 100 is a true value? Yes, sir. What will be printed? High. After that, where control will go? After that, where control will go? Sir, control will go to the test modification part. I will become 4. I will become not 4. Last time it was 100, now it become 102. It becomes 102. Then control again come here. And again it becomes 100. So 102 is override by 100. Is it a true value? Yes. Will you enter? Yes. High. Comes here. 102. Again 100. True? Yes. Enter here. 102. 100. True? Enter here. Understanding what is the output we are going to get, Chetan? Sir, it will become an infinite loop again. It will again become an infinite loop. Execute, compile and run. Execute, compile and run. Check it out. Hi, it's printing. Got the clarity? Here 100 is assigned to I. Is it a true value? Yes, sir, it is a true value. Someone is telling, sir, I'm assigning 0 to I. Tell me, guys, how many times I will be printed now? How many times I will be printed, sir? Good. This time I will be printed 0 times. No time, sir, no output. Execute, compile and run. Okay, now guys. Yes. So you have to be careful. You have to make your basics correct. Then decide. Then take the decision of how many times it is going to execute, sir. Yeah. Next and after that, guys. Observe carefully. Say for example, delete this. Yeah. Suppose here I'm taking one double variable. Double a is equal to 0. Then I'm writing for k is equal to 0.0. K less than 3.0. K plus plus. Then I'm writing printf. To print double value, we need long float. Percentile LF stands for long float, comma k. This is the coding. What will be the output of this code, guys? What will be the output of this code? Tell me, students. What is the output here? Modulina, your answer is wrong. What about others? Respond, guys. No need to worry about your, whether I'm going to scold or not. I'm not going to scold you. I will make you correct if you make any wrong answer. What is the correct answer, guys? Okay. Let me tell you. First of all, there is a semicolon at the end of for loop, guys. If a semicolon is there at the end of for loop, don't think it is a syntactical mistake. It is not a syntactical mistake, guys. It is not a syntactical mistake. Okay, na? First point is it is not a syntactical mistake. On top of that, compiler will treat this semicolon as if in the next line. Compiler will treat it as if in the next line. Hence, what will happen? Suddenly, I thought that this printf is a dependent on the for loop, but as the compiler considered semicolon as the next line, this printf is now independent of the for loop. Now, guys, this printf is now dependent on the for loop. No. It is under the for loop. No. It is outside of the for loop. Yes. It is outside of the for loop. Yes. But sir, code was written in this way. I thought that it is there under the for loop. No, 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 you are wrong, because compiler will treat it in the next line. Sir, what it means? Simple, guys. It means a null statement. Oh, not null value, guys. Not null value. It means a null statement. Sir, what is null statement? No statement. No statement. That's a null statement. Sir, can I write a C program like this, sir? Can I write a C program like this, sir? I give semicolon, I give semicolon, I give semicolon, I give semicolon. And here I'm giving these many semicolons. Is the program is going to compile? Why not, guys? Why it will not compile? Everything is syntactically okay, na? Everything is syntax okay. 100% code got compiled, sir. Any error is there? No error, sir. No error, no warning. What is this? Null statement, 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 like this. Same, sir, here. If you are writing, if once the compiler is considering this semicolon as if in the next line, so it is a null statement. Now this is your for loop. Your for loop is up to this. Your for loop is up to this. Printf is not under the for loop anymore. Then what will happen? Sir, first time k is equal to 0. Next time, is 0 less than 3? Is the 0.0 is less than 3? Sir, here it is not 3, 3.0. Is 0.0 less than 3.0? Yes. What will happen? True value. Body will execute. What is your body? Sir, only semicolon. What is your body? Only semicolon. That is a null statement. After that, sir, control modification part. It will become 1.0. 1.0 less than 3.0, true. Again null statement. 2.0. 2.0 less than 3.0. Yes, again null statement. Now it becomes 3.0. 3.0 less than 3.0. No, sir. Is the control will be there in the for loop? No, sir. Outside of the for loop. Outside of the for loop means this fellow will execute. What is the value of k? 3.0, sir. What is the value of k? 3.0, sir. Execute, compile and run. Execute, compile, run. Check it out, guys. Understanding, getting perfect clarity. Any doubt? 100% clarity you are getting? Yes. One minute, guys. Let me really delete this. Yeah. Let's go for the next one, sir. Suppose, for example, guys, here I'm writing a while loop. While inside this I'm writing printf welcome. While printf welcome, second bracket open, second bracket close. That's it, sir. My code ends here. If this is the code, sir, the question is how many times welcome will be printed? How many times welcome will be printed? You have to tell us. Tell me, guys. Acha, Innonil. 1 minute, guys. Innonil. Which one you are asking for repetition, Innonil? One more time. 1 minute, guys. Chetan, your answer is correct this time. Innonil, which one you are asking for repetition? null statement. Acha, 1 minute guys, I will come back to this one. 1 minute, let me repeat this. Yeah, you only observe in a C function I can have a semicolon, only semicolon. Suppose you are writing printf hi, after that you are giving a semicolon. Is it a null statement? Is it null statement? No. Why? Sir, something is there, na? Some statement is there, sir. That's why no, not a null statement. Not a null statement. This is not a null statement. Why? Sir, something is there. Something is there. Compulsory it have to be printf. No, no, sir. It can be scanf also. It can be scanf also, sir. It can be x is equal to 10 also. It can be int x also. It can be int x also. These are not a null statement. These 3 lines are not a null statement. Up to this you understood, Indonil? Up to this you understood? All the 4 statements are not a null statement. Yeah. Now suppose you are writing like this. Just a semicolon. Anything is there? No. Any statement is there? No statement. This is what is called no statement. No statement. This no statement is technical terminology is null statement. The no statement technical terminology is called what? Null statement. Now once you write a for loop, suppose you write a for loop hoping that it will print your name 5 times. I is equal to 1, I is equal to 1, I less or equal to, or 3 times I plus plus. Let me take here as int I. You thought that, sir, it will be print my name 3 times. Here you wrote say printf. Here you are writing Indonil. Hope that it will be printed 3 times. Yes, it will be printed 3 times. What is the problem? 100% it will be printed 3 times. No, sir. Execute, compile and run. Execute, compile and run. Yes, it is printing 1 minute. 1 minute. Here. It will be printed 3 times, sir. Execute, compile and run. Execute, compile and run. As per our expectation, it is printed 3 times. Now, by mistake, what you have done here, you put a semicolon. By mistake, you put a semicolon. Now, what will happen? Is Indonil is going to be printed 3 times? No. Why? Sir, this semicolon, though I kept it here, sir, compiler internally it will treat it in this way, sir. Compiler internally it will consider in the next line. What is that? No statement. What is that? Null statement. Now, even you thought that this printf is under the for loop, but is it really? Because we know now in the body, if we are having more than one statement, compulsory I need what? Curly braces. Compulsory I need what? Curly braces. Is curly braces is there? Not there. By default, it will consider which line? Just the next line. By default, it will be considered which line? Just the next line. Then how? What will happen? Sir, 1 less or equal to 3? Yes. Execute the null statement. Next, 2 less or equal to 3? Yes. Execute the null statement. Next, 3. Is 3 less or equal to 3? Yes. Execute the null statement. Next, 4. Is 4 less or equal to 3? No. False. Don't execute the null statement. Get out of the for loop. Get out of the for loop. This is for loop. Get out of this means come here. What you will print in no name? How many times it will be printed? Only once. Check it out. Got it? Null statement, for loop ends with semicolon, everything got clear? Yeah. Now come to this one. This is the code. Tell me guys, Chetan already given his answer. What is the output, sir, in this case? Not many, technical term is infinite times. Not many, infinite times. Sir, what will happen here? Sir, already you told us in some example, return type of printf function, return type of scanf function. You remember guys? Return type of printf function is int, return type of scanf function is int. Now what int? Sir, welcome will be printed. Welcome will be definitely printed. After printing welcome, printf function will return here what, guys? In this place, printf function will return what, guys? Not 1 modulina. Printf function will return here 7. Printf function will return here 7. The number of characters that is printing successfully to the console. How many number of characters, sir? 1, 2, 3, 4, 5, 6, 7. So 7 numbers. So here what value while loop will see? 7. Is 7 is a true value? Is 7 is a true value? Yes. How many times while loop will execute? Sir, entire lifetime. Entire lifetime while loop is going to be executed. Sir. Check it out. Entire lifetime while loop is executed. First times welcome printed. 7 got here. True, yes, true. After that control come back here again. Again printf welcome. Again returning 7. Again body. Continue. Sir, I have done this. Nothing. I didn't write anything here. And in the body, I'm having printf hello. I'm having printf hello. Tell me, guys, how many times hello will be printed? How many times hello will be printed, sir? Achha, you thought infinite times. Observe here carefully. Execute, compile and run. Execute, compile and run. No time, sir. No time. Why no time, guys? Sir, first this printf will execute, na? What it will print, Modulina? What it will print? Will it print anything? Oh, don't say it will print 0. Will it print? Say it will not print anything. Are, how it will print 0, Ray? How it will print 0? It will not print anything. It will not print anything. Are not printing anything and 0 are same, boss? Is not printing anything and 0 are same? No, na? So it will not print anything. If it is not printing anything means what? What value will be returned? 0. Acha, if you are talking in that angle, sir, it will be returned here 0, then okay. I thought you were talking from that angle. It will be returned what? 0. Yes. Now that's fine. Now if it is 0, what it becomes? While 0. Will it enter in the body? Will it enter in the body? No, sir. How many times hello will be printed? No times. Acha, if I make a 0 here, how many times hello will be printed, guys? Correct? Infinite times. Sir, 0 will be printed. Then what will be returned here? One character, na sir? 1 will be returned. True, again body. True, body. 0, true, body. 0, true, body. Sir, infinite times body will execute. Infinite times I will get that hello, 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 like this, sir, it will happen. Of course, 0 and hello, 0 and hello, 0 and hello, 0 and hello. Understanding, guys? What is my original program? This is my original. Make sure you practice this question once in a while, guys. Otherwise, just one time you may forget. I'm sharing the notes. Once in a while, you just practice this question. Or if possible, you can make someone understand, then that will be good for you. Okay, na? Now suppose I'm writing here. 1 minute. Tell me, guys, I remove this curly braces. What will happen? What will be the output of the code? Tell me guys. Chetan telling syntactical error. Chetan, it will not be syntactical error. First, let me give you clarity to Chetan and Indonil. Both they thought that syntactical error. Let me tell them why the syntactical error will not come. Because when you write a while loop, what is the syntax, sir? General syntax: loop counter initialization. Initialization. But it's not compulsory you have to initialize the loop counter. This is general syntax. This is general syntax. After that, while, first bracket open, testing condition, curly brace, this is body, and somewhere in the body, sir, where at the beginning, middle, anywhere in the body, we must have loop counter modification. This is the code. Now, is the curly brace is compulsory? No, sir. If the body contains more than one line, then curly brace is compulsory. Then curly brace is compulsory. Can I write a while loop like this? Int I is equal to 3, while I less or equal to 5, I plus plus. Yes, you can write, sir. What is the problem? You can 100% write. But if I write like this, guys, suppose for example, let me copy paste. Let me copy paste. Sir, I write like this. First of all, am I going to get any syntactical issue? No. 100% no syntactical issue, sir. Execute, compile. I'm not interested about out. Any syntactical issue is there or not? Execute, compile. Only compile. Any syntactical issue? No. I remove this one. Any syntactical issue? You thought yes. But what is happening, guys? This return 0 fellow, na, it is considered as under the while loop in this fashion. It is considered in this fashion. Though it is written in this way, it is considering in this fashion. That's why no syntactical error, sir. Execute, compile. Take it out. Okay, na? So let me go back to my original coding. What I was given to you. This is the code. You thought after curly brace some statement must be there. If more than one statement, curly brace is there. If not more than one statement, we can ignore the curly braces. And the sir have not even write that statement, then 100% syntactical error. No. Return 0 is considered as that line which you have not signified. If we not write return 0 at the end, what will happen? Execute, compile. In this case, the while loop is not having the body. Now the mistake is there, na boss. Understanding, Chetan? If you are having the return 0, it is considering as a part of the body. If it is not having that return 0 also, sir, then I am not able to help you guys. Then I am not able to help you. Now it is a part of the syntax. Even you can make a compatibility matching here as void, but still, sir, the problem will be there. While loop is not having the body. Got it? Everyone got it perfectly? Seems very easy, guys, but see internally when you are learning that for loop, while loop, small things, so many variations are there. That's why with respect to programming language, we should not be in a position to tell I have learned, I know the programming language. You should always have the feeling I am learning, because every day you will say I completed learning, something new will come. In your entire lifespan, you will not be able to complete the learning of programming language. Every day new thing will come. Every day new thing will come. Okay, so that's it, guys. I will share this document with you. Rough document I will definitely share. Yeah, it will print welcome once. It will print welcome once, Chetan. It will print welcome once. Check it out. Why? Because after this, when the body will execute, what is the statement? Return 0. Then immediately control will be returned back to the operating system. That's why no way to execute anymore. That's why it will be reprinting that welcome only once. Okay, they can ask the question in this way also. In this case, how many times welcome will be printed? One option is syntactical error. High chance that you will go for syntactical error. Okay, guys. Okay. So tomorrow again we will meet. Right? Tomorrow our timing will be same time. Now onwards every day we will have the session from 8:30, guys. Okay. Yeah. Let me share today's note. I will update accordingly. Again, I will try to update the question because till now 59 question I have perfectly updated by adding those options, explanation. You can take a note of that. Currently no batches are there, guys, with 5 PM 6 PM because it's not anymore in my hand to take the classes at that time. Only thing is that available slot is left is 8:30 to 9:30 and 9:30 to 10:30, guys. After your session I have to go for data structure session also. And other than this, only weekend, guys. Acha, extra problem. Okay, Chetan, will do that. Just give me some time by the end of this weekend because normal days I will not have any time, guys. Just once Saturday comes, na Chetan, Friday or Saturday, just remind me once. I will add you a Google Classroom, practice test for you. Okay, if possible, I will try to add by tonight, but high chances is that not possible. Otherwise, I will add it in the coming Sunday, Monday. I will add it for you. At least 3 tests I will add it for you. Okay. Yeah. Thank you, guys. Thank you, guys. Good night. Yeah. Next and after that, we are going to discuss about pointers. So operators and expressions, control structure, arrays, pointers, followed by functions. Next and after that, we are going to cover character array. That is nothing but string. Character array, that is nothing but string. Next and after that, we are going to cover about storage class and data types. Storage class and data types. Next and after that, we are going to discuss about structure, union, enum, and type def. Next and after that, we are going to discuss about the preprocessor. Next and after that, we are going to cover the files. So these are 11 chapters which we are going to discuss. But as I said, not from scratch. Assuming that you have the knowledge of C programming language, MCQ with respect to these concepts will be discussed. At least 200 MCQ I am going to cover throughout this session, throughout the duration of the course. And while discussing those MCQs at any stage with respect to any particular chapter, if I found that you are not having the knowledge, then that particular part I will discuss and then take those MCQs. Other than that, everything will be discussed at runtime. Discussion at runtime means, suppose whenever I will start a discussion about operators and expressions, Now under C programming language, we are having so many operators: arithmetic operator, relational operator, logical operator, bitwise operator, special operator, increment, decrement operator. So many operators are there. So it will be not be like a C session where first operators will be taught and then MCQs will be taken. No, directly from the beginning MCQs will be taken, and while the clarity with respect to that particular MCQ, how to get the output with respect to that particular MCQ, while giving the lecture based on that at runtime, at that time, for that operator, whatever necessary information will be needed, that I will provide to you. That's why I said that the prerequisite to attend this session is that you must have a C programming language. At least it is not required you have to be master of that C programming language, but at least if you have basic idea, then I will be able to work on that thing. Along with that MCQ, there are some tricky interview questions are there, which generally ask at the time of interview. So those type of questions also I will cover as a part of the course. Duration of the course will be 45 to 60 sessions, right? Initial 5 or 6 days, though they will mention it as a demo session, it's a demo session to you people. To me, it is not anymore a demo session, because from today only I will start discussing everything. So demo session is separate, and then again the session will be start freshly. Not like that. Session is going to start from today only. It's for you to decide whether to continue with the course or not. For that, it is the demo session. Now, if you feel that it is good for you, it will be helpful for you, then you have to join the session by registering to that Durga Soft, right? And once your joining will be completed, then everyday note, running note, whatever I will discuss, whatever is the necessary thing, that I will provide you in a Google Classroom. But today Google Classroom will not be created. Once you become a registered member, then the Google Classroom and will be created, and I will start the sharing the notes. Initial 4 or 5 classes, as it is a demo session, no note will be shared. You can take the picture, you can take the note parallelly at a runtime also. But once your registration process will be completed, then I will share everyday note. Now from the Durga Sub point of view, they will share the everyday lecture video. That means if you miss any session, that session will be there in your mail ID, in your what is called that Google Drive. Those videos will be shared from there. From their side, they will definitely share those videos, right? So these are the things that is going to be provided as a study material. That is the video and the runtime notes, as well as any note that will be necessary for understanding any particular topic. Recorded video will be sent. No need to worry for that. Okay, Viraj. Viraj, if you want to join that data structure batch, what you can do is that, as you are showing interest to join in that data structure batch, you can directly contact to DurgaSoft, right? They will guide you how to join the batch, because already the session has started. If you want to join, you can join, but in that case, all the recorded videos, whatever already discussed, you have to go through those videos, right? You can join there. Ritik, yes, you also can join, but for that you have to join. You have to contact to DurgaSoft only. That the course duration for that data structure is say 2.5 months. Already 1 month, close to 1 month is over. Another, not 1 month, few sessions have been done, 15 or 16 sessions have been done. Now it's continuing, so you can join, but in that case you have to make it up by watching those videos, and for that you have to contact DurgaSoft. They will guide you. Okay. Yeah. So let me start today's session. Let us take the first problem state, first example. Now, in this first example, say for example, I'm writing here printf. Now, it will not be like all other session where you will not respond, just silently watch those videos. No, because it is for interview preparation as well as it will be for practice session. So what you have to do is that you have to be responsive. You have to, whenever I will ask the question, you have to respond in the chat box. Forget about the correct answer or wrong answer, because even if you are giving any wrong answer, no need to worry, because I'm not going to scold you. I will make you correct. But if you are interactive, if you're giving the wrong answer, then automatically next time when the same type of question will appear, you will definitely make it correct. But if you are not giving the answer, just silently watch like a YouTube videos, then automatically what will happen? You will not make the mistake now, and at the time of interview, there you will make the mistake. So that's why my suggestion is always try to be responsive and try to give answer in the chat box. Let us take the first example. Printf, the value is equal to percentile D, and here I'm writing 20 plus plus. This is my code. Printf, the value is percentile D, 20 plus plus, and my options that are available here is one is 20, one is 21, one is compile time error, and another is runtime error. Tell me, students, what will be the answer in this case? Everyone, forget about correct or incorrect. Just make a habit of responding, and then I will make you correct. Yes. See here, in this example, the operator that I used here is plus plus. So plus plus means what? Plus plus means it is a increment operator. It is a increment operator. Now increment operator, what it does? This is the symbol. Increment operator, what it does? It increments the value by 1. It increments the value by 1. That's the role of increment operator. Now, how many type of increment operator we are having? We are having two variation of increment operator. We are having two variation of one is pre-increment. Number one is pre-increment, and number two is post-increment. This is the variation we are having. This is about the increment operator. Similarly, we can have decrement operator too. Plus plus is increment operator. Decrement operator means it will be like minus minus. There also we are having two different variation. Post-increment, like pre-increment, post-increment, they are also pre-decrement, post-decrement. Now, what about the working principle for pre-increment and post-increment? Pre-increment means first it will be incremented and then with the updated value it will work. Post-increment means it will use the original value in the expression. Later, before moving to next line, it will increment the value. Now, in this example, what will happen is that normally another restriction is there. What is the restriction? The restriction of pre-increment or decrement operator is it can be applicable. It is applicable. It is applicable only to the variables. It is applicable only to the variables. This is the restriction of the increment operator. Now observe here carefully. 20 plus plus. 20 plus plus. The question here is 20 is a variable? Is 20 is a variable? What is the answer, guys? Do you think that 20 is a variable? 20 is not a variable. What is 20? 20 is a constant. 20 is a constant. What is the rule of the increment operator? It is applicable only to variables. Are you applying it to the variables? No. You are applying it to the constant. What is the drawback of applying it to the constant? Suppose, for example, if I assume that 20 plus plus is true, you know that Plus plus means it will be incremented by 1. I said that already. So if 20 plus plus is true, if I assume that 20 plus plus is true, then it means 20 is equal to 20 plus 1. Tell me guys, is it possible 20 is equal to 20 plus 1? No sir. 20 is equal to 20 plus 1? No way it is possible. That is why if I compile this code now, 100% I am going to get a compilation time error, because the mistake that I am doing is I am not incrementing any variable. I am incrementing a constant. Constant cannot be incremented. 20 means 20 only. You cannot have 20 plus plus. If you have a variable x is equal to 20, then you can have x plus plus, because x plus plus means the variable. Variable can change. That's why the name is called variable. Why it is called variable? Because it varies. It can change. But constant means it should be fixed. It should not be changed at any time. That is why if I now go for compilation of the code, see this, execute, I'm compiling the code. What is happening? Some compilation error is generating, and see in which line the compilation error is coming. 1 minute, show that error also. See the line where error is coming, in this line, because this is where I made the mistake. And along with that, you read this, you read the error. Later I will give the clarity. What the error is telling? L value required in increment operand. What is the error we got? L value required. L value required. Let me copy this. What is the error it got? What error we got? L value required. L value required as increment operand. Sir, why this error is showing L value required? What is that L value, sir? Now listen carefully. This is which operator? This operator is known as assignment operator. Is known as assignment operator. Every operator must have some restriction. You cannot do it whatever you want. You have to follow those restrictions. Like increment operator having one restriction, na? It is to variable, but not to any constant or any expression. Similarly, assignment operator is also having a restriction. What is the restriction? On the left hand side of assignment operator, there should be a value, not a constant. On the right hand side, you can have a variable, you can have a constant, no restriction. But on the left hand side, you must have a variable, not a constant. But currently, due to the 20 plus plus, it becomes what? 20 is equal to 20 plus 1. Are you following the rule of assignment operator? No. And the left hand side variable is called as L value. The left hand side variable is called as a L value. That is why compiler is giving the error and it is telling I required as a L value. I required as a L value as increment operand, because here whatever you are trying to increment, it is a constant. I need is a variable. L value means it is a variable which can change. L value means it is a variable which can change. Currently, due to your increment, internally it is the thing that is happening where I am not getting any variable. I am getting the constant. That's the reason of the error. That is why, with respect to this code, this is our question number 1. What will be the output of the following code? So, from these options, these are the options with respect to this particular question. So, what is the answer to this? Answer to this is option number C, compilation time error, and this is the explanation for this one. Tell me, students, anyone is there? Sir, I didn't get this. Everyone understood? Students, make respond in the chat box. Everyone got the clarity about this one? Yeah. Let me move to the next one. Yes, clear. Good, very good. Let us move to the next one. Int I, yes, int I is equal to 0. J is equal to 1. K is equal to 2. And M. Okay. Here I'm writing M is equal to M is equal to M is equal to I plus plus. This is called logical OR. Then I'm having J plus plus. This is called a logical OR. Then I'm having K plus. And then lastly, I'm printing everything. I, J, K, and M. All the values I'm printing here. Let me print. Here, M is equal to I is equal to J is equal to K is equal to. What will be the output in this case? What will be the output, guys? Okay, Prashad, let's see. Let us verify it once. What is the output? Suppose, for example, first of all, here, what about this operator, guys? This is known as logical OR. Take it here directly. This operator is known as what? It is known as logical OR operator. Now, logical OR operator have one rule. What is the rule? Suppose A, B, A or B. Now, what is the rule here? Very simple one. 0 or 0, it is 0. 0 or 1, it is 1. 1 or 0, it is 1. And 1 or 1, it is 1. Everyone knows that. This is the truth table for logical operator. But what is important point here is, observe carefully. This is where you have to focus. This is the important part of the logical OR operator. What is the conclusion that we can take from here for the logical operator? See, if the first operand, this is called operand, guys. A is an operand, B is an operand, and this is operator. So it becomes operand, operator, operand. How many operand is there? 2. How many operator is there? 1 operator. What is that operator? Logical OR, bar sign. Here the conclusion is, if the first operand, observe carefully, is the first operand is true. True means 1. True is indicated by 1. If the first operand is true, is there any need to execute the second operand? Is it meaningful to go for the second operand? No, no. Because whether the second operand is 0 or the second operand is 1, the result will always be 1, sir. The result will be always be 1. So just from these two lines, what we can conclude, if the first operand is true, second operand will not be evaluated. Second operand will not be evaluated. Why? Because as the final result will always be true. As the final result will always be true. That is why second operand will not be evaluated. But you cannot say this in this case. If the first operand is 0, can you tell the final result? No. Without seeing the second operand, you cannot see the final result. If the second operand is 0, final is 0. If the second one is 1, final is 1. So I have to check the second. But here if the first operand is 1, sir, no need to check the second. And it is evaluated in that fashion also. They never execute the second part once the first operand is true for the logical OR operator. For the logical operator, once the first operand is true, they will never evaluate the second part. Now you see here, I++. Here, post increment. Post increment is what? Here the value will be considered as 0 for evaluation purpose. For evaluation purpose, here the value will be considered what? 0. So that means M will treat in this fashion. M is equal to, he will treat the value here as 0. But internally here the value me to work as 0. I got here as 0. But internally, before going to the next half, that means the second half, before coming to the next half, internally I will change its value and will become 1. I will change its value and become 1. That result will not come to me. That result will not come to me. That result will not come to me. Right? To me, the result that will come is 0. But internally, I will become 1. So once I got a 0 here, what is my feeling? Should I go to the next step or not? Yes, first operand 0 means second operand you have to check. So I am moving logical OR. Then what about this J? Sir, J is 1. So here what value will be considered? 1. Here what value will be considered? 1. Then plus. So that means what? Internally, J will become what? What is the original value of J? 1. So internally J will become what? 2. Internally J will become 2. Now M is equal to 0 or 1. Now you see there is another logical OR operator is there. That is basically for K++. That is basically for K++. Now in case of the operator, whenever you are evaluating any expression, with respect to operator, a very important concept is there. What is that concept? That concept name is operator precedence and operator associativity. Without having the knowledge of operator precedence and operator associativity, we cannot evaluate any expressions. Without having the knowledge of operator precedence and associativity, we cannot evaluate any expression. Then automatically the question will be raised. Sir, what is known as operator precedence and what is known as operator associativity? First precedence followed by associativity. Now precedence determines the order. Precedence determines the order in which the expression will be evaluated. Precedence determines the order in which the expression will be evaluated. For example, if you carefully observe here in this particular example, whatever I have taken here, if you carefully observe here, my expression is 5 plus 10 into 2. So if I ask you what is the value of 5 plus 10 into 2, immediately you will say, sir, it is 25. But is it 25 in your own choice or it is getting that 25 logically? It is getting that 25 logically. How you are getting that 25 logically? Very simple, sir. See how many operators are present here? 2 operators. Plus and multiplication. Plus and multiplication. Between that, who is having high precedence? Sir, multiplication is having the high precedence. If multiplication is having the high precedence, is it the factor I am telling you multiplication is the high precedence and you started believing that as I said multiplication is having the high precedence and multiplication is having the high precedence? No. There is a rule is there. What is that rule? Precedence and associativity rule. Is it my own rule? No. It's predefined rule. Now, if you check that precedence and associativity chart, I will give you the clarity that of the chart slowly. But just for today, observe here carefully. In this chart, you see where is the multiplication? Sir, there is the multiplication. Their multiplication is present. And where is the plus? Here is the plus. Who is having high precedence? Multiplication is on top of the plus now. So multiplication is having high precedence compared to plus. Multiplication having high precedence to plus. That is the reason in this expression you are telling, sir, the answer will be 25 because multiplication precedence is higher. That's why 10 into 2, 20, 20 plus 5 becomes 25. Then what about associativity, sir? Associativity means, suppose in an expression, guys, suppose I'm asking you, simply I'm asking you 5 into 4 by 2, what is the answer? Then you will say, what is the answer? 5 into 4 by 2, definitely the answer will be 10. I know that, but I have a question here. What is my question? Is it 5 into 4, 20 by 2? That's why is it 10? Or my question is it the factor 5 into 4 by 2? That is why it is 10. Because if you say, sir, 5 into 4, 20, I will do 20 by 2, 10. Yes, 10. If someone say, no, I will do 5 into and then 4 by 2, I will make it 2 and then 5 into 2, I will make it 10. So anyhow, answer is correct. If you say 10 as the answer, answer is correct. But the question is, which is the process to get that 10? Which is the process to get that 10? First, you observe here how many operators are there? 2 operators, multiplication and division. Then what I have to do? Sir, I have to go to the precedence associativity table. Let's go there. In the precedence associativity table, check it out. Multiplication and division, they are in the same block. Same block means same precedence, guys. Don't think sir wrote multiplication before that division and then division is written before that modular division. That's why multiplication is having high precedence. No. I can write these 3 in any order. But in a same block means they are having same precedence. All these 3 are having the same precedence. Different block means precedence is higher compared to this. Now this fellow is having high precedence compared to this. But whenever you are in a same block, that means all of them precedence are same. Doesn't matter how I wrote. Precedence are same in a same block. Once precedence are same, you have to go for the concept that is known as associativity. What is the concept, guys? Name of that concept is associativity. The name of that concept is associativity. This is associativity, right? Now, associativity can be 2 types. One is left to right, one is right to left. Now, for multiplication and division, if you see the associativity, the rule is left to right, guys. The rule is left to right. Now, that is why, sir, if you ask me, both of the answer is giving me 10, but which one is the correct? Sir, I found here associativity. Because why you are going for associativity? Because multiplication and division both are same precedence, sir. So which one will be first evaluated? I don't know. Then you have to go for associativity. What is the associativity? Left to right. That means first this part will be evaluated and then that result will be divided by 2. That means, sir, first will be done 5 into 4. 5 into 4 equal to 20. Now that 20 will be divided by 2 and hence the answer is 10. So if anyone think that, sir, 5 into and then 4 by 2 is 2, that's why the answer is 10. That is incorrect. That is incorrect. Just for this example, you may get the correct value. If you take a different set of values, you will get a wrong value if you thought in that direction. The correct direction is following the rule of associativity, which is from left to right. Similarly here, guys, why I'm discussing this left to right concept. Now, similarly, if you see here, how many logical OR is there? 2 logical OR is there. Can you make the comparison between their, can you compare them in terms of precedence? Sorry, in terms of precedence, I cannot compare. Then what you have to see? Sir, I have to see the associativity. Let's see the associativity of logical operator, logical OR operator. The associativity of logical OR operator is left to right, guys. Where it is, sir? Here. Check it out. This is logical OR operator and associate. Later, I will tell you how to remember the entire chart. No need to confuse and no need to thought like that. Sir, such a big chart every time. How can I remember from where I will get that chart? I will give you a shortcut. By that, very easily, the entire chart you will be able to remember. No need to worry for that. With time, you will get that. Now, you see the logical OR operator is what? Left to right. Left to right. Now, what will happen, sir? First of all, here I am having 2 logical operators. 0 or 1. Associativity is left to right means, sir, this part will be first evaluated. This is one part. Now, this part This is one part and this is another part. This is one part, this is another part. Why you bracketize in that one? In that way, sir, associativity, na sir, associativity is left to right. That's why I have to make sure na which logical OR will work first. Then how can I determine? With the rule of associativity. Are associativity is what? Sir, associativity means in the absence of the bracket, how the expression will be bracketized. That is followed by the rule of associativity. What is associativity? In the absence of the bracket, how the expression will be bracketized. Oh, that is why you are bracketized in this fashion. Yes, sir. Then, sir, I will bracketize again this portion of this. The entire thing I'm bracketized. Why you are bracketized in this fashion? Sir, left to right I'm going, na sir, because the rule is itself left to right. Now you go for it. You will remember, in our country, evaluation always starts from left to right. You may bracketize the expression following the rule of left to right, right to left. That is just the bracketization will be done, not the evaluation. In our country, we always evaluate from left to right, but bracketization might follow the rule of left to right or right to left as per the associativity is concerned. Now I started evaluating, sir. 0 or 1. 0 or 1. Sir, 0 or 1. What is that value, sir? 1. 0 or 1. Already you know na boss? 0 or 1. What is that value? 1. So this part is giving you what value? 1. Now 1 followed by logical OR. 1 followed by logical OR. Tell me, students, will you show interest to go to this part? Logical OR operator. First operand is true. Will you show interest to go to the second part? Yes or no? Make respond in the chat box. Will you show interest in moving to the second part? No, sir. I will not go to the second part. Why? Sir, meaningless. If first operand is 1, na, result will be 1. Why should I waste time by going to the second part? That is why this second part will not be evaluated. That is why the second part will not be evaluated. As a result, what will happen? Sir, the k value initially was 2. Sir, k will persist with 2. K will still persist with 2. Now you are having 1 or something. 1 or something means what, guys? Total result will be what? 1 or something. Total result will be what? 1, sir. 1 or something means total result will be 1. Now to M, that 1 will be given to M. So now what will happen? M will get the value as 1. I is also 1. J is 2. K is 2. Let us verify it, guys. Intentionally, I didn't give you the option. If you think of the options are like this. 1, 1. Actually, if you make any mistake, now that will become my option. 1, 1, 2, 3 is an option. Maybe you can think 1, 1. Because initially, if I give you the option, then what will happen? You may find that, sir, it's very easy to get the output. That's the intentional. I didn't show you the options. Sometimes I will not show the options. Now 1, 2, 3, 3. Let us assume these are the options. Now let's see. As per our clarity, which one should be correct, guys? B should be correct. 1, 1, 2, 2 should be the answer. Let us evaluate. Execute, compile and run. See, guys. M value is 1, I value is 1, J value is 2, K value is 2. That is what we predicted now as per the option number B. Everyone understanding? Everyone got the clarity? So this I hope you people get an idea what actually we are going to do throughout the duration of the course. This is what we are going to do throughout the duration of the course. We will take the problem statement and see. I said, I will not discuss this from the scratch, but even I'm not discussing from the scratch what is happening here. Whenever this operator is come into the picture, at runtime I discussed. Here also, increment operator at runtime I discussed. Here this logical operator also at runtime I discussed. So here it is, answer is B. Explanation, everything not possible to write here, but you will get the video, you will able to watch the video, and whenever you feel that you have to take note according to you, you will able to take the notes by watching the videos again. Otherwise, mostly important things, I will add it here as a note. Okay, let us move to the next one. Yes, guys, this is the code. What will happen in this case? Yes, Modulina, your answer is correct. What about others? Yes, Ritik, your answer is also correct. Tithi, your answer is also correct. Okay, very good. See this one. Here, like the previous case, this time I will introduce logical AND operator. This is logical AND. Zero or zero is zero. Zero or one is zero. Yes, Prashad, your answer is also correct. 1 or 0 is 0, 1 or 1 is 1. This is the logical AND. Now here also you will take one conclusion. What is the conclusion here? See carefully. If the first operand is 0, see, immediately you will able to make the conclusion. Sir, final result will be 0. Anywhere you need to check the second operand to make the conclusion? No. So if the first operand is false, second operand will not be evaluated, as the final result will always be false. Just the reverse of the logical OR. In case of the logical OR, if the first operand is true or 1, you will not check the second operand. In case of the logical AND, if the first operand is false, I will not check the second operand. This is one point we have to take here. Next is that associativity of logical AND is left to right. Associativity of logical AND is left to right. It is also for logical OR also it is true. For logical OR also it is true. Associativity of logical OR is left to right. Let me show you. See this, logical AND left to right, and this is, sorry, logical OR left to right, and this is logical AND. It is also having the associativity left to right. Okay. Now you see here, this is the part where we will show our interest, how to evaluate. Okay. How many logical AND is there? 2. And their associativity is left to right. Then how the expression will be bracketized? Sir, this is one part. Now this is one part. Assume that this is X and this is Y. Now you will have another part. This is this, how it will be bracketized. Now evaluation started. First come here, Y plus plus, post increment. So we will not consider the plus plus. What we will check? Y value. What is the Y value? 10. Y value is 10. Initial Y value is 10. So what actually checking I am here? What thing I am checking here? Is 10 is greater than 9 or not? Forget about plus plus now. 10 is greater than 9 or not? See here. What operator is used here? This is called a relational operator. How many relational operator is there, guys? In C, we are having 6 relational operator. We are having 6 relational operator. What are that 6 relational operator? Greater than, less than, greater equal to, then less equal to, then equal to, and then not equal to. These are the 6 relational operators we are having, right? Important point what you have to remember is that whenever relational operator works, we will get the value, we will get the result as 1 or 0. Whenever relational operator will work, we will get the result as 1 or 0. 1 in the form of true, 1 in the form of true, and 0 in the form of false. Whenever relational operator will work, we will get the result as 1 or 0 in the form of true or false. Now you come here, 10 greater than 9. What is the answer you are getting here? True. True means 1. True means 1. But internally, why change this value? To what? 11. But do you have any awareness now? No, internally it's happening. And you evaluated with what? 10. Is 10 greater than 9? 1. 1 followed by and. Will you go to this half? Will you show interest to go to this half? Yes, I will show interest. Because first operand is 1, na sir. That's why I have to see the second operand. Now you came here. Again here plus plus. Again means what? Plus plus means later I will think about that. First think about the current value of y. What is that? 11. Is 11 is not equal to 10? Is 11 is not is equal to 10? Yes sir, it is a true value. 11 is not equal to 10. So what value you will get here? 1. But internally plus plus will happen na? That will make it to 12. Now what is this value here? 1 and 1. Sir, 1 and 1 is 1. 1 and 1 is 1. Okay, 1 and. Now you will show interest to the second half? Yes. Why? Because first part is 1, na sir. I will show interest to go to the second half. What is there in the second half? Oh, again y plus plus. Na? First think about y value. What is that? 12. Is 12 greater than 11? Is 12 is greater than 11? Yes, it is greater than 11. So what it will return here? 1. But internally y will become what? 13. Internally y will become what? 13. 1 and 1. 1 and 1 means what, guys? 1. 1 and 1 means 1. Now come to the coding. Here, the total part evaluated to 1. If followed by 1. We know na if, when if works. If the condition part after if is a true, then if will work. Is the condition the yellow one, the blue one? This if block printf will execute. And what value it will print? Y. What is the y value it should print? 13, sir. Let us evaluate it. Check it out. This is about the clarity, right, with respect to question. Like every day, 3 question, 5 question. That depends on the length of the question, and that depends on the important the question. What is the important thing I need to discuss? Based on that, number of question will be discussed. Sometimes if it is very easy question, maybe 10 questions. Sometimes so many internal things are there. 5 question, 3 question, 2 question, not 2 question, more than 2 will always be there. At least 3 to 5 question will definitely be discussed each and every day. Like this, today we have started completion of the operator. Like this, at least 3-4 days we will spend time on the operators. Look, actually it is not like a particular topic. Here though I'm talking about operator, if else is coming into the picture. That means what? Control flow is coming into the picture. So it is not possible to discuss with respect to a particular thing only, because all these things are mixed up. Whenever I am discussing about the operators, parallelly control structure will come into the picture. In future, whenever I will go to the array discussion, there are also some if statement, maybe there, operator maybe there. So that's why I said that prerequisite is knowledge of C programming language. And then whenever anything, mostly will have difficulties from here. Pointers, structure, storage class, there you may have difficulties. There first we will cover the theoretical part, whatever needed to discuss this MCQs. and then I will move further from there. That's it, guys. That is it for today's discussion. So note I'm not going to share from today. After few days, I'm going to share the notes. Data structure session is from 6 p.m. That 5 p.m. batch is moved to 6 p.m. now. Satyanarayana. That 5 p.m. data structure batch is not anymore from 5 p.m. That batch is merged with the 6 p.m. batch. Okay, students. Now, if you have any doubt, you can ask me. As because it is the first session, so next 5 minutes I will give you. If you have any doubt, if you have any query, now you can ask me. I think validity, video recordings will definitely be available. I think validity of the videos, I think you can contact to them. I think they give the validity of the video at least one year.